Thanks so much. Senior Associate Dean Jenny Stromer-Galley is here to welcome us and start our second day of the first Syracuse Blockchain and Cryptocurrency Research Workshop. Thanks so much, Jenny.
Oh, the joys of being home on Zoom just never, they just keep on going. I've got a barking dog, a husband saying goodbye. I am seriously sorry, everybody. So welcome. Thank you very much for attending on the second day of the cryptocurrency and blockchain workshop. I am delighted to see that there are researchers and practitioners coming together to really explore and think about the challenges, the opportunities, the technologies, the human impact of cryptocurrencies and blockchain in business and education, healthcare, and in society. One of the things that strikes me about this work is that you're studying and looking at and working with something that is evolving rapidly, and its uses and approaches and consequences are also changing quite rapidly. So it's a hard research space, just as it's also a really exciting area to be doing work and thinking about. We're really kind of at the cutting edge. And of course, I have to thank Lee McKnight for organizing this. When I came to Syracuse University 9 years ago now, he was warm and gracious. And since I have been here in the school, I have seen that Lee is always looking at and thinking about sort of the next cutting edge, or in some cases, even bleeding edge technologies to bring those to our students and to the research community. So I want to take a moment to thank Lee for his vision and his curiosity in bringing this really impressive group of scholars and businesses and the city together to think about these challenges and opportunities with blockchain. I also want to acknowledge Abdullah, who is helping orchestrate this. I know it's a lot of work to put these sorts of events on, so thanks for all of the hard work in making this happen. I'd be remiss if I didn't take a minute in my role as Senior Associate Dean to highlight some of the things we're doing in the School of Information Studies to both in terms of education and teaching, as well as in research on questions and challenges around communication technologies, information technologies, and how it is that humans use and are affected by them in a variety of contexts. So we currently have several certificates of advanced study. We've had a long-standing certificate in advanced study at the master's level in information security, which some of this cryptocurrency research touches on. We also just launched just got New York State approval for a cloud computing certificate of advanced study, which we're really, really excited by. We also have a long-standing information systems master's degree program, and we are one of the first degree programs in data science in the country. So we like to think of ourselves as being cutting edge and doing innovative, new, and important research and bringing that to our students in the classroom. On the research front, I would just note that we have the Center for Computational Data Sciences. I was the director of CCDS until a couple of years ago when I stepped into this really fun administrative job. CCDS does a variety of hosts a number of speakers and conducts research, especially around computational methods in data science, especially human language technologies, like my own research looking at political communication and developing algorithms to classify what politicians say on their Facebook ads. I also want to acknowledge, I should note that Jeff Stanton and Jeff Hemsley are currently the co-directors of CCDS. And I also just want to make mention of the Smart Grids research group that Jason Dedrick leads. Smart Grids and cryptocurrency, the kind of the larger Internet of Things and the challenges that and opportunities really that these technologies are bringing to a variety of different industries is critically important. And Jason's work looking at energy and the technology that goes into energy monitoring and thinking about more effective energy research, more effective energy delivery is critically important. So as you launch into day 2, I hope that it's another fruitful, exciting, and vibrant set of discussions. And thanks again, Lee, for hosting this important day.
Thanks so much, Jenny, and it's been a fun ride over the years, and better you than me for sure where you are now, so I appreciate that on all your service and comments. Okay, so my task right now is just to say a few words summarizing yesterday's first day of the conference to get us ready for today. We had a variety of sessions, roundtables, keynotes addressing a wide variety of areas of research and practice. So I think those participating hopefully all got something from this mix of practical approaches as well as very fresh research, and including also the sort of the policy perspective, legal ramifications, and frameworks. So with I want to highlight Professor Steve Lupine of University of Wyoming's keynote on new regulatory models. The Wyoming case right now in terms of regulation of cryptocurrencies is certainly leading edge for the United States and deserves closer examination and further research and perhaps experimentation elsewhere. In addition, we have wonderful work from Rand, Ariel, Betania, Mike, and Donna was presented on both crypto mining and on crypto markets and related markets. Very, very creative and a wide range of perspectives presented there. So by now, people, if you're here, you understand this is not, when we say cryptocurrency, yeah, we mean the currency, but we mean the whole ecosystem, the whole environment, the complex social, political, business relationships that are growing up in this sector, which one of the points of this is a area of worthy of this study, well, worthy of taking seriously and by scholars in many different backgrounds. And also because it is a new area, as Jenny was just mentioning, there's a lot of opportunities for businesses to learn from each other and also from the scholarly community and the public policy, sort of this collaborative, iterative learning, which is what we're trying to do here. So in that spirit, what time is it now?
8:38.
Say it again?
8:38.
8:38. Okay, so we have 2 minutes. Am I doing good or what? I'm staying on time. Okay, so we're very privileged to have with us from University of Notre Dame is Professor Ian Taylor. Professor Taylor is one of the most, he's at the Center for Research Computing at University of Notre Dame, and he is a co-founder of SIMBA Chain. Maybe coincidentally, a lead sponsor of this workshop, but Professor Taylor is, as I was about to say, a prolific, well-known, very highly cited scholar in the whole broader space of what is now blockchain, cryptocurrencies, the whole space going back through many years, many papers, many accomplishments in grid computing, graph computing, all kinds of very geeky technical things that if that didn't work, then we would not be here because there'd be nothing to talk about, because the whole interface between the chain and the broader computing space would not be secure and reliable. So without further ado, and with many thanks for his coming remarks, Professor Ian Taylor.
Hi, thank you very much. I need permission to share my screen. Could somebody give that to me, please? It says the host has disabled screen sharing. Okay. Okay, thanks. Can you see my screen?
Yes. Yes.
And
Yes.
presumably you can hear me because you're responding. So, okay, great. Thanks for the intro. Yes, my name is Ian Taylor. I'm a research professor at Notre Dame and I'm also a professor at Cardiff University in the UK and CTO of SIMBA. And today, really, the theme of this talk, just go to this, is really on the life cycle of Web3 applications. So what I tried to do is tie some different perspectives together, some research that we did at Notre Dame that actually looks at cryptocurrencies and looks at the accounts in cryptocurrencies to try and gain insights about, auto-detecting certain types of accounts, for example, and also doing some graph analysis to essentially tie wallets together, wallets being the nodes in a graph and the edges being the relationships. So that's some work we've been doing at Notre Dame. At the same time, in the Web3 community, going beyond cryptocurrency, right? So blockchain with the smart contracts has a wonderful ecosystem now of new approaches, new Web3 applications that are emerging in DeFi and decentralized finance and decentralized exchange and so forth. Looking at those approaches, what tools exist now for Web3? And there's a few different approaches there, which I'll touch on, and then I'll describe how SIMBA attempts to solve this problem, essentially by enabling users or programmers to create relationships before while constructing the application and having those integrated into the smart contract. So that provides a schema for understanding the data once it's recorded on chain. And then I'm going to go through some use cases to talk about that. So at Notre Dame, this is the group. We have a blockchain research group. Please, reach out and come and talk in one of our weekly sessions if you'd like to. So Yorick and I run it. We have some programmers, Adam and Sarah, and then we have a number of researchers and PhD students that work at the center. There's a few more that are involved, interns and so forth, also nowadays. So looking at this work, in 2018, we essentially came up with this concept of, well, there's a lot of data in cryptocurrencies, and there's also a lot of data coming onto blockchains from applications through smart contracts. So we asked the question, could we, build a system, really a research platform that could take this data, crawl the data, provide some meaning, format the data in a way that we could actually look at it and do some data analytics on it. And to do that, you need to not only understand the layer, the blockchain layer for extracting the data, but you also have to understand what the smart contract methods and the smart contracts actually do and the relationships of those, those methods to each other. So we created a way of extracting semantic data from those smart contracts semi-automatically using the ABIs to essentially map that to a schema, a JSON schema that we could then use as a basis for the analysis that we did. And then we plugged that, we provided an environment based on Jupyter Hub that enables data scientists to kind of load data, perform different algorithms on the data, and do some fun stuff like research. So I'm just going to go through some experiments that we did using that. So we used about, in 3 different experiments I'm going to talk about here, we did about 7 million accounts in January 2019. This is about 16.5 million transactions analyzed. And we had about 3K accounts flagged as malicious through these various tagging mechanisms like Etherscan and CryptoScanDB. So what we wanted to find out is that could we actually analyze those automatically using machine learning to extract, auto-identify these potentially malicious accounts or accounts that are somehow, differentiate each other from other kind of more conventional accounts or conventional activity. So what we did is we looked at these 7 million accounts. We looked at averages over that month of things like the total number of transactions, average transaction value per month, standard deviation, and so forth. And then we used different machine learning algorithms based on this data to see what they could extract. And the first one we looked at was SVM, which is support vector machine. And essentially this, we told it to say, okay, we want 2 types of accounts. We want, conventional accounts, and then we want the outliers. So we ran this SVM, and a surprising number of outliers we found, so you can see on the right-hand side here, that the blue accounts are the conventional accounts and the red are the outliers. So these red outliers, we correlated those to the known, known list that we had. And there was a very high correlation between what we found and these, you know, the scam sort of accounts that we'd found on, you know, on these different resources. So there was around 6.2 million conventional ones, and then the rest of them broke into various different categories. So we thought that was kind of interesting. So we thought, well, maybe that's a fluke. So perhaps we should, you know, use another machine learning algorithm to see what that finds. But these are the things that it extracted. So extracted crypto whales account, sorry, and then it extracted a whole bunch of mining pools, for example, Nanopool here. And it also extracted CryptoKitties, of course. That was pretty prolific in those in 2019, which it was pretty much just taken off then. So we thought we'd look at k-means. With k-means, rather than asking it to go into two groups, we thought we'd extend the groups a little bit to you know, to see if there was different types of categories. So we created 4 groups, and this is again the, you know, the plot here. The red is the conventional, and then the group 4, the pink one here, was the second, and then it, you know, different numbers, but there was around about kind of 130 extracted automatically here as different from this, which is kind of an interesting kind of you know, interesting that I found those accounts. So then we decided to look at these both. So what we did is we used a normal SVM where we could add labels to it and train it on those labels. So we used about 20% of the labels that we extracted using the k-means. So we trained it on those 20%, and we said, okay, classify the remaining 80% to see what happens. And we found that the SVM, you know, pretty much correlated with the k-means across those. And that kind of showed us really that there is a detectable similarity between the features of these accounts that we're finding and consistently finding. So that was quite interesting. That's just looking at accounts, right? That's not looking at graphs or anything kind of further in terms of relationships, but there are relationships obviously between wallets and other wallets when they transact with each other. And that's you know, what we've looked at here. The other thing we looked at was we moved into looking at graphs. And this was an interesting use case, I felt, that really sort of outlined, you know, what it is to look at a cryptocurrency network as a graph, as opposed to just the transactions. You look at the transactions, it's very difficult to even understand, you know, where one transaction went, never mind when you have, you know, some activity like in this graph here. So what we did is we took this orange account here. This was the hacker that stole the money from the Banco account. They stole $23 million. And we looked at that, and we built a graph of relationships between that hacker and other accounts that transacted with that hacker. So you can see there's one on the right, and then there was 2 transactions with one on the left. But then if you look what happened, the one on the left here transacted to around 150 or so accounts. And then those accounts went back to a single account, which went to another 150, which went back to a single account. At the same time, they went from that second account to another 10 or 15, which went to multiple other accounts and so forth. So essentially what they were trying to do here is cover their tracks, right? They were trying to, you know, make the money sort of flow through the network in a way that it was very difficult to detect, you know, where the kind of transition to fiat was. But representing this as a graph is a very interesting perspective, because now you can see it's pretty obvious where this cryptocurrency went. So we felt this was a very interesting kind of area. And this is kind of an underlying theme. Okay, you can do this for cryptocurrencies. You can build a social network graph, right, of the cryptocurrencies. You can take the accounts, you can take the relationships, aka transactions between the accounts, and you can look at that visually as a massive network and understand who is connected to who and who knows who via proxy between by transacting with some common intermediary, for example. And that gives very interesting insights. And we use this work to kind of look at you know, various use cases you know, over the last couple of years. We're also using neural networks now to analyze these graphs and extract motifs of behavior that are kind of representative of certain, you know, certain types of activity. in these graphs. So with that said, I thought, okay, well, let's look at this kind of more generally. So how would you do this? How would you be able to have this, much fun in research by getting a good data set? Well, to get a good data set from blockchain is kind of difficult because a lot of applications that are written for blockchain, they're written to write certain types of transactions through smart contracts, but you don't really have an insight to, the architecture of those and how they relate to each other. So you need to index that or curate that to be able to make it useful. And just to give an example in Web3 applications, this is Maker on the right-hand side. You can see there's like, 25 or so smart contracts all interacting with each other. That constitutes the system. So these are very complicated systems, Web3 systems that exist nowadays. And there's many of these, in different areas. It's not just DeFi, it's all sorts of different emerging applications that are coming along. So how do you analyze that? So, in order to analyze it, basically, you need to know these lines here. You need to know the relationships. You need to know how they interact with each other. Then you need to kind of understand, okay, what do I want to, look at here? What do I want to test? What's my hypothesis? What is the goal that I want to, do I want to analyze the kind of just the lending and borrowing and see what accounts are involved in those? Or do I want to look at, how the governance network impacts the rest of the system? So there's a lot of kind of ways to look at this and analyze the data. And if this data was available in that form, it would be an excellent kind of, medium, right, for doing all sorts of research to understand these systems better. So to do that, there's essentially a couple of different methods. One I call after the fact. So this is, the application's built, the data is written to chain, and you use some techniques to essentially gain insight and meaning from that and extract the data in a way that it can be used and plugged into other systems. So I'm going to talk about a little bit about a couple of those. Chain trail is one way of doing that, and I'll talk about how we accomplish that a little bit. Another one is the graph, which is a Web3 sort of application that kind of is indexing data 24/7 through a decentralized network and making that available, and that's being used by other applications. And then there's other companies that, of course, like Chainalysis, who are a big player in this space, who have proprietary tools that also do the same. And the other approach would be before the fact. So how do you kind of annotate these, if for want of a better word, so that they can be understandable using kind of relationships that are actually baked in as the application is being created. And this is the approach we take at SIMBA Chain. And I'll just go through what that looks like and how we approach these Web3 applications that we create. So the graph is a decentralized protocol. It essentially has nodes. Those nodes have indexes. The indexes are fed what they call subgraphs, and curators create subgraphs. Essentially, a subgraph is just kind of defining the smart contracts that you're interested in and the data that is coming from those smart contracts. So you kind of like point, you label the data, if you like, through this subgraph mechanism. And then contract events map this data to a database, which is the indexing part, and then a hosted service. So an indexer then is essentially rewarded for running a service that indexes those. And then people, when they query the network, they pay per transaction. And that transaction is split across the network to provide this community-based indexing service. And then the resulting data, this is basically subgraphs of structured data. So they're not graphs as such, in the sense like GraphDB is a graph that you can have, things that point to each other, or you can have pretty complex kind of relationships going on. GraphQL is more of a way of looking at structured data like a JSON object, for example, and sub-objects. So you can use this GraphQL then to query the data and extract it and use it in your applications. That's one approach. ChainTrail has evolved from the what I mentioned earlier, which we use for those research experiments, into sort of a more cohesive system. So so we have three different layers really that are in the system now. We basically have we run 2 nodes 24/7 for mainnet Ethereum. mainnet Bitcoin. We also have written adapters for other networks like Binance Smart Chain and so forth. And then each of those, well, we're extracting the data. We have listeners that extract the data from the mainnet, but we also have listeners that extract the data from the mempool. So you can basically analyze data coming from these networks before they've been transacted, if that makes sense. So as they're in the queue to go in the networks, you can see what is about to happen using the mempool listeners. And these listeners extract the data from chain, and they have connectors that can put the data in different formats, so they can write it to a DB, and we have a Postgres DB that is basically caching all of this data. And then we also have extractors for JSON and CSV as well. So these then plug into this layer, which is underpinned by Redis, which essentially enables this processor methodology. So you can plug in a processor that listens to a stream of data from Ethereum, takes it in, does something with it, and outputs, whatever that processor intended to do. So, for example, you could, we've written processes that look for whales, right? So you give it a threshold, it looks for transactions coming in the network, and it looks for whales, and it will notify you when a whale comes into the network. And we've also used this to create graph processes. So again, you look at Bitcoin or Ethereum. You've taken the transactions, and then those transactions you're parsing, and you're understanding the relationships between the different wallets, and you're creating a graph dynamically from those relationships to create a big graph of all of the network and all of the accounts and how they relate to each other. And more interesting experiments, if we go back 2 slides, things like Maker. Well, we didn't look at Maker yet, but we looked at Aave, which is equally as complex. And we created a processor to look at Aave, look at the different smart contracts. And we have a mechanism for metadata extraction. So we essentially take the smart contracts, we look at the ABI, we auto convert that API into a structure, and then we annotate that structure about what we're interested in. And that can be used to create graphs of relationships, or it can be used to just analyze specific parts of it. And that's a way that we can, gain insight into this. Which is kind of like the graph, but it's a little bit more complicated because we can really go down and build sort of complex relationships there for further analysis. Okay, let's go on to SIMBA chain. So SIMBA chain was born in 2017. I'll say a bit about it where it came from later, but really the goal is to make it easy to use blockchain by providing a common language for applications to interact with. It's kind of like a Babel fish for blockchain, in the sense that you can really talk to these different complicated systems in a way that is very familiar to everybody who's programmed. So essentially, our abstraction bubbles up to a REST API layer, and that kind of wraps smart contracts. And it just provides a very kind of easy way with simple posts and gets. You can interact with a blockchain without really understanding the specifics of the underlying blockchain too much. And there's a lot of tooling to make it that simple. There's a lot of tooling surrounding that enables that kind of level of functionality. And I'll touch on some of those points, but we have a limited time here, so I'll just go through at a high level. So SIMBA chain came from, it was born in 2017. Essentially, I started as a research professor in 2016 at Notre Dame, and a local company, Joel Neidig, wanted to put in for a blockchain call from DARPA. And I just joined and didn't know much about blockchain, but I thought I'd give it a go. So I wrote a proposal and submitted it, and it was successful. So that kind of led to this journey of blockchain. And what we found, we were using Hyperledger Fabric in those days in 2017, 2016, actually, that grant started. After kind of looking at Fabric for a year, especially around that time, it was very fluid. The APIs were changing. They were even changing, the communication paradigm to gRPC from the previous connectivity and things like that. So things were changing a lot. And we felt, this is a lot to deal with if you're writing an application and you want to kind of build something stable. So we ended up creating an API to the blockchain to kind of abstract it for that project. And then we looked at Ethereum, and Ethereum in those days also was pretty complicated. You need to understand wallets, you need to understand asymmetric crypto systems and hashing and all this kind of good stuff to really sort of understand how the system worked and understand really how to interact with it. And in terms of the smart contracts alone, you know, that decentralized nature of them, being able to essentially transact at any point in the system, to understand the memory model and how that works and what is recorded on chain and what is recorded in these different, you know, other stores that go alongside chain is pretty complicated. So what resulted in that was Joel wanted to do something in this space in terms of a startup. So I said, well, let's try and, you know, take that incredibly complex process where you literally have to spend about a month getting your head around this to be confident as a programmer to build systems in a, you know, in an appropriate way, reduce that to, you know, to minutes if possible. So we set that goal and we created this SIMBA chain platform that really makes that whole process very simple, and, you know, non-blockchain people can basically create smart contracts and do all this good stuff, and developers can then you know, take their existing smart contracts and plug them into an environment that really removes 99% of the headaches that they have in terms of creating production applications. So we have this deployed across universities in the country, and, you know, this is we have a tool which I'll touch on, which people use to create smart contracts. People from, you know, business schools and those students are creating smart contracts using SIMBA chain, and they've never written a line of code in their life, for example. So how does SIMBA chain work? Well, this is the basic flow. So this is a supply chain use case. We take in what we call assets and transitions. An asset would be, in this case, a parcel, so something we want to track, and transitions would be how that's tracked through different geographical locations, different modes of transport and so forth. We take those and we specify the relationships between those. In this case, there's a relationship between the transport and the package and the geographical location of the package, right? And they relate to each other. So we build those relationships into the smart contract, and we annotate kind of smart contract methods to do that, and have pointers from one method to another so that we can tie this data back together. So when we record on chain the data, these relationships are already baked into the chain, and that makes it very simple to understand that data later. And we have implementations in GraphQL to query that, which is great, but it's a bit limited for complicated use cases. So more recently, we've actually been looking at doing full GraphDB. So we're using Neo4j, for example, and we can do seamless on-chain, off-chain querying using GraphDB. So essentially, like the off-chain data is in the graph. Another graph annotates the on-chain data using this methodology, and then we tie those together to make it a seamless kind of system to query. So looking at that a little bit more, so essentially this model is based on assets, which are basically the nouns or the things you want to look at. An asset could be a token, for example, and a transition could be a transaction of that token from one wallet to another, or an asset could be, a tail hook from an F-18, and the transitions could be, well, how does that move through the supply chain? So we can use this in very different ways, but we use these basic concepts, and those concepts are specified using tools that we provide, or they can be just added after the fact. And then we can also generate smart contracts from these relationships as well, and then generate REST APIs to them, and those can be searched using GraphQL and other graph database means. So this is what our tool looks like, which is our smart contract designer tool. So the red rectangles here represent assets, and the ellipses represent the transitions of those assets. And so here is an additive manufacturing example where a component which is printed, which is manufactured here as one transition, is delivered somewhere, received somewhere, and then installed somewhere. And this additive manufacturing component refers to a design, an STL file, and that design can be updated. So this is a simple sort of like, mock-up of an additive manufacturing scenario. Each of these boxes, you can double click on them and specify the parameters you want for each of those assets or transitions. And then once you have that, you built this model, you click go, and that basically creates, in this case, Solidity, for deployment onto a blockchain. And to deploy it, you basically, on SIMBA, you choose the network type. We support 5 different types of blockchains, around about 9 different networks or so. Or maybe it's actually 8. No, actually, there's 9 different blockchains. So there's 15 or 20 networks, actually. So we support things like Ethereum. We support Stellar, which is very different, of course, RSK, Binance Smart Chain, Fabric, Consensus Quorum, and so forth. So there's a number of networks we support. So you choose the network you want to deploy it on, click Continue. Sorry. Okay. Click Continue. Then you can integrate with off-chain data. So if you want to attach things like files with your data, you can just choose off-chain, choose the file system, and it will automatically put the file in the file system and generate a hash of files, or multiple files actually, to go into your transaction. Then you choose the smart contracts you want to deploy, and in the SIMBA enterprise platform, you can choose multiple smart contracts per application. You give it a name, and that name becomes your URL, which you communicate with. So what you end up once you deploy a smart contract is a number of get and post methods for those different smart contract methods. So doing a post to that method puts data on chain, and doing a get does a query from the data. And then we provide these Swagger and RE-doc interfaces to auto-document those APIs. So you can very, very quickly, like in 5 minutes or so, mock up an application, deploy a smart contract using SIMBA, and play around with it. And that's what these students kind of work on. And I can't touch on this too much, but this is our SIMBA Chain Enterprise platform. And like I said earlier, to achieve this level of simplicity, it's actually a very complicated system you need to build, to support all of these kind of features. So this is our overview of the different components. And this is an enterprise platform. So on the outset, you have auth. So we use auth too, and we bind to Active Directory. We also bind to CAT cards for the DoD application work we do, which is the cards that the DoD people have, to access systems and so forth. And then we use the SIMBA chain model as a basis for some of these tools. We have the smart contract designer I just showed you, the virtual API I showed you. And then we have this level of resilience and validation that we have. So transactions come in, we check them, we put them in an asynchronous queue, we wait until they're transacted, and we get a receipt before we continue. And the queue is dynamically kind of created as and when needed, depending on the load coming into the system. On the back end, we crawl the blockchain, create a cache so that we can search the data super quick. The transaction cache is generated 24/7. It's generated upon input, but it's also validated 24/7 to ensure it's consistent. And then the search is either searching endpoints like you would in a relational system, or you can use the graph tools that we provide. There's a dashboard that ties all this together, which I'll show a little bit in the use cases. SDKs build stuff from any language off-chain, and then subscriptions. You can essentially add a subscription to any transaction. So you can say things like, okay, on this smart contract method, I want to track this part, and when this progress of this part, which is a parameter in the smart contract method, is greater than 80%, can you send me an email? And you can do stuff like that, and the subscription will just send you a notification based on certain conditions. Okay, so we won some awards, which was a lot of fun. This one on the left was really, really a lot of fun. We put in for this additive manufactured competition, and Boeing and Stratasys were in the final, and SIMBA Chain won. So the little guy kind of was victorious. That's Joel there with his hands in the air, a big moment. But okay, so let's look at some use cases. I have about 10 minutes left. So I've got 3 use cases I was going to touch on that kind of provide some examples of this, the SIMBA chain approach, if you like. The first one is in DoD. So we have a project with Notre called Ricart. And this essentially is tracking parts from OEMs. So we partnered with Boeing for this project. Boeing makes all sorts of things. This image here, this person is inspecting a tail hook. So that metal bar there is the tail hook from an F-18. So that catches the aircraft when it lands on an aircraft carrier. So we've been monitoring those, the tail hooks, and we expanded the use case to the wings of an F-18 too. So essentially Boeing make these, they actually don't make tail hooks, they subcontract them, so they go to a sub-tier, but the wings they make. And so what Navair wants to know is, okay, we submitted this PO, this order to Boeing. And we know roughly it takes, I don't know, 6 months, a year or whatever for these to be made. But we want sort of insights, maybe the schedule goes faster, maybe it goes slower, there might be issues. So can we get like a progress indicator really of where they are with this particular order? And there's no real insight to that right now. So what we did was to create a blockchain connecting OEMs to Navair. And then we shared data on that common blockchain, which Boeing introspects their own systems, and they provide this data through the blockchain, the data that they want to provide to satisfy the requirements of this use case. And essentially that is, okay, we're making this F-18 wing, we're about 20% of the way complete, and this updates every periodically, so every day right now it updates. There's a paper here, I'm going to share these slides after. This paper is a very detailed 35-page paper of this use case if you want to learn more about it. But at a high level, on the bottom, this is the what they call an MRO flow, which is the maintenance, repair, and overhaul of a tail hook in this case. And essentially, just to give you an idea of what goes on here, you have the aircraft carrier. There's something goes wrong with the tail hook, right? So they have an O-level guy who extracts the tail hook and looks at it. If they can't fix it, they pass it to an eye-level. The eye-level has a machine shop on board the aircraft carrier. They try and repair it. If they can't repair it, they send it to FRC Southwest. So there's transport then going to FRC Southwest. FRC Southwest then overhaul it. And then once they finish overhauling it, they send it back to the carrier using a transport means. And then they send it to the O and I level at the carrier, who the I level inspect it, the O level basically reinstall it back onto the aircraft. So that's kind of the operational flow. But when they're at FRC Southwest, they might want to, as part of the overhaul process, they might want to order parts. So there's different springs and so forth within the tail hook that they would order from Boeing. So you could track at that level. Or track kind of the progress more in a more granular level. So the system supports both modes, but the more sort of higher level mode of wing percentage complete is being used right now. And to do this, obviously the DoD network and the OEM network, there's issues of privacy there. And the way we solved that issue is we created actually two blockchains. We had an OEM blockchain that was implemented using Hyperledger Fabric. So Hyperledger Fabric nodes were set up at Boeing and connected, through SIMBA chain. And then the DoD network, the data on that use a different smart contract to monitor the internal operations, and that was done on consensus quorum. So we connected these two networks together, and I just wanted to talk a bit about how we did that. So in terms of the graph model that we use for the relationships that I talked about earlier, we actually use that to do high-level concepts too. So we use it for versioning and for connecting blockchains together. And essentially the way that works is, for versioning, when there's a new version of smart contract, the old version doesn't go away, right? It's non-reputable, it's written into the chain. So the new versions are created, and we can link those back to the older versions to make it seamless. So you query a new, the latest version, and that automatically queries all the other versions it knows about, because it's just a part of a graph of the data that a person is querying. And then for blockchains, we can link transactions from one blockchain to another by connecting essentially methods and variables on smart contracts across chains and link them that way, and that provides that relationship which connects the data together. And then the outset, the result of that is that you can have data on two different blockchains. In this case, now they have their own data. They have the data flowing back and to from the OEMs. They can query both of those, but Boeing can only query the OEM network. So that's how we use the relationships then to connect different blockchains together. And these are examples. So this is like on the left is smart contract to to track work orders as they go along the MRO pipeline. And then the OEM network is on the right-hand side, which basically connects these different, PO things, the orders with the different kind of progress indicators from the OEMs on the progress of those orders. We also connected this to a third blockchain recently. So we had the Fabric and the Quorum connectivity that I just discussed, but then we connected that to data that we got from another project where we ingested publog data, which is open source data that describes OEMs, contracts with OEMs. So you can extract all sorts of information like zip codes and addresses from OEMs and other parts they make and so forth. So we actually connected all these together and had 3 blockchains connected together where we could query that and extract further information from those, which is quite neat. And then to query that data, we use GraphQL, and we have this intuitive user interface on the left. We click the supplier part there, and that gives us the green ones are the ones you can click. The orange ones you might be able to click depending on what you click next. So if you click a part, then you do have a relationship to the part extra detail. So you basically can intuitively select what you want to query. On the right-hand side, you choose what you want to extract and the filters for those. So you can filter on, say I want to extract, all the data with a nen equal to such and such. And then that provides the data in a structured way. So you have the top level of the graph, and then you can click through, just clicking the blue links here to click through to the next level and clicking on another blue link to go to the next level and recurse down the tree. Okay, the next use case, I just have a few minutes left, so I'm going to just whiz through this. So we have a production application now in Mexico with Tokes. Tokes has about 230 restaurants across Mexico, and they were providing sustainability to the farmers. They basically redesigned their supply chain to essentially provide a lot more income back to the farmers, and they're working with the farmers directly now. But they couldn't really advertise the fact that they were doing that because putting sustainability on a packet, according to a survey they did, means that 75% of the people wouldn't believe it. So what they wanted to do is, and this video is a trip that we did to visit those. What we did is create a blockchain application that tracks the coffee as it comes from the farm. So in this case, a farm will bring in a bag of coffee from the farm. They will choose the name of the farm. They will choose, put in things like the weight of the coffee, the amount of bags of the coffee that came in, and so forth. The type of coffee. They also do a humidity test, all of these kind of things. And then they sign the document, which you'll see in a second on the app on the right. Once they sign the document, we generate a barcode for that coffee. We put the QR code. So we put the QR code on a bag of coffee, and that is registered on chain also. And then as it goes through the supply chain, this app is used to track that bag of coffee. So it goes to the desheller. So the beans, when they arrive, they're just in the shells, the green beans. They go for deshelling. They come back. There's a new weight, right, associated with that. They come back from the desheller. They go to the roaster. They go through the different. They get roasted. They get ground, and then they get put into bags, and then they go through to the different restaurants across Mexico. And to do that, we integrated with a warehouse management system, and that essentially provided as a means of connecting into their system and tracking across the entire chain. And to do that, they just simply used an adapter on the WMS system to talk to our REST APIs that we generate. And because we're using standards, they didn't have to write any code to do that. So that was a simple integration. So this tracks the beans from the source to the restaurants. And now COVID is somewhat easing in Mexico. They're able to open the restaurants. We're actually kind of looking at creating an app now at the restaurant so that people can identify the coffee they're drinking and read a bit about the farms that it came from. And then the last thing I'm going to talk about is the NFT stuff that we're working on right now. We're about to release a marketplace, which is based on our platform and using the same kind of paradigm. We're making it as simple as possible. So 1% of the people on the planet have cryptocurrency right now. So what about the other 99% for sports teams, for example? So we've made this marketplace very simple. It's a simple way of registering, creating, so bidding and paying for NFTs using conventional sort of, currency systems. We're going to support crypto as well, but we're basically, you can just pay with a credit card at ACH for the NFTs, and we have a choice of all of these different blockchains we can support, and we chose for this particular launch to use Avalanche, which is a green chain, and it's, it doesn't use proof of work. It's very green, it's very efficient. You get finality in a few seconds. So that's the structure we've used, and what we've done with the NFTs here for those who have been working in this area. Obviously, you have a NFT, you have the metadata, which is a JSON structure of information that describes the NFT, which is generally stored off-chain, HTTP or IPFS or so forth. And then you have the URI to the media itself. Well, we've actually taken that, we've baked all of that on-chain. So we're using a data URI. We've got the data, the metadata baked into that URI on-chain. So it's in the smart contract. So there's never, there's a fail-safe mechanism, non-reputable means on-chain for proving that you have access to that content. So we also include a cryptographic hash to the media in that metadata. So you have absolutely fail-safe proof that you own that particular media. And I think that's all. Thank you very much for, and this is some members of our team, which has grown quite a bit more than this recently, but thank you very much.
Thank you, Ian, for your insight on SIMBA chain and others. I just have a couple questions.
Sure.
So is there a point where blockchaining something adds too many complications? And where's there the happy medium?
Yeah, I mean, we always, when we approach any use case, we always ask ourselves the question, why blockchain? What is the purpose? And for example, in the DoD, you could, if you wanted to, you could track every part that goes around the system, but what's the point, right? There are millions and millions of parts flowing around the DoD. However, the ones that are flight critical, right? They're the ones that you want to track because they mean, loss of life if something goes wrong with those, or they can't be, replaced in time. So we always kind of ask that question, and I think there's a balance between what you put on chain but also how that integrates with the rest of the data out there. And that's why we have, things like the graph approach, which provides access to all of the data as if it's a single system, but only part of that data is actually tracked on chain. So that balance is, you really have to kind of look at that for efficiency. The blockchain isn't for storing everything.
And then have you seen or derived any approaches to help track global warming?
No, we haven't been. Well, we had a project a while ago looking at tracking kind of microgrids. So, for example, if somebody had a solar panel farm or whatever, and they wanted to provide that energy locally to other consumers without it going back to the grid, we provided sort of a token-based mechanism to prove how that could be done. So we've done some work in that area, but that's really all we've had the opportunity to do so far. But I'd love to do more in that space for sure.
And then I'm going to open the floor to any questions. Just type them in the chat or raise your hand to speak up.
I'll go on up. So that was fantastic, Ian. Thanks very much for your remarks. I mentioned your work on graph computing is really like central, I think, to seems like everything you're doing here. That's an area of knowledge that is not that widespread. So could you say something more about that? Like, is graph and blockchain as like sort of a natural marriage? Because there are other ways to, again, represent and link data, not using graph theory. Could you just say a little bit more about why? Well, it obviously seems to work because of how fast you've been able to move in just a couple of years. But over to you.
Yeah, I mean, we kind of stumbled on the graph aspect from two different directions, actually. So first, this idea of this assets and transition model, we had that from the outset of start of SIMBA chain, and we tried to use that to provide a way of specifying relationships. At that point, we weren't thinking it was sort of a graph so much. We were just thinking it was a convenient way of specifying the business processes in an application. But of course, it's a graph. We didn't realize it. So that became a graph kind of after the fact, and we integrated GraphQL in order to formalize that into a schema. And then the other side of from Notre Dame, we were looking at that Bancor use case, and we weren't looking at that as a graph initially. We were just interested. Okay, we knew this account was the hacker's account. So we wrote an algorithm. Andre actually wrote the algorithm to look at the neighbors and look at the neighbors' neighbors, and that's what created the graph that I showed you. And then after looking at that, I was like, that's amazing, right? So it's so intuitive to look at the data that way. And in terms of cryptocurrency, it makes perfect sense to have a graph, just like Facebook has a social graph, right? That connects every user to you have your friends, you have people you follow. They're all nodes and edges in a social network graph. And this is a very natural way of representing cryptocurrency. And if you look further down, if you can specify those relationships up front, as SIMBA chain attempts to do, then it is a natural way of querying the data, because you're querying your assets and the relationships of those assets across the lifetime of that asset. And that is very much a graph way of looking at things. It's a relational way of specifying that would look very, very different, and it would be multiple queries. So it just seemed like a very natural fit for the types of applications we were looking at. If that makes sense, I don't know.
And then there's one more question in the chat. What are your thoughts to keeping NFT media on chain, IPFS maybe, versus off chain?
Yeah, the media itself is a tricky one. We had a lot of internal conversations about that. Putting the media on chain doesn't make sense, because if you look at a high quality image or a video, I mean, it's just blockchains are not designed to store that much data. I mean, putting like a megabyte on Ethereum would cost thousands of dollars, right? So it's not really designed for that storage. IPFS is used a lot to do that, but really the way we looked at it is the authenticity of the NFT is the key part, right? So the media you can have, if you buy an image or a video, and you have that image in your possession, you need to prove that image, you own it, right? And that's what the NFT gives you. So the way we approached that was, okay, the media really is decentralized, right? The person who buys the NFT has access to that media, and they own it, and they can prove they own it. So the proof part is the piece that we focused on. And we felt that this ERC 721 metadata, URI to JSON object that lives off chain, it's really kind of introducing centralization into a inherently decentralized process. So that's why we felt that the metadata should go on chain, and also a cryptographic hash to the media should go on chain also. So you can take your media, you can generate a cryptographic hash, and you can compare that to what you have in your NFT. And if they're the same, it's absolute proof that you own that media, right? Because that's written in a non-repeatable way. So the media, yeah, you could store the media on sidechain. It depends on how you want to consume it. If it's, imagine if it's an image that is a one-off. Well, there should be a way of creating, providing that one-off image to the purchaser, such that only they can possess it. Nobody else has access to it. So in that case, you wouldn't want to put it out there on a sidechain or anything. You're basically passing it to the owner. But if it's something more general and it's open to the public more generally, well, it could really be anywhere. The key part is the metadata that ties that, because the metadata is the kind of connectivity between the NFT and the media. I hope that answers the question.
Yes, thank you.
Yeah, thank you.
And okay, first, obviously, I'm not Professor Deidre Hodges. Deidre, at her new university, Florida International University, has been called into a meeting with her dean. She's been there all of about 2 or 3 days, so I understand why she did not say no to her new dean. But in any case, I am Lee McKnight. I'm very pleased to be moderating this panel on blockchaining cyber physical communities. We'll be presenting a variety of work from across the country, literally. And we'll start off with Professor Pardis Pishtad-Borozgi of Georgia Tech about a supply chain, an application of blockchain for supply chain. I think I said the words in the right order. Thanks very much. Over to you, Professor.
Hello. Good morning, everyone. Lee, thank you so much for the introduction. I very much enjoyed the workshop and the great presentations and the roundtable discussion. Let me share my screen. All right, let me put it in the presentation mode. All right, can you see my screen?
Yes.
Yes, great.
Yes, we can.
Perfect. Remind me, how much time do I have?
Yes, you have about 10 to 15 minutes. Yeah.
Okay, so I guess I will count on 15 minutes. I don't think I can do it in 10 minutes, but I'll do my best. All right. My name is Pardis Pishtad-Borozgi. I am an associate professor in the School of Building Construction at Georgia Tech. So my presentation is slightly from a different point of view, given that I am coming from my background in architecture and building construction. I want to share with you the result of my research on how blockchain technology can be potentially applied in the construction industry, specifically to address the issues in construction supply chain. So the contents of my presentation include first an overview to the construction supply chain anatomy, and I will discuss challenges associated with the current structure of construction supply chain. Specifically, I highlight 4 issues, which basically translates to 4 use cases or opportunities for blockchain applications in construction supply chain. Then I will briefly share some successful blockchain applications in other industries. In addition to financial industry, I would discuss the applications in food, healthcare, and insurance, and then conclude with a framework for blockchain-enabled construction supply chain. In the construction supply chain, there are various stakeholders involved, starting from the customers, end customers or owner, which is in the upstream, is considered as an upstream stakeholder. And then we have the construction entities, we have the design and engineering professionals, and then we have the downstream stakeholders. We have material providers, laborers, and equipment supply chains. And as you can tell, there is an it's a very complex system, involves many individuals, and given that construction projects are unique, it makes it even more challenging for the parties to establish trust and to have a standardized procedure for exchanging or collaborating in a particular project. So every project is unique. We have a new set of stakeholders, which makes it very challenging for them to be able to trust and collaborate in a project. So given that, there are challenges associated with this construction supply chain. The first one is due to the linear communication channel that exists. So let's say if there is an owner's initiated change order here, or an RFI by the architect, by the time that this information gets communicated from architect to the GC, from GC to sub, and then supplier, and then from them to then, you know, provide that information back to the architect, it's gonna take a long time. And then in addition, due to the number of people who are involved in these data handoffs, there is a high risk for data loss and data error in every exchange. The second issue, again, back to the linear communication trait of the supply chain, manifest in payment delay. So in this graph, we are showing how once the supplier is finished with their service, they submit their invoice to the sub create application and certificate for payment and continuation sheet, which shows their progress. They report it to the general contractor. They do the same. They review, consolidate all information, invoices that they receive from subs, approve it, create their own application and certificate for payment, submit it to the architect. They review and sign off, and then the owner. So this chains, the supply chain of the data flow, it takes a long time for it to get to the owner, and by the time it's in owner's hand, owners may not be able to even trust the originality of these documents or the accuracy of these documents, which was initially shared by the supplier here. And then once the owner approves it, then they have up to 15 days to release the payment to the general contractor. And then for the general contractor to, again, they have 10 days to share the information, make the payment to their subs. And then for the subs, again, they take them up to 10 days to make the payment to the supplier. So if you add this 10, 10, 15, it's minimum 35 days by the time that the owner released the payment for the suppliers to receive their payment. And this is in addition to the days and months that take these supply chain participants to review and approve these invoices. So typically in a project, you know, it takes the suppliers up to 3 months after they deliver their services to get paid. And they are charging the owner for this delayed payment, and the owner, knowingly or unknowingly, is paying interest in this in their project for this delayed payment. So that's a very important issue, given the magnitude of the construction industry, as how much money we can save just by expediting this payment. Then the third issue is related to information silos and lack of transparency and traceability in the current supply chain. So as you see, every stakeholder is functioning in their own individual silos, and if you know, they manipulate the data and they change the data as they pass it to the next stakeholders, and if there is any counterfeiting involved for a specific asset or material in the construction, it's hard to know where the manipulation of data took place. And if there is something, if there's a structure failure, let's say, or if there is a claim or dispute, the forensic analysis to go through the documents and find where things went wrong or where the error occurred, it's a costly, very time-consuming process. And the reason for that is because of the lack of transparency and traceability in the current supply chain. So again, that's another problem. So the fourth issue is related to the procurement process or the bidding process. So currently, when the GC, they develop their tender documents and invite the subcontractors to submit their proposals and price for scope of work, then the subs submit their prices, they communicate it to the general contractor, and the general contractor, once they know the price and the scope of this subcontractor submission, they can use those knowledge to share it with their preferred subs to further negotiate and give them the contract. And that may be perceived as an unfair process to the subs who trusted the GC to share their price and info. So again, how can we make the bidding process more transparent and fair to the subcontractors to avoid the game of negotiation? I mean, the contractor can always go back to the awardee and further negotiate, but we're talking about how we can eliminate this gaming process of bid procurement. So now that we know all these 4 issues, let's take a look at successful applications of blockchain in other industries. I'm going to go first with the pharmaceutical industry. So currently, blockchain application has been used successfully in pharmaceutical industry to ensure the patient, the doctor, about the originality of a medicine, so they can see the journey of the drug or the medicine through the supply chain, which manufacturer built it, where was it stored, the distributor, all this information can be seen in an app, and the patient and the doctor can trust that this is not a counterfeited medicine or drug, and it's actually original. The other thing that I want to add here in pharmaceutical industry, the doctors can also use it to ensure that the patient is not getting drug from different doctors, and basically to avoid potential overdose. In the food industry, IBM Food Trust, basically the end customers can ensure the safety and quality of the food, and the agencies can put in blockchain the certificate of food inspection and its compliance. And if it's organic, again, the certificate of organic, that it's an organic and the product, and the customer and the users, they can see where this food is actually coming from which farm, and all the detailed information about the supply chain journey and the certificates of safety and quality and compliance all can be trusted and seen. Next is in the insurance industry. Once the terms of the policy are agreed by the user and the insurance provider, these are hard-coded into the smart contract and cannot be changed without all parties knowing. So once the event triggers insurance policy execution, the smart contract policy is automatically executed based on the pre-agreed terms, and the payment is completed instantly and efficiently. So these are 3 examples of successful applications of blockchain in other industry. So last is I want to just conclude with how blockchain can be utilized in the construction supply chain to address those 4 issues. So the first 2 issues were related to the linear communication channel and how lengthy is the process of data exchange and the risk of data errors or data manipulation and data loss, which can be addressed by blockchain. The immutability of data in blockchain eliminates the risk of data loss and data errors and data manipulation. And then fourth issue was the smart contract, which basically for delayed payment, contract can be utilized to regulate or develop the digital rules for payment and release the payment and make the parties gets paid instantly as the performance of contract is satisfied. Basically, I believe that there is a great opportunity in construction supply chain that has yet to be realized. And currently I'm working with RB company who is sponsoring my research on this area. And I want to acknowledge their contribution, as well as I want to thank my PhD student, Jung Han Yoon. And with that, I'm going to end this presentation and open the floor for any questions or comments. Thank you.
That was a lot of information that you threw out there. Looking at it, you know, some of the people that we work with in our group are on the smart city side. I see a lot of correlation there. The one big difference that I see is there is difference between transparent data and open data. Do you see a way for outside input into some of these construction projects? Say like from a community point of view?
So can you be more specific? I'm not sure if I understand your question.
So a lot of times you have construction projects that are pretty large in scope, and they will do they'll do some research, but a lot of times it's in-house or pretty specific. And then when it's kind of sprung on the public isn't really happy about it. And then there's a lot of back and forth, a lot of times at public forums. I think it might be an advantage for blockchain to be able to receive information from the public and show how it was addressed, or you know, giving it more of an openness than rather just a transparency. Because transparency means you see what's going on, but openness means you actually have a dialogue, right?
Yes, definitely. So I think what you're bringing into equation is the actual end user. By public, are you referring to end users and end user satisfaction? And how? Yes, definitely. And just like how in the food industry, that can be also is factored in customer satisfaction of the product and as a feedback loop to the designers and builders to see you know, how their products or assets are perceived by the customers. And transparency, obviously, it is not, it can be transparent to the people who are authorized to see the information, obviously, and I didn't mean to imply that it's transparent to everyone.
Right.
Yes.
You know, you were clear. I'm just making the distinction my own. The other thing is, how does it address, you know, a lot of times with contractors and these kind of projects, there's past performance. So, you know, you've got a self-contained project here, but how does it address going from project to project to project?
Oh, I really love this question because I actually thought about it as a potential opportunity for how blockchain can change the industry and the performance of the subs, because you know, different subs perform, you know, work for different contract owners or contractors, and how can we develop a system that actually records if, let's say, if this subcontractors has an identifier and how they perform is it can be actually tracked globally. And if we have a let's say a public blockchain where these contractors are functioning, subcontractors are functioning, and this information is tracked, then it would be much easier to shortlist the qualified subcontractors or see their records from all their past projects. So again, this is kind of vague yet, I think, in my mind, but I think there is a potential as how this traceability can bring more light into the performance of subs and contractors.
Thank you very much. I appreciate the response.
You're welcome. Thank you. Great questions.
Yusuf, are you ready?
Yes, I am.
Okay, so Yusuf Abdul Kadir will be next up.
Thank you very much, Lee. And I'm sorry that I have to rearrange the agenda for today. But being the youngest, I kind of take the privilege of doing that. And you can just call it a sense of being spoiled. So my presentation today is really on how do we think about smart cities in a very different kind of way. This is a conference on blockchaining, and really, I think as we think about the ways that our colleagues have talked about yesterday and indeed today, about the various ways that the leveraging and using blockchain as a solution for a variety of challenges is really, really important. And I think that same type of thinking has to be applied to how we understand smart cities in particular. And I want to give a little background because we are all familiar with the IoT revolution. We're all familiar with the connectivity of devices everywhere. We're often familiar with smart watches and smart sensors that are proliferating everywhere around our world. But we're very rarely focusing on the ways that our existing technologies build on existing infrastructure and how that existing infrastructure is designed and has been designed in many ways that have been discriminatory. And so what I'm going to talk about for a little bit is the kind of convergence between the IoT revolution and legacy discrimination. And I want to hone in specifically on the legacies of eugenics, the legacies of racism and other forms of discrimination and bias that are entrenched across systems and structures in our society. Things like redlining, right, which is a federal policy, federal housing policy that enabled for there to be a mortgage-backed mortgage-backed by the federal government in ways that helped get us out of the Great Depression, but were really, really, really discriminatory towards Black communities, referring to them as infiltrations in the ways that you would think about your home being infested with bugs. And because they were considered to be negative and the perspectives were perceived to be, discriminatory in effect, what we wound up seeing happen are those communities not being invested in and really facilitating and driving the kinds of reemergence of de facto segregation. Again, we are in Syracuse, New York, or you all are in Syracuse, New York, which is in Onondaga County, which is the 9th most segregated county in the country. And so when you think about the ways that eugenics and racism, other forms of discrimination, espoused in policies like redlining, the realities of segregation, the consistent concerns of environmental racism and inequity in transit, all the things that, by the way, a smart city would be capturing, right? Smart grids would be wanting to know about how much electrical flow is going between different homes and how do we optimize usage of electricity, right? Smart cities, as we're told, wants to know about how do we make sure bus sensors are distributed in a way so that you can have rapid bus transit so that people can be able to more effectively get transported without thinking about the ways that these policies are intimately necessarily driving opportunities for some communities against others. We're not thinking about, well, what about a community that was redlined, that is outside of the normal bus rapid transit mechanisms, and therefore they're unable to benefit from what this application of a smart city technology would be. What about in this context that we'll talk about today, people with disabilities? And I say this, and if I meant to grab a prop, so give me 1 second, I apologize. I say this because my mother is visually impaired. She has a walking stick. And as I began to think about smart cities, and if you're at Syracuse University, I encourage you to go to the Shine Student Center right across the street from Sheraton Hotel. And what you'll hear is an alert telling you, if you're visually impaired, that you can cross the street, right? But I now live in Baltimore, New York, and I tried to walk around Baltimore with my mother. And if Baltimore were to be a smart city, wouldn't it be important and essential for my mother's ability to navigate Baltimore, right, to safely transport herself from place to place, that there was an ability for her walking stick to communicate with that traffic signal to let her know that she can wait, that's connected to GPS technology that helps her orient herself around the city. And I say this because if we think about smart cities, we're very rarely thinking about applications that benefit people with disabilities, right? We're talking about bus rapid transit and the ability for creating efficiencies and how the bus schedule operates. We're not thinking about the fact that there are people who have physical and developmental disabilities who may not be able to benefit from that. You know, a lot of my research is also centered on the ways that bias is baked in to how we both leverage smart city and IoT applications, whether it's the introduction of a street camera system that is leveraging facial recognition technology, and the way that we have historically operated under surveillance and bias towards civil rights organizers and activists. If we're not thinking about smart cities in ways that are explicit to focus on how legacy discrimination and legacies of bias are all around us in society, then what we're going to be doing is creating more efficiencies in how we can facilitate for discriminatory practices against people. And so I'm going to pause there to allow people to have any questions.
Hey, I have one question.
Yes, please.
So do you think that economic viability, or do you think that the the misunderstanding of what people's disabilities are right now a bigger barrier?
That's an important question. I want to do it two ways. What the COVID pandemic has helped kind of reveal for many people is that there's a significant amount of digital divide, right? So in order to have a smart city, we have to have a city that is connected and that people have digital literacy to understand how to use those connected devices. This assumes that the person has the physical and even the mental ability to understand how to leverage that. I'm not saying that people with disabilities don't, but I am saying that my mother, as a person who's visually impaired, can't operate her iPhone in the same ways that I can. And so how are we making sure that we are designing for them and the smart cities? Of course, there are also specific economic impacts of these issues, right? If we are not enabling people who have some sort of disability to being in the workforce, that's potentially meaning that their livelihoods and their ability to have inclusive, thriving lives are reduced. Their ability to be contributors to the economic viability of a specific neighborhood, the reliance on social services to ensure that that individual is maintained and protected is also implicated. So I'm interested in the economic implications of this, but I'm also more specifically interested in how do we make sure people like my mom and people who have developmental disabilities are able to also benefit from these smart cities. And if we're not intentional in designing that way, then we're going to continue to really exacerbate the existing legacies of discrimination that we have.
That actually connects to another question I had is how do you think this the digitization of this technology could compensate for the lack of adaptability for example, old people who oftentimes are disabled themselves, and just disabled people in general who might have that issue?
Yeah, I mean, so I'll give you one solution. There's a company that recently came out with a GPS guided walking stick. Again, this is, for those who may not know, this is a walking stick. This is what people who are visually impaired would be using to navigate the world. And again, presuming that they have the ability to actually get a walking stick. So there are a lot of assumptions in that even. But with that assumption in design, or kind of, in mind rather, you could leverage that existing walking stick. And if we thought about how do we as a community, like for instance, Syracuse has considered bringing Ring, right, which is an Amazon company, to Syracuse and providing a contract with Amazon to be able to ensure that you can create a grid-like leverage of a kind of surveillance camera system. You can do something similar in other communities, right? You can absolutely have a situation where you ensure that the walking sticks that are going to be leveraged in that community that are digitally connected, that are connected to the internet, are able to communicate with the sensors that the city deploys across the city's smart grid. And so I think in that sense, we have to be really targeted and really focusing on those communities, or if you have, in the case of people with dementia, if we're able to make sure by being clear to protect people's privacy rights as well, that if your relative is lost, that we can easily locate them, so that people who are experiencing dementia, who are likely to wander, and who relatives and families are burdened with providing care for, that they're able to have some sense of security that if their relative or loved one does get lost, that they're able to actually find them. And again, I say this in a very personal sense because my stepfather has dementia. So I know what that feeling is like. And these are the kinds of things that made me think about why these solutions are so important and what is absent in the conversation. Completely absent from the conversation are the ways that we're not designing to reorient society to become more inclusive. I hope that answers your question.
I agree. I think that there's a lot of useful solutions, but with that being said, what you had just mentioned, do you think at any point it will move towards an encroachment on privacy?
I used to work at the ACLU of New York, and so I'm very really interested in how do we take an American with Disabilities Act, right, which is the law that protects people with disabilities. How do we design that act into the ways that our smart city operates, right? Not just to be efficient, but also to be inclusive of people with disabilities. And how do we do so in a way that doesn't both facilitate for the types of things that we saw under eugenics, right? The hierarchy of society based on the perceptions of what people's abilities are and people's biological makeups orient them to being. How do we not replicate that by doing this? But also, because we have significant histories of surveillance, particularly of minority communities, how do we make sure that we're not leveraging this as a tool to do that? That's the conversation for another paper. And I think I'll get to that. But really right now, I think my focus is on how do we actually begin the conversation for developing smart cities in ways that are inclusive.
Okay.
So thanks so much, Yusuf. Very important broadening of the discussion to bring your perspective. I'll note that Yusuf and I and others have been working on a rights inclusive secure cloud architecture for regions and cities, including with the National Institute of Standards and Technology and the city of Syracuse for some time. So where it's certainly possible to build into the cloud and blockchain rights and qualities to affect human life. But Travis had a couple follow-up questions too. We're going to take that later on. We got to keep moving because we have a lot of people on this panel. Thanks again, Yusuf. Should note that he's still here in Syracuse, whatever, spiritually and in many other ways, and is also with Facebook, and Facebook called and made us reorganize this panel. So thanks again, Yusuf. Over to
And I will just say for the record, the work here is based on my academic research and not my work at Facebook. So
very good.
Take care.
We have this is a really full panel of great folks. We're very fortunate to have the big data program manager of US Ignite, Praveen Ashok, with us to talk about the autonomous vehicle testbed work that he's involved with. Without further ado, Praveen.
Thanks for the introduction, Lee. Let me go ahead and share my screen real quick. Great, thank you. So yeah, thanks for the introduction, Lee. I think that was really nice and sweet of you to sort of throw a quick introduction of what I do. So yeah, just really quick, I predominantly work on the data side. A lot of questions that you guys answered were things that I worked on and the things that we try and solve with the communities. A part of the work that I do is, I'd say like a newer version of the work that we do is trying to take the idea that we've been doing with the smart communities, that's the cities, and then take it to the basis. So the basis are.
I'm sorry, I introduced you, but I didn't really introduce US Ignite. And so for this, again, mixed audience, probably not everybody understands.
I can do that, Lee.
Yeah, you do a quick introduction to US Ignite. This is very important.
Absolutely. So US Ignite, so we are a 501c3 based out of Washington, DC. So what we do is we specialize on accelerating the smart cities movement. We have over 40 partner communities and work over a base of it. So what you could consider US Ignite is a player in the market who tries to accelerate the smart cities movement. So we lay out technology roadmaps for cities. We try and see how we could get that essential funding so that the smart city, smart infrastructure projects could get going, and also advance in the wireless research segment of it. So our idea is to try and see what cities are doing and then try and take it to the other cities so that the cities don't need to replicate those efforts. At the same time, there is an ecosystem that's created so that the cities could share the challenges that they face and the learnings that they have in a way that they could benefit from. And we sort of stand as a liaison between them to try and to make that process easy for them. So what we do is like maybe lay out technology roadmaps when it comes to say a specific project. Say if a city is working on a smart infrastructure project, like say smart street lighting, then we'd say like, say for example, the city of St. Pete in Florida has done a smart street lighting project, and these were the challenges they had. And this is a specific route that you might want to take that might help you tackle through these challenges and like find specific funding routes that might be available, and then get connected to those other cities that might actually help you with other aspects from. So yeah, so with the smart cities, we've been out there in the industry for like over 8 years now, and we've been working with over 40 communities. And this specific program that I'm going to be talking about is a program that's called Smart Bases that we've had recent involvement for the last couple of years, I'd say. So we've been working across 2 or 3 different bases across the United States, where we are trying to take those innovations and those technologies and that inherent knowledge that we've gained working with the smart communities, and then try and see if we can apply that in a much more condensed, secure environment that's on the smart basis. So any questions or anything before I jump on to the presentation itself on the overall mission? Sorry, I couldn't hear that.
Yes, I think that helps greatly. Thanks very much. Just one last word of background. The US Ignite grew out of an initiative of the Office of Science and Technology Policy in the Obama administration, White House, and continues to collaborate closely with the National Science Foundation, but is a supposedly independent nonprofit. Okay, back to you.
Absolutely, thank you. Thanks, Lee. Thanks for the additional talk there. So just really quick, so what I'm going to be talking today is trying to see how we are adapting the version of digital twin onto the smart basis effort that we're doing. So as a part of the smart basis effort, what we do is we take multiple smart infrastructure pilots, be it autonomous vehicles, unmanned aerial vehicles, or smart infrastructure projects such as smart transportation or others, and then try and see how we could get a lot more involvement from the Department of Defense and the folks at the White House, so that we could improve this space and then potentially bring through a lot more interest in the smart infrastructure technologies. So I sort of classify this into 3 different buckets on the work that we do. The one is to sort of try and improve the connectivity aspect. As I mentioned earlier, we're definitely interested and focused a lot more on advanced wireless technology. So our interest is to try and show how connectivity could improve this smart city acceleration. So we try and deploy pilot networks. We try and work with other vendors and trying to show like what use cases could be generated using the technology that's out there and using the network, how it could benefit the different use cases and how return on investment could be capitalized or eventually realized by using the connectivity that's established. The second bucket here is the smart sensors. Now with the connectivity that's available there, we want the infrastructure. So this is to try and say like how we could deploy different sensors, like say air quality monitoring or weather or transportation, like vehicle counters or CCTV cameras, and try and see how that could be integrated into the network. Once again, showing the communities on a way to work forward, like on deploying additional sensors and deploying additional networks. And then the last bucket is the one that's pretty important, which focuses on data analysis, because a lot of communities, what they do is they build out the network, either with partners, they deploy the infrastructure, but then the challenge really becomes when they don't really know what to do with the data, right? Like they have millions of data, like we work with multiple cities, they have a great open data portal, but at the end of the day, it's really very few users who come into the open data portal, and they just come to check to see like what's the salaries of people working in the community. So the idea is to try and see how all this data that's been capitalized can be turned into value. And for that, what we do is we try and build dashboards that would support and show the return on investment of what the data is available through. So as a part of the other work that I do, I work with communities and creating dashboards. So for instance, like I work on creating dashboard that focuses on economic development that helps small businesses identify specific locations that they want to be situated upon. So this is once again a data application where we try and use all that data we have, combining the city data with the federal data and privately available data to provide a locational intelligence for the small businesses to be placed in specific areas within the city. The other idea is like the cities are definitely interested in bringing a lot more businesses. So we could not just use that experiential knowledge, but then try and see how we could use the data to bring a lot more business to the city. And we work with the cities on building dashboards that could support that. So that's one side of work I do. The other aspect is the digital twin that we work along with the basis. So this also falls under the data analysis bucket. So now we have the data, now we have the network. How do we make a visual representation that could be understood by someone who is not a data expert, right? Like we definitely want a lot of engagement from the people at the White House, from the people at the Department of Defense who are not data expert, but then understand the value of something that they see visually. So that's the reason why we wanted to adopt something that's replicating the efforts, and with the digital twin efforts that are like booming and a lot of aspects where you could simulate things which could not be seen in the real world. I think it's a great opportunity for us to try and see and use the data that we have with the backed up connectivity and the network sensors that we deployed. So this is just a quick background about the projects that we're working on. So this is a project at the state of Colorado that's at the Fort Carson base. So once again, in this base, what we have is we have an autonomous vehicle pilot that's running through the base that I'm going to be talking about in the digital twin version. And then we also have an unmanned aerial system. This is a drone that we have deployed, which detects FOD, that's the foreign object detection system, and uses that for further machine learning and analysis to try and see how they classify objects and what might be the causes of that, and then do an analysis to prevent further FOD objects onto the air base. And then the third one is the advanced 4G or the 5G network, which resides as a backbone within the network at the base, which is a proprietary private LTE network that we deploy to host through the different sensors. So this is a JMA wireless network solution, and it's a CBRS-based network that's out there. Any questions still here? Great. So just jumping further onto the autonomous vehicle twin. So what we've done so far is we've collaborated with this company called LG SVL, which is a part of the LG Electronics. And they have a project team who focuses on the simulation aspects. And I've built out a project that's called the LG Simulation Engine. And like without working from scratch, we've used a lot of data that we've aggregated from the autonomous vehicle in the form of ROS bags, and then tried and see how we could replicate that and make that a better visual, at the same time also simulate something that's called as edge cases and try and demonstrate cases which could not be imagined at the real world. So just to give you an example, we could, like for example, we are working in a military-based environment, so folks could be dressed in a camouflage dress, right? Like the military personnel could be really different to identify than a civilian. So at that aspect, you need to train the vehicles, you need to train the data algorithms and the machine learning based data sets on like how could you detect a camouflage dress, and that's something that we are interested in. And then we're also interested in edge cases. For instance, if there is a cyclist coming through, and then if there's a pedestrian crossing through, and then there's a car, if there's a car coming through, what stops first? These are corner or edge cases which you don't really impact or see in real world, right? And like we'd want to try and see to justify or to validate those just edge cases so that the autonomous vehicle algorithms that we're using or the fit of the autonomous vehicle on the base could be evaluated and justified. And for that work, the digital twin effort that we're taking forward is really helpful and supportive on that front. So what is the digital twin? So not really jumping detail into this, but what we're trying to do is recreate the whole environment in a 3D scenario for to make it visually representable, and then B, to make it a process so that you can evaluate things in the future, right? Like at a later stage, what we're trying to build is a test bed. So we don't really want vehicles to come into the base and test it, but then if there's a methodology where you could create a model of your vehicle on the digital twin version and then put it onto the digital twin and then be able to test to see if that might be a fit onto the base, I think that's where the value gets added upon. And that is exactly what we're trying to do, make things virtual before we jump on to having a real vehicle on the base itself. This is the suite of sensors that we deployed at the vehicle on the base. So as you could see, we have a couple of LiDAR nodes, we have a radar node, and then we have the GPS of the IMU unit and a blackfly camera. So what we were essentially understanding in this project where we collaborated with the University of Colorado Boulder was to try and see the behavior of the autonomous vehicle in comparison with the other vehicles for which we use the LiDAR, radar, and GPS units. So this was to try and see how was the braking pattern, what was the state estimation of the vehicle, and things of that nature. The other aspect that we were also interested in understanding was the human factor analysis. So this was to sort of understand what is the behavior of the operator when it comes to an intersection, right? Like the vehicle might take time to break down at an intersection, but is the operator panicking through to stop the vehicle even before the autonomous technology comes into play and stops the vehicle? So for that, we were monitoring the vehicle's operators' vitals, such as the eyeball movements, the reactions of the passengers in the car, and like comparing that with the autonomous vehicle stack that we had in place.
Praveen?
Sorry, go ahead.
Yeah, sorry to distract your presentation. We have only 5 minutes now, so please remind that we have 5 minutes for the presentation.
Sure, absolutely. Yeah, so thanks. Yeah, and this is the digital twin data generation pipeline. So what we're trying to do here is try and recreate the whole scenario. So I'm not going to like completely take a lot of time in explaining this, but this is to try and say like how we are regenerating the overall methodology that's being created. Like we have a photogrammetry methodology where we create a 3D image of the vehicle and then map that into the digital twin version. And we have a cluster where we perform the data extraction and then put that out onto the real world technology out here. This is the 3D model of the vehicle that we built. So this was built on Adobe Maya of the Polaris 3D vehicle. So this is the base model that we would import onto the 3D simulation software with the sensor suite deployed onto that. And a real quick visualization video of like how the vehicle visualizes the traffic flow. So if you could see here, the vehicle's got 2 Velodyne sensors and then a radar at the front. And this is the visualization coming from the LiDARs and how the vehicle moves through and like how that compares to the camera images and how that has been worked through. So this is how you would see if you would not have a real digital twin version. And it's really difficult for someone to understand what this works and how this might work through, right? And with the digital twin work that we've done at the Joint Base Maya Henderson Hall, which is one of the projects that we've worked on, this is a basic version of a digital twin that we've built. So you could see here how a vehicle moves, what are the neighboring environments that's available, and the movements and the detection of the vehicle that could happen out here, right? If I can maybe scroll down further. Oops. Yeah. If you could see on my screen, you could also see the sensor suite and how the vehicle sensor suite is being displayed and on what basis the vehicle makes a decision to take a turn or then to drive along the roads and work through that. So yes, I think I already covered this, like why we've adopted a digital twin and how we could generate different edge cases and work through that, and like how a photorealistic environment can be created using a digital twin. Yeah, once again, this is a scenario pipeline on how we regenerate edge cases and work through that. And like if you see here, like we could create different scenarios that are non-existent and use that existing data to classify and create buckets and then create different scenarios, which might be useful for edge case simulations. And this is once again a data pipeline that I've listed below. I'm not going to jump into that. So yeah, so just coming into the final slides of this. So the broader goals are to generate a simulation and a data set that would be used to advance further research in this autonomous vehicle segment, right? Because autonomous vehicles are definitely running on the field where civilian environment is present, but then at the basis, there aren't really enough data sets or there aren't really enough resources or projects that have been taken to understand how autonomous vehicles react in basis. And then the other major impact is to try and see how we could generate edge cases, which might not be possible in the real world, but want to test the autonomous vehicles. And then the last idea is to create a virtual test bed that I described earlier, where we want to create something which, where you don't have to really bring those vehicles onto the base to test it out, but then you could just develop and put in your autonomous vehicle stack so that you could test and deploy and see how the vehicle breaks and how you'd want to configure the vehicle for the specific project on work. So yeah, so that's all I had predominantly. Any questions on this?
Thank you for your presentation. Because we only have 1 minute left, I'd like to add a brief question. So how can blockchain be combined with this data train for autonomous vehicle, and what will be the role of blockchain?
Sure. So I'm not a blockchain expert, but all that I can say is the data that's being generated from this vehicle or the data that's being generated from the sensors can all be put through a blockchain technology so that it becomes a lot more secure, right? Like,
I think you were disconnected.
the data is really important.
Oh, okay.
Can you hear me now?
Yeah, I can hear you.
Yeah, so I was just saying, like, the security of the data is really important. And since we're working on a smart-based environment, it's really important for us to ensure that the data is being secure and encrypted, and a blockchain technology where you could make sure all this data is secure would really benefit this. And like, since there is a lot of data transfer happening, not just between the vehicle and the cloud, but vehicle to infrastructure, V2X is what we call. So you have neighboring CCTV cameras that's being deployed that could also be used for. So all this technology, when you combine it with blockchain, would provide a much more secure and advanced capacity for us to work on. So I think that's where blockchain might come into the picture.
Okay, thank you very much. I appreciate your answers.
Thanks.
Well, so thank you.
Thank you.
So perfect question, Junghan, to set up our next presentation. And thank you so much, Praveen, for those remarks. There's a really tight connection. Without further ado, Catherine Forrest.
Hello, my name is Catherine Forrest, and I'm a undergraduate senior in the iSchool, and I'm also a newly admitted fast track master's student. Today, I will be presenting on my research project funded by the Syracuse University Source on blockchaining the Mupal digital twin. So in May of 2020, Syracuse University, the State University of New York, College of Environmental Science and Forestry, and the State University of New York Upstate Medical University innovated the ultra sucrose method for real-time transmission tracking of COVID-19. This innovative testing solution is scalable and deployable through the mobile early warning platform Ultra Sucrose Lab, also known as the Mupal. My objective was to create a Mupal digital twin using Azure, Microsoft Azure, to optimize design and manufacturing processes, maintain physical assets, and provide data analysis mechanisms for proactive maintenance. Digital twins are a great way to model the Mupal, however, they have some access control security issues. So the question was, how do you blockchain the Azure digital twin of the Mupal in order to solve their inherent access control security issues? I'm going to pass it over to my mentor and Professor Lee McKnight, who's going to tell us a little bit about the Mupal.
Thanks, Catherine. So this slide was developed in April 2020 and refined by May 2020 to describe this Well, obviously, we all know what a crisis this pandemic is and was at that time. So developing a modular standardized method for collecting data on COVID-19 in wastewater, analyzing it, classifying it, and then aggregating and relaying it, that's life and death stuff. So that technology, within a couple months of its invention, was being planned for use and deployment in within weeks of deployment and use in upstate New York counties and in Syracuse University dorms and other areas throughout New York State in cooperation with the New York State Department of Public Health. So if we have this method that is quickly becoming standardized, we think, what if you could actually make it portable? If you didn't have access to the right professors in upstate New York or the right lab doing the analysis, the rest of the world could use some standardized methods quickly. So we quickly envisioned imagining putting this into a freight container and making it portable. We were in dialogue with the various parts of the Department of Defense in particular, but DoD doesn't usually get things out the door as quickly as a pandemic, but we did develop the conceptual framework for having a lab doing the standardized method on a ship, having a different version of it, going to any smart base, having it basically deployable in any emergency humanitarian situation. And so if you have this thing, but we haven't actually built one yet, but it's easy to configure and imagine because we know the process here, couldn't we just start working on a digital twin? And now back to Catherine.
Thank you so much, Professor McKnight. So Praveen did a great job of introducing us to digital twins, but I'm just going to quickly go back over it. So a digital twin is a digital replica of a physical object or process designed to understand, control, simulate, analyze, and improve operations. Digital twins bridge the gap between the digital world and the physical world. They function in the digital realm just as they do in the physical. The creation of the Mupal digital twin utilizing the Azure Digital Twin platform will serve to optimize design and manufacturing processes, maintain physical assets, and provide data analysis mechanisms for proactive maintenance. Although digital twins seem to be the perfect modeling solution for the Mupal, there are several access control security issues with them. So traditional digital twin development relies on centralized authorities to define truth. However, this does not ensure integrity. There are also the critical issues of interoperability among collaborators on the network, the security and integrity of stored data and analysis, and communication transparency between peers on the network. So our blockchain solution, or the blockchain solution that I developed, utilizes consensus quorum, which is an open source protocol layer which enables users to leverage Ethereum for private and public blockchain DApp, which is a decentralized application, and smart contract development. So consensus quorum is a box, and then inside that box we have a smaller box, and that's Hyperledger Besu, which is distributed ledger software. So Hyperledger Besu is an open source Ethereum client that enables us to implement our security mechanisms. But before I go into that, a client is essentially a software application that lets us utilize certain specifications on the Ethereum network, and clients can also collaborate and communicate with other collaborators on the network. So Hyperledger Besu enables us to implement our security mechanisms, IBFT, which is IBFT 2.0, which is Istanbul Byzantine fault tolerant, an example of proof of authority, consensus protocol, and on-chain permissioning. So blockchain is a security solution for distributed networks where we don't know who the peers are on the network or if they're trustworthy or not. It's not centralized, so the peers are who govern the network. So the goal is to ensure integrity on the network, and this is done by utilizing consensus. So a lot of you may have heard of proof of work, where the peers on the network are miners, and these miners are competing to solve complex hash equations. The first to successfully solve the complex hash equation and verifying transaction gets a reward. Proof of stake is where peers on the network, the peers on the network are known as stakeholders. They hold the proof of stake cryptocurrency. And what they do is they're essentially gambling their cryptocurrency. They're saying, I'm going to risk this amount of my this proof of stake cryptocurrency for this transaction to go through. Now, if the transaction goes through, those proof of stake holders get a reward, which is, shocker, more cryptocurrency. However, if let's say someone on the network is trying to do something malicious and that transaction is, not truthful. So if that happens and the transaction is not verified, it gets slashed and the crypto is gone forever. So IBFT, Istanbul Byzantine Fault Tolerance, is an example of proof of authority. And so Istanbul Byzantine Fault Tolerance is a consensus algorithm derived from the logical dilemma called the Byzantine generals problem. So I'm just going to quickly go over what this is. So the Byzantine generals problem is when there are multiple generals and they're surrounding a city in which they're going to attack. Now they either have to decide to attack said city or retreat from it. Now it doesn't matter if they attack or retreat, it just matters that they come to a consensus. Obviously, there would be a failure if 2 of these generals go in, other 2 don't go in. It's not looking too good for those guys. So, and there are the issue inside that is that there are communication issues. So these generals cannot communicate with each other directly. They are connecting or can talk to each other one at a time and through a messenger. And the messages could somehow get delayed, destroyed, or lost, or a fraudulent message could, get sent out by one of the generals to confuse someone for, some malicious way. So if we apply this dilemma to Istanbul Byzantine fault tolerant, this is when our generals are validators on the network, and these validators work together to vote to consensus. So Istanbul Byzantine fault tolerance is the ability for a blockchain network to operate accordingly and to reach this consensus despite the chance of nodes failing or propagating incorrect information. With Istanbul Byzantine fault tolerance 2.0, it requires a total of 4 validators on the network to validate the transaction. So for a block to be inserted on the chain for that which is validating the transaction, there needs to be greater than 66% of validators must sign the first block. For a validator to be added or removed from the blockchain, there has to be a majority vote greater than 50%. Proof of authority consensus protocols have faster block times, much greater transaction throughput, and immediate finality. It's ideal for consortium blockchain network. Consortium meaning with the mutable digital twin, like we saw on a couple of slides before, is that we would be working with organizations, government organizations, CENTCOM, and so they could be able to access this network with other organizations. So proof of authority is really built for, it's really a solution built for consortium network, which is perfectly fit for the mutable. We will also be exploring implementing on-chain permissioning. So Hyperledger Bisu gives us the opportunity to implement on-chain permissioning, which utilizes smart contracts to store and administer node account and admin allow lists. Allow lists is exactly what it sounds like, a list that allows certain people to do something. So using on-chain permissioning enables all nodes to read allow lists from a single source on the blockchain. Permissioning implements 3 different types of allow lists: accounts which can submit transactions on the network, nodes which can join the network, and admins who are accounts that are able to update accounts on the network and node allow lists. And so now I'm going to go into some implementation challenges that I faced during my research. So there's really very limited resources out online. Growing up with the internet, it's pretty scary to see when you go and Google search something and nothing pops up. And that's what happened when I looked up blockchaining a digital twin. There are several people currently in the process of working on this cutting edge solution right now. People out in Germany, people in the Middle East. And so it's really just this cutting edge technology, which has made it definitely a challenge. And then, so there are also no off the shelf capabilities. Azure doesn't provide a digital twin blockchaining service, right? They're collaborating with Consensus and consensus is enabling them to utilize their technology. So, we can build out that solution, but it is, but there's nobody has done this before with Azure and with consensus. Another challenge was securing resources to execute the solution. We weren't able to secure the Agile Digital Twin service during this three-month grant. And this is, but I utilized open source solutions and working with Azure and getting Azure certified. So we've been able to access some resources, but not the literal service. It's really expensive. And yeah. And so another challenge is building a constituency within the university that understands the value of funding this project. So by doing this, building a constituency, we can raise awareness and get the funding that this project needs to be executed. That's all. Thank you so much for your time. And I'm excited to hear the rest of the presenters. Oh, flashlight. Sorry.
Yes, me and Lan Jensen, but I don't see Lan.
It's okay. You want to stand through? Okay.
Yeah.
Okay, go super fast.
Sweet. Yeah. We only have a couple minutes, so I'll just ask one question and leave either or, and leave the rest for anyone in the audience, virtually or in person. I know that the main priority is security and like access control, and you've done a lot considered like how early stage it is and how many hurdles that you've overcome, but also seeing that the pandemic has exacerbated supply chain issues, especially when you're trying to implement a MuniBond during the another potential pandemic. Do you plan on implementing like a blockchain for supply chain?
I mean, supply chain is one of these. Blockchain is a solution that's been explored for supply chain pretty extensively. We saw a presentation earlier today, which explored how it can be adapted. So sure, I mean, I think that it could definitely improve operations, improve execution. It's just getting it out, getting it implemented and tested in the time. But yes, totally. Yeah,
seeing Professor Pardis's presentation definitely shed light on that as well.
Yes, definitely was really extensive and did a great job educating us on the applications for the supply chain.
That's all the questions I have.
Right,
if there's
thanks.
anyone online that wishes to get something in.
Thank you, Catherine. And now you see how I set up undergraduates for impossible challenges. So thank you, Catherine. We certainly we have made progress, and there's more to come. And we look forward to continuing to work together and with others on this important work in another form through the fall semester and hopefully beyond. Prasanta Ghosh prepared this presentation of work that we've been doing together with Rand and with Danielle as well. And now we're starting to move beyond. So we have the MuniBond, sort of a small containerized health service. We can now start, and we've also talked about the Internet Backpack, which is a even smaller, non-containerized connectivity solution. And now we started thinking about microgrids, again, which we've talked about briefly before. We're going to start drawing some connections between those areas of application for a blockchain. So we talked about blockchaining potentially the Internet Backpack, blockchaining potentially freight container size objects for health purposes. And in the research we're doing, we're also talking about blockchaining other forms of microgrid energy supply. So we think about this nowadays, the grid already is more decentralized than in the past with rooftops, solar, wind farms, other sources of energy now bringing energy both onto the grid or that were not planned for originally when there was just large centralized suppliers. Next slide. Let's see if I can read this. I can't see it. My eyes aren't so good. Okay, let's move to the next one. All right. Yeah, let me pull this up closer for my poor old eyes. Okay, so we in other meetings, just before the pandemic, we had meetings also with the CIO of NYSERDA, the New York State Energy Research and Development Agency, and we had students about this now 2 years, is it a year and a half ago, presenting on blockchaining energy trading platforms. There's been a variety of work, not just here at Syracuse. There's other work across the country and around the world, starting to think about this interface between blockchain innovation and reimagining and redesigning the grid as it's happening, with increased security from the edge for the suppliers, for the buyers, establishing new distributed trading platforms. These are not just theoretical now. They are starting to come into practical development, and perhaps we'll flash over to one of the sources of them from other commercial companies and partnerships that have platforms in place. The relevance of this in a time of climate change and global warming, in which potentially energy trading and greater efficiency in reducing carbon through verification and authentication of changing behaviors of energy consumers in distributed environments, seems, I guess, pretty obvious. That's irrespective of the exact type and source of the energy supply being used, but the very common use case as shown here is, okay, we got multiple solar home panels producing a small amount of energy sometime, which is hopefully, but they want to be able to trade it back into the grid, having that capability for buyers and sellers and consumers to allow for greater flexibility, but still with grid stability, because the number of sources of energy going up potentially can lead to fluctuations that could destabilize and essentially wreck the system. So this is not to be taken lightly or undertaken without consideration. So there's a reason for it being difficult to redesign and decentralize the energy grid in the way that we can say, oh yeah, that's kind of obvious. We have solar panels everywhere, right? But managing this is a challenge at multiple levels. So as, for example, here on the next slide, we see we have to think about many different parties where blockchain can come into the solution. For the supply chain, we have to be managing the data. We've already talked through the healthcare and energy areas as different distinct domains, along with the IoT sensors. So bringing this all together, we have elements that we just heard Praveen talking about for electric vehicles. I just mentioned carbon emission trading and green certificates that are active areas of interest to the energy firms. Then with decentralized technology and distributed platforms, peer-to-peer trading is, again, what my own students in blockchain management were talking about 2 years ago in prior research on utilization of blockchain. So for this work at an early stage, I'll note more broadly, we've been having discussions with Professor Pardis from Georgia Tech, Professor Deidre Hodges, now from Florida International University, working with Danielle Smith, working with Michael Maloney of CoinMint, and working with George Newman of One Planet Education Network, Angela Reeks, who's been here as well, has joined in the meetings. And am I forgetting anyone? And of course, fantastic doctoral students like Rand Cotto and Vince. And this ties, of course, to Catherine's work. So if we think about this together, we got the tiny little backpack, which is also a microgrid. We got a Mupol, which we didn't highlight, but it includes, of course, on the roof is solar panels. Of course, built into the Mupol is a energy or battery storage system. And of course, with blockchain, everything we just talked about, you could be doing on that discrete unit of energy being stored and consumed within that Mupol, transposing to other forms of containerized microgrid solutions, which including using biomass systems or small portable systems that are being under development, which is kind of beyond the scope of this presentation. but at least some people here, David, know what I'm alluding to. So now if we think about this all together, we're saying, you know what, this is more and more something where, going back to Professor Taylor's talk this morning, there's similarities and differences and commonalities that could lead to greater efficiencies, and the tie-in to the digital twin work again of Catherine is, if we can do this for a MUPL, we could be doing it for a containerized microgrid, and I'm up on time. So all this, do I need to say anything further here? I think that's basically my last slide. It says note that all of these different areas we can be thinking together, and we look forward to also with companies like Intel and VMware and others that were involved in Nokia and others that were discussing these issues around sustainability, energy, blockchain, security, and smart cities. This is in the form of areas where we're like ongoing research for future submissions and future grant applications and future collaborations also with public partners and public agencies, where by now you're guessing I'm being careful in what I say and what I don't say. So I'll stop there, and thanks very much.
As the respondent, my question to you is, from an academic and from an industry perspective, what do you think are the challenges that you're facing and that you see that are kind of preventing for this technology to move to the next levels?
Well, there's quite a few obstacles. The energy sector and industry is like highly regulated for good reason. Everybody depends on it. It uses rights of way, and oh yeah, it can be deadly if you mess it up. And so it's really there's important reasons, and we're not just talking about nuclear power, we're talking about any kind of electrical power. So, you know, fluctuating bandwidth and taking out a server, that's one thing. Fluctuating energy loads on a substation leads to a real world explosion, accident. So this has to be carefully done with high security and trust, and going from the legacy grid, which is literally so, you know, like the current electrical grid for the whole country is so complicated that there is no model of it and no model possible. So you couldn't possibly build a digital twin of it. It's too I've had these discussions with Department of Energy for federal regulators saying we can't model it. So if you have unlimited computing capacity and it's too complicated to model, that tells you how complicated the current grid is. But I think moving to a more structured, standardized, reflective model where things can be comparable and can be managed. I think this is going to be a tricky transition from the legacy grid to the future grid, because it's not easy to make that leap. And so for basically every single actor has reasons not to change, because it's not a little change we're talking about overall at this time.
Hello, everyone. Hi, this is Kevin Werback. I'm the moderator for the next session. So for those of you in Syracuse, let me invite you to all sit down, and we'll start up in just a minute. All right. So it's a pleasure to be joining you virtually. Sorry that I couldn't make it up there in person for the conference. I'm Kevin Werback. I'm a professor of legal studies and business ethics at the Wharton School at Penn. And I've had the great pleasure of knowing Professor McKnight for more than 20 years. And I'm delighted that, like me, he has heard the siren song of blockchain and crypto, and has brought his talents in studying technology and communications to this field. And it's been wonderful to hear so many of the exciting applications of blockchain that we've discussed at the conference. The next panel is about law, policy, and regulation and community partnerships. And there is a notion that you hear a lot that somehow blockchain is inconsistent with law. That if we're going to talk about decentralized systems and cryptocurrencies, then that means we're in some world where traditional legal systems and policy and regulatory concerns go away. And we don't need to think about governments. That's the argument you hear. I am firmly convinced that argument is wrong, and I actually wrote a whole book largely about that point. But it's wrong not because blockchain doesn't raise important issues, and it's not wrong because blockchain doesn't force us to reconsider the things that governments and policymakers do. It's wrong because it assumes that we can have something that's so important and transformative in terms of so many areas of human activity and not think about these important kinds of public concerns. So we have three presenters on this panel who are going to address different aspects of that, both some of the policy concerns that blockchain-based systems raise, as well as the fact that governments themselves are now getting involved in this space, whether that's through formal initiatives around cryptocurrencies, like we've seen in El Salvador, or through central bank digital currencies, where governments are themselves talking about issuing digital assets. So let me first turn to the first presenters, and I will assume that everyone is here. The first that I have on my list is Clara Abayan and Stefano Catani, who are going to talk about Bitcoining or blockchaining Central America.
Okay. Well, thanks, Kevin. So that's actually not accurate. So where we're dealing with the time changing schedules, and the lead speaker got pulled to Spain and sort of is in transit, so we're not able to hear that presentation now. But if you can, Thibaut Streppel, I believe, is next. Is that correct?
My pleasure. No problem. Yeah, sorry about that. I didn't have the updated schedule. Good. So we go to Thibaut Streppel, who is going to talk about computational antitrust implications of smart contracts.
Yes. Hi. I hope you can hear me well. Is that the case?
Yes.
Yes. Yes. All right. I'm asking the question because I have the most DIY setup of all year. I'm not home, so I do have my iPad in front of me and a pile of books, and we're going to talk about complex technologies. But at the end of the day, I still struggle to have a decent setup. I hope you can hear me well. So indeed, I mean, the title of my talk, I believe, was assigned to me, and I'm not exactly sure what it meant. So I've decided to change it a little bit and to focus on smart contracts and antitrust. And I will try here and there to talk about the computational aspects of it and how you could tackle the problem. But I think this is an all new discussion and another discussion we need to have. So without disclaimer, I've just tried, and apparently it works if I just share my screen with you. So I'll be sharing it from the iPad. I've never done that.
Yep. Sorry, we sort of moved really quickly. I didn't really introduce you live from somewhere near Amsterdam or in Amsterdam, I'm not sure. And congratulations on your move to the Vrije Universiteit Amsterdam. But could you just say a brief word about yourself and the university where you are before we jump in?
Of course,
and,
yes.
Oh yeah,
so
you're talking from Stanford too. So
yep.
Say a little bit more about yourself so people know who we're talking to.
Sure. So I'm a lawyer. I assume not everyone is a lawyer in the room. So I have a PhD in law, and I'm an associate professor of law at the VU University in Amsterdam, indeed, for 2 weeks now. Before that, I was at Utrecht University in the Netherlands. And I'm also a faculty affiliate at the Codex Center at Stanford University, where I do work on computational law and computational antitrust. So I will try to create a segue between those two big interests that I have. I mean, I've done my PhD in the field of antitrust and digital markets, and I got a bit tired of talking about big tech all along. And eventually, for very, unknown reason, even to me to this day, I've decided to work on blockchain and got a bit obsessed with blockchain. So here I am. So that's my background. But again, talking from south of France, where it's very hot. So I'm not used to that anymore living in Amsterdam. So I hope I will survive. Please, if you if you don't understand what I say, don't hesitate to interrupt me. I hope you can see my presentation right now. So I thought, it's still the summer after all, so I will create a presentation in a shape of a smiley face, hence the two little bubbles that I want to discuss. One being talking about dominance, and the other one talking about how can we use smart contracts to collude. Not that I am advising companies in the room, if there are any, to use smart contract to collude, but I think this is the first step. So then we can tackle this type of collusion and talk about what antitrust agencies can do. I'm very pleased to see that the DOJ in the United States has been very active, especially under the previous leadership, in trying to understand blockchain at the antitrust division and to tackle those issues. Same for the FTC and the European Commission and many others. So I believe we are going in the right direction. So I just want to start with a positive message. And again, I'm not sure if there are Bitcoin maximalists in the room. I'm not one of those. But I do believe in the potential of blockchain with all the limits. And although today I will be discussing the pitfalls of blockchain and how it could be used for bad, I believe that overall this is positive. So I just wanted to make that clear. Without disclaimer, I want to focus, and this relates to the title of my presentation, the use of smart contracts to abuse dominant position or to monopolize the markets. Which is a very something that is trending now, even in political and presidential debates in the US. But if you look at it from a distance, what you see in those situations is that you have one company who is dominant on the markets. So of course we could be discussing that quite a lot when it comes to blockchain and crypto. What does it mean to be even in a dominant position? Once you have proven dominance, you want to see that company abusing the market power against all the companies or against the consumer. And so here, you do not need to create trust between the big companies and all the companies. This is actually quite the opposite. You want to abuse your market power and destroy any form of trust that you may have with your competitors. And so for that reason, why should you use smart contract? It's not that obvious that you want to have a beautifully algorithmic contractual relationship. So overall, I think it's not where you're going to see most smart contract being used to infringe antitrust law. That being said, I just wanted to show you this table. What I've tried to do here is to summarize all of the forms of monopolization that are being tackled in 99% of cases. And it's still likely that you will see companies using smart contracts, but not to abuse their blockchain power in itself, but to abuse their power they have outside of blockchain, right? So it could be a car manufacturer, and you want to use that power against tire manufacturer. And for that, potentially it might be that you want to use a smart contract. I could see how relevant that might be for rebates. So in the case of rebates, what you say is that you may basically say to your competitor or your business partner, the more you buy, the cheaper it becomes. And then you start introducing new criteria, which are not based on the quantity, but the quality. And there I can see how a smart contract could be used to, organize a perfect sort of abuse. But even, I'm not convinced the company will be using smart contracts to implement such abuses, even less so for, some others like exclusive dealing. So I just wanted to show you the overall picture. I don't have the time to go into details here, but overall, I understand how in theory it might be possible, but in practice, I'm not sure you're going to see that. Something that you may see, and here this is not the case, because to the best of my knowledge, there are 0 cases in which a company used a smart contract to abuse its blockchain power, whatever that means. But it could have been the case in this case that I'm sure you're all familiar with, in which, allegedly the Tether community overflown the market to buy Bitcoin and convert that into US dollar and so on. And this could have been done by way of smart contracts, certain conditions, more token being issued on the market, and to be a bit more automatized. Although, again, I'm not quite sure why a smart contract would be very convenient in that case. If you just want to issue token on the side in a discrete manner, maybe you just want not to use a smart contract, even, you know, for privacy reason, and so that the bytecode of the smart contract won't be public, and et cetera, et cetera. So overall, I'm not sure we're going to see it. I mean, I might be wrong. Prediction is hard, especially about the future. But when it comes to monopolization or dominance in smart contracts, I'm not convinced. The story, I believe, is a bit different for collusion, because in the case of a collusion, what you want is to indeed straighten trust between at least two companies. It might be 3, 4, 5 companies. And here, what we see looking at empirical evidence is that trust between those companies is the #1 issue. They want to trust one is not going to apply for leniency, which is to report the cartel to a competition agency. They want to trust they gain more in staying in a collusion than leaving the collusion. And here, smart contract might help. And so what I've done here is that I've distinguished between the creation of a cartel, the life of the cartel using smart contracts, and the death of those cartel. So the creation of it, so here, same distinction. You might see companies using smart contracts to collude within the blockchain ecosystem, but it might also be that supermarkets are using smart contract to collude about, you know, supermarket activities. So you do have those two type of practices. But here is the reason why I believe this indeed might be where you see smart contract being used. I believe that I've seen evidence of that. I'm not going to disclose where, but I think this type of practice is already being implemented. I think you're all familiar with the prisoner dilemma, you know, with the idea that it might be best for two prisoners to lie, but since they cannot coordinate once they are put in two different cells, it's hard for them to know what the other is going to do. And this is where you actually see that all cartels are by definition what we call non-cooperative in game theory, because even though you may sign a contract and say to another company, let's agree to collude forever, it is impossible to go before a court or an antitrust agency and to try to enforce that contract. That contract has no legal value. And so for that reason, it's non-cooperative. All you have is the trust of the other colluder, but that's about it. Using a smart contract, you won't be able to take the smart contract and enforce it before a court of justice, but you can somehow try to predict the behavior and try to at least make sure that the code will be enforced depending on certain events. So for that reason, using smart contracts, you transform collusion into, they are not perfect cooperative game, but a bit more cooperative than.
I think we lost him.
You see is that they will help straightening collusion, because
Thibaut,
you may
Thibaut,
yes?
I think we lost you
Yep.
for a minute there on the connection. Just just go back a little bit to the beginning of that slide with Macon.
Sure. That okay. No. So I was just saying that, and again, I'm sorry about the connection. That it might be that indeed, you know, Macon, who was the former head of the antitrust division, underlined the fact that using smart contracts, it might be indeed a great way for companies to collude, unfortunately. And so it proves that antitrust agencies are aware of the risk. And so for that reason, I think we should also be aware of the risk and try to see what's possible to do. Moving on to, and I hope you can hear me, the life of the smart contract. I was trying to explain why a smart contract might be convenient and indeed create trust between the parties. You know, code will be executed unless, of course, there is a kill switch and I mean, all the exceptions, but the rule is that the code will be executed if the conditions are met, and that creates trust between companies. And for that reason, they may want to use a smart contract to collude. And so at the end of the day, I think there is a danger. It's not, however, potentially as problematic as it seems, because what you may also see is that companies will use smart contracts to also end cartel, because without smart contracts, and if you look at empirical evidence, it's very clear, and I'll leave you on that note, that companies collude until one company starts to deviate because the company does not agree with the price anymore. And for that reason, they try to sell some products for a cheaper price, for instance. And that's pretty much the end of a cartel. And I believe that you may indeed create a smart contract saying that collusion will end if another company deviates for more than 10% of the price or any conditions that you want. So at the end of the day, I believe that you will see a stronger cartel using smart contract with more collusion, but potentially they may explode more rapidly. But of course, it creates one big issue, which is the issue of a private enforcement, which represents 90% of all antitrust cases in the US, because indeed, if the practice ends, it might be harder then to prove that the practice ever existed. So end of the day, collusion and smart contract, yes. Smart contract and dominance, I'm not too sure about that, but that's a subject that I explore in a book that is about to be published in September. And so if you want to read more, the book will be open access, and so plenty of antitrust and blockchain issues for you to read. So that's all I wanted to say. Thank you very much. I will try to go back to my screen. I hope it works.
Terrific. So we have a little extra time. There's only 2 presenters on this session. I believe Zach Goldstein is up as the respondent to start us off.
Hi, Thibaut. Thank you. So I just had a question. Will the cycle be broken when more companies acquire smart contracts and use blockchain to their advantage, and there would be less collusion?
Why would that be, in your opinion?
Because there'd be less differences in the prices.
I mean, the core, if I understand the core of your question, I'm not aware of any empirical work leaving blockchain showing that if a certain number of companies collude on a market, then there is less incentive to collude. It seems to be actually quite the opposite. The more companies are colluding on your market, the more it creates an incentive for you to do the same. And so going back to blockchain and using smart contract, I'm not sure if it's going to change, this sort of dynamic. And so I think you may actually see the opposite. I mean, if you talk with some business executive, they are very scared. They've heard blockchain is immutable. And so for that reason, the idea to collude using a blockchain where it's immutable and an agency may actually just have all the evidence the agency needs might be a bit scary. Of course, as we know, there are lots of a way to work around blockchain immutability, but I think it creates some sort of fear, and potentially the more companies are using smart contract, the more they understand that they can design them in a way to stop, in a way with more privacy than using just some basic smart contract. So no, unfortunately, I believe the more smart contract, the more collusion, and the more work for antitrust agencies. I hope I answer your question.
Yes, you did. Thank you.
Well, then do you have more, Jack, or should I go?
No.
That's great. So I have some questions I can ask, but let me invite anyone else to please, if you have a question, to put it in the chat or the Q&A on Zoom.
Okay,
so
Kevin,
I'll go ahead, Lee.
Real quick, and then I'll turn it to you. So, all right. So I'm missing one important element, Thibaut, in your comments here. So we're positing there will be more collusion, but there will not be abuse of dominant positions, or you won't find evidence in smart contracts. Is there a failure, a gap in logic somewhere? Because if you have more here, or that would be a separate correlation. It wouldn't be directly in the smart contract.
I'm not sure if I understand.
Well, if I agree with you that with more smart contracts, there are more opportunities for collusion. Some, not all collusive opportunities, like some of them are co-equal, and other ones there is a dominant player sort of orchestrating and managing that collusion. So why wouldn't there be evidence of that type of collusion, which is not, I'm not the legal scholar, but there, I don't think it's an uncommon class of collusive activities in other areas of antitrust.
So, okay, I'm going to try my best to answer your question. I mean, indeed, it might be that you have a collusion in which you have all equal companies. Generally speaking, this is not the case, though. You do have one dominant company colluding with all the companies and putting pressure on the small companies and saying, if you do not collude with me, I will make sure to eliminate you from the markets. But that said, here we are talking about still a collusion, and I mean collusion. It does not, the size of the companies, that it does not really matter, at least in theory. In practice, it does, because if just two coffee shops around the corner are colluding for the price of coffee, nobody cares really, and the FTC certainly won't go after those two coffee shops. So in practice, the market shares matters, but in theory, it does not matter. So trying to understand your question, if indeed you have Apple and Google and Facebook using smart contract to collude, it does not really matter that they are so big on the markets, because here you just look at coordination between companies, regardless of the size of those companies. But when it comes to evidence, I mean, the reason why I think you're not going to see lots of smart contract being used to abuse dominant position is not because of evidence. It's because, I mean, I'm not sure it makes sense as a business executive wanting to abuse market power. I'm not sure I understand why using a smart contract would be superior to just doing it, you know, the old-fashioned way. So please let me know if I do not answer your question. But again, those are predictions. Yeah.
Okay, well, so that's very helpful, and that's an interesting prediction, and we can empirically test it as it plays out in the years to come. Thanks.
Yes, indeed. And you know, I'd love to be wrong. One prediction I could tell you I was wrong already. I thought that the first cases that you will see, and they are in the United States, will be cases where companies are using smart contracts to abuse their power or to collude about the outside world, right? The price of orange juice in the supermarket, this kind of stuff, because I thought that's much easier for an agency to understand and to be able to justify that consumers are hurting. But those are not the cases that we see. The first two cases in antitrust and blockchain, one was one person arguing that he got evicted from bitcointalk.org and that therefore the forum abused its dominant position. So this is really much, you know, internally to the blockchain ecosystem. And the other one was the Bitmain case versus American Corp, in which they argued that a fork was anti-competitive. So those two cases were about the actual blockchain ecosystem. And I thought, you know, those cases will come in just a few years, but they are here already. So please do not take my prediction as a real forecast of what's going to happen in the future, by no means.
Okay, well, so let me ask a question. I mean, one thing about blockchain is that it's a transparent system. And so the smart contracts are on chain. And so if you know what you're, you know, how to read the code, you can actually see the terms of the smart contract. Isn't that a better approach if we're concerned about collusion, where regulators or even market participants can identify these agreements, even if they are immutable?
Yes, mainly yes. I would say it might be possible for indeed the FTC to find a smart contract, try to, depending on the blockchain, but try to, you know, convert the bytecode into the original, I don't know, code used for this blockchain and those smart contracts, and try to understand. I'm not sure if that will be good enough to understand the meaning behind the smart contract, right? You might see an exchange between two companies, but the reason why there is an exchange is not necessarily anti-competitive. So it might be one barrier, but I think the biggest one is the fact that most antitrust agencies, and this is mostly true in the US, are reactive, meaning that antitrust cases are coming from all the companies complaining, and some will complain indeed. I mean, if you are the victim of a cartel, you don't care if, you know, you are a victim of a cartel using smart contracts or not. I mean, you will complain, but the idea of agencies being proactive, which is to scan blockchain and try to identify smart contracts and to identify cartel this way, I think is not something that we will see, because antitrust agencies do not have the mean to be proactive. More than 90% of all US cases are coming from reactive methods and not agencies being proactive and try to scan, what's happening. So at the end of the day, I mean, I'm not sure if they will even, I mean, of course they will say, yes, we are making sure and using the transparency of blockchain, but I'm not sure if that is true. Most cases, but again, this is just a prediction, but I think most cases will come from reactive means of enforcement.
Yeah, that's a very important point, or a really interesting point. I mean, but then wouldn't you say that antitrust agencies should become more proactive? Because, I mean, we've seen this, for example, with financial crime, where initially the statement was, well, no one can trace anything on the Bitcoin blockchain. And it turns out that there are mechanisms with analytics to trace transactions. And people said, well, law enforcement is not technical enough to do that. Well, there are analytics firms that partner with law enforcement, and it's certainly imperfect. But we saw, for example, with the Colonial Pipeline ransomware hack, that law enforcement was able to go in and get back a lot of that money. So, by analogy, shouldn't antitrust agencies develop that same kind of competence?
Yes, 100%. And I mean, for that reason, I was really happy to see that the US was proactive and trying to understand blockchain and get not, a lawyer such as myself to talk about blockchain, but try to get some computer scientists to explain the technology for real and understand how it works. So 100%. Again, there is still something which is private. I lost you? Hopefully not. Yes, okay, you're back. I mean, yeah. So, but that is public enforcement, which is big in Europe, but not so big in the US. When it comes to private enforcement, it might be hard, for you and me to ask an LLC company to scan the blockchain, and I mean, it might be too expensive for just consumers to use those means of detection. So I think it's important to still keep in mind the distinction between agencies, which indeed may use some of those firms to try to understand activities and recover losses and et cetera, and just end consumers. We all can think about family members who will be lost if one day their Bitcoin or Ethereum got stolen. So there is this distinction. That said, yes, more proactivity would be great. The OECD is pushing for that regardless of blockchain, but it's pushing for that for years. And we should also discuss AI potentially, and all the problems that it creates. This is where I plug computational tools. Again, far from being perfect, but it seems to me that if agencies are tackling those technology with the means that they used to use 30 years ago, at some point it won't work. And I'm very happy again to see that they are willing to develop computational tools to try to scrape, the web a bit better and blockchain and try to use NLP to try to understand a bit better what's happening. So I think this is direction to be taken for, again, proactivity.
All right, wait, we've got a few more minutes. Let's see, does anyone else have a question to ask? I'm not sure, Ed Nano, if this third-party verification is for this.
Yes, I'm on the line. Can you hear me?
Yeah, absolutely. Go ahead.
Yeah, this is Ed Nano. I'm joining from London, England. I've got a question around yesterday. The second presentation was on the DTCC, and I have a question about that and following on with the third-party verification on the blockchain. So the Robinhood application for purchasing securities, I don't know if everybody is familiar with that, but there was a banning of the ability to buy certain equities in the USA by trading firms, and it was being blamed on the DTCC not being able to clear those trades for Robinhood. When I was at the bank in New York, I dealt with the DTCC on a daily basis. They're extremely powerful, as everybody knows, as a clearing agency. As the trades occurred, they're verified by an independent third party, in this case, DTCC, And in the business, the jargon is known as T+3. That's the time between which a trade is executed and the transfer is booked in the system. That is trade T plus 3 days. One of the obvious disruptive effects of blockchain is to eliminate the need for a third-party verification, since the chain is a register of the trades which previously occurred, and the block is verified to be true by the participants themselves. Also, in crypto, the trade happens instantly and not T+3. There is a set of hearings on Capitol Hill because the very system of finance is under threat. We did hear about central bank digital currencies as well in another one of the talks yesterday. My question would be, if this is actually the case with the blockchain and the third-party verification, would participants like DTCC be disintermediated if they're no longer needed in a decentralized system like blockchain?
Okay, so I don't think that's a question for Thibaut about the antitrust issues, but we'll leave that out there for. I'm not sure if one of the subsequent panels or panelists wants to talk to that issue, but certainly an important set of issues. Okay, I think Thibaut, do you have any other final comments? If not, we're going to move on to the other presenter.
Sure, just on that, I mean, I was about to say, I think this is a question for you, Kevin. This is definitely not my field. I just wanted to say, I wrote a report on smart contract, not blockchain related, for the European Commission. It will be published in September. And I've listed, and it makes me think about that, some requirements that we do have in Europe, in which we have paper requirements or, all sorts of form-based requirements, which are actually hindering blockchain developments. So I'm not sure if it does not answer your question for sure, but I've been working on some equivalent that we have in Europe, and there are lots of works to be done on the European side and certainly on the American side. But indeed, a question for somebody else. And thank you very much for having me. This was a blast. So thank you.
Thanks very much for joining us. So we'll move on. The next presenter is Anjan Roy from SIMBA Chain, who's going to talk about central bank digital currencies and cryptocurrency regulation. So if you could just introduce yourself a little bit at the beginning, and then go ahead.
Thank you. Well, thank you all. And I think I'm going to go ahead. I didn't really come prepared with slides. I was somehow in my mind, I thought this was a kind of a discussion roundtable. With that being said, I do have a slide to present. It's not my slide, but open source on the web. So I'm going to go ahead and share my screen, because I think that you actually don't need to have a lot of slides. Sometimes it's better just to have an accompaniment that you can speak to. And I'm going to go ahead and do that. Hopefully, you'll be able to see it. And I don't have to ask, can you see my screen? Because I'm here. And I can see my screen on the thing. So a couple of things. So I'll just get this out of the way. These are only my personal opinions. I'm not speaking for SIMBA Chain or any other entity in these remarks. And I think that's one of those things that disclaimers that everybody puts up when they go and give a talk. But in blockchain and especially crypto, the debates are very furious and passionate. Well, I'll say they're passionate and spirited. And so I think it's important to put that out there and to say, look, these are just my opinions, and people, my colleagues, others, have their own opinions, as we all do here. So with that being said, I also want to stray away from opinions and just kind of lay it out of kind of what a CBDC is. And sometimes the best way to explain what anything is to compare it to other things that people might understand or have somewhat understanding of. Well, what characteristics does one thing have in common with other things that are maybe similar to it or somewhat similar or adjacent, or in people's minds are, something that they understand. So this is if you Google CBDC, or if you study it heavily, closely, you've probably seen different versions of the taxonomy of money, and there's so many different Venn diagrams sitting out there on the web. The primary, and they all kind of source the BIS, the Bank of International Settlements, that's been doing quite a bit of research on this over the last couple of years, and they put out some great papers, some fantastic diagrams like this. And so you'll see this, but then people put their own interpretation on it. So they always cite Bank of International Settlements. You'll see this diagram all over the web, that has sites, Bank of International Settlements, yet there's different versions of it because it depends on kind of who you're talking to. So you almost see like a diagram of diagrams. So what I did is I thought this was actually a really good one. And I'm also going to, and then compare it to this one, which is really, really similar. But to explain, okay, so what is a CBDC? Well, what does it have in common with? Well, a couple of things. The CBDC, I like to say it's the one word answer I give is it's a lot like digital cash. And by cash, I mean cash that's literally sitting right here in your wallet, except I don't have any at the moment. Do I? Oh, I got a coin. Here you go. I got a coin. So it's cash, right? Now, a CBDC, the closest I would say is it has all the characteristics of this thing here, the quarter. You guys can't see it, all right? And except it's electronic. That's one way of looking at it. Now, why is that? Well, a couple things. Cash here, if you look at the four kind of variables, which this particular version of the taxonomy money puts, it's universally accessible, okay? Anybody can use it. I can give this cash to Catherine, give it to Professor McKnight, give it to David, give it to anybody here. It's universally accessible. It's peer-to-peer, which is really important, because as soon as I said I can give it to anybody, that also implies the peer-to-peer aspect. Quite literally, I can come and give it to you, and it's done. We're done a transaction. I'm gonna go do one right now, okay? I'm gonna pay a quarter. Those you can't see me. David here, I'm gonna take his pen. I'm gonna say that you agree with that, right? You're okay, right? We're okay. We just did a transaction, okay? Peer-to-peer. You got a quarter, I got a pen. I think I got the better deal. This is a really nice pen. He agreed. We just did a transaction. This money, anybody could get, right? It's cash. It's universal. It's universally accessible. It's peer-to-peer. We didn't need any. We didn't need other intermediaries to do it. It was not electronic. Okay, we'll come back to that. It was physical because I had to be in the room with him and walk over and take his pen and offer him my quarter. And of course, the medium exchange that we used, you know, the quarter, he knows it's worth something, or it has backing from who? What's written on it? If he's not sure he can write on it, it should be written on it. I think it's written on it. At least the paper versions are. It's a liability of the central bank. Okay, it's just worth something. So if, for instance, I gave him my mask and said, okay, you know, I'm going to take that quarter back and give him a mask. That's not, now he has the mask and I got the pen. Mask is not a liability of central bank, okay? Quarter is. So now I got the quarter back. He's got my mask. Maybe that's more useful. It's probably worth more than a quarter. That's an expensive one my wife got. But it is not a liability of central bank. So so what if we could do this where we will come back and just so we got it clear, well, I already gave the quarter. I will give David his pen back. I'll take my mask. So we're all settled up there. That was great because we just reversed it, right? We just went ahead and reversed it. Well, that gets into another thing. Did we reverse it or did we just do another transaction that effectively reversed it? I won't go there. That's a different beast. I'll go there. That's longer than the few minutes we got here. But here's what happened. So we did a peer-to-peer transaction. Okay, we issued something that was you know, a medium that's universally accessible. It was a quarter, liability of central bank. The only thing we didn't have is we had to physically be here. What central bank digital currencies enable, in theory, should enable, is all those things except electronic. So that I don't have to fly to Syracuse to meet David to do that transaction, okay? I didn't have to, because I had to fly here to do that. It's expensive, it took a lot of money. It's absolutely worth it. Love the place. I'm gonna come back here again, especially the iSchool. But I had to fly here to do that, okay? We had to be in physical presence. What if we could do it electronically and have all the other benefits of what we just did? Now, you might say, well, you can do this electronically right now, right? I could have just paid him through, I could have written a check, right? All right, we could have done a deal through Venmo, right? But that would have required a lot of infrastructure. That would be one of these things you might see here of central bank is issued by the central bank. Maybe it's universally accessible, it's electronic, but it's not. They are deposited currency accounts or using our bank deposits to pay each other through Venmo. And here's an example here. That's effectively what Venmo is. See here? Venmo would allow the same thing, but it wouldn't be a peer-to-peer transaction. It may look like a peer-to-peer transaction, but when I pay David through Venmo or through a check, there's a whole lot of infrastructure that goes into making that happen. That's kind of obfuscated. It's invisible to us, but it's definitely there. So it's not peer-to-peer. So that's that. So in that sense, to be able to do that peer-to-peer is what a CBDC, aims to enable. Okay, and then if we go back to this again, can we do it? Can we do this through a kind of a peer-to-peer transaction? Now, on the other side, the other thing, of course, that CBDCs have in common with, and this is probably where it starts to get a little, it could get contentious, is, well, cryptocurrencies, right? So right here, now if you're using a cryptocurrency, of course, the beauty of this, and of course, anybody at a conference like this knows this very well, is that it's peer-to-peer, okay? It's universally accessible, all right? Anybody can access it in theory. And, the universally accessible, I think we want to, I want to put that in quotes because there's issues around accessibility that I'll get into in a moment. But in theory, anybody can download a MetaMask wallet and get, go do, their Ether transactions or what have you. And of course, electronic, it has all those. What it doesn't have, of course, is it's not issued by a central bank. Some people consider that to be that's a feature that may be, that's the whole point of it. Regardless of that debate, I'm going to stay away from that. What CBDCs aim to do is give you the kind of the universality, the electronic and the peer-to-peer properties that cryptocurrencies give you, but to have it be utilized in the unit of account and in the manner which everybody prices everything else at, which is the national currencies of whatever place they happen to be living in. And that's what CBDCs aim to do, but still give you the efficiencies that you get from cryptocurrencies, still give you the efficiencies that you get from having a universally accessible ledger. And so that's in theory what CBDCs are aiming to do. It's a hybrid of, I would say it's a hybrid between your bank deposits, your cryptocurrencies, and cash. It's a bit of everything. Now, I do want to say that there are different, that's what a CBDC retail is. Now, there are other versions of this, like the CBDC wholesale. I would call that like the permissioned CBDC that's used between banks, and a really interesting, what is that I wanted to point out? Yeah, this particular chart refers to the cryptocurrency version that would be like a permission DLT, where there's a certain group of people that will have access to it. And that's something that banks or other entities or institutions will use to settle payments kind of amongst themselves, okay? And so that's what, so you get into this idea of CBDC wholesale that's used for just base money that banks will use in the interbank market to make it for settlement. Whereas retail is actually universally accessible. You don't have to get formal permission to go out and use it like you would with a permission DLT or a wholesale CBDC. Now, I will say the other thing it's important to point out that universal accessibility is itself a loaded term, because we know in theory, bank accounts, we have lots of people that are unbanked, right? What is it? An underbanked. It's something like, in the US, it's something like 15%, by some studies, 15% of the population, and in developing, in emerging economies, it's a lot higher than that, So is it really universally accessible? On the other hand, with cryptocurrencies, you need to have access, you need things like computers, right? And because of the digital divide, the accessibility to smartphones and computers is actually even lower than it is to bank accounts. So in that case, universal accessibility, you're really putting the quotes around, universal. So, and then you could say the same thing to some degree of cash, and arguably cash is probably the only of these that truly is universally accessible. You can literally just go out in the street and trade something and get cash. The theory of CBDCs would be that you can actually close the gap, the unbanked gap. in theory, and some of the purveyors of CBDCs or e-money or treasury money. So there's a whole nother debate out there on whether central bank digital currencies is actually the right term. That shouldn't the U.S. Treasury be the one issuing it, or the finance ministry if you're talking about other countries you're talking about in England, shouldn't be done by the Chancellor of the Exchequer as opposed to the Bank of England. I'm going to stay away from that. But what you can do is be able to close the gap, because the government or the public sector can come in and actually issue these and even provide some electronic infrastructure so to make it more universally accessible than, say, bank accounts are. Because right now, to get a bank account, there is a barrier to entry there. Like I said, in the US, about 15% don't have access. There's debate about that. Some say, and then underbanked is significantly higher than that. And emerging economies, the numbers are, astronomically higher. So CBDCs give you the potential to close that. And then finally, I do think it's important to mention a few things. And, some will say that, well, CBDCs and, if you put in there's going to be this debate over privacy, and certainly some of the advocates of CBDCs, that talk about the importance of Zcash, which really is this type of electronic cash, but with like super privacy protections in there so that it's like cash. Now, security hawks will come in and say, well, then this becomes a money laundering conduit. And what I would say to them is the most private and untransparent form of medium of exchange that's out there, money that's out, is actually cash. So cryptocurrencies, as someone I think had mentioned earlier, is there actually are mechanisms and tools to, for instance, that law enforcement use, and even if law enforcement don't know, they contract to firms, Chainlink, or I don't know, Chainlink, others, they contract to firms, and that's, and other firms out there to deal with illicit activity in cryptocurrencies. Much harder to do that with cash. It's just this, where it's just guys transacting and people transacting in person. So for those you say, well, we don't want to put too much privacy into saying that, because then it becomes a money laundering act or a place of illicit activity. Understand that there's one that's even harder to trace, and that's called cash itself, which is very hard. On the other side of the token, the people who say, well, we don't want to do this privacy, you've got security hawks, you got privacy hawks. And I know it's not necessarily one-dimensional things. These debates are very, very multi-dimensional, but for the sake of simplicity, we'll go with the one-dimensional debate of privacy and security hawks. Privacy hawks is say, well, this is going to be a surveillance system. You could design it in a way it's a surveillance system. Well, let me tell you that right now, the vast majority of economic activity and the vast majority of money supply is right here. It's your bank deposits, it's your mobile banking. That's where the money, most of the money supply is. It's not your base money, it's broad money. And most of that is circulating in the economy with guys making payments with you, writing checks with each other, making credit card transactions with each other. There is actually much less privacy there than it would be with CBDCs, depending upon how you design a CBDC. So if you're a privacy hawk, understand that right now, most of it is happening here, okay? And with CBDCs, it actually gets you a chance to rewrite those rules in a way that there is more privacy than what you get with bank deposits and mobile money right now and credit card transactions. And for the security hawks, understand that mostly illicit activity is happening right here in cash, all right? Where you have no traceability, So, by bringing it into the electronic sphere, you can actually have some traceability, whether it's bank deposits, whether it's CBDCs, whether it's cryptocurrency, where there actually are tools of traceability that we know law enforcement can use to track down, illicit activity. So CBDCs at least give you the potential. The devil is always in the details with how you implement. As they say, it really comes down to, well, what's this? How'd you design the smart contract? What you put up? Well, you still have to write the solidity code right. And you gotta agree on, you're still never going to get away from that. And that at the end of the day, money is I'll end with this and we'll take questions. Money is a social construct, right? If you design it in a way that you have pluralism in mind, any system, blockchain-based system, a CBD system, any system, if you get pluralism in, you'll get pluralism out. If you put surveillance in, you'll get surveillance out. Like anything, if if you make it easy, so for illicit activity, then you're going to get illicit activity. I mean, it all comes down to the design. There is no, and that's true whether you're designing, you want to launch your new cryptocurrency. If you want to launch something in the public sector in CBDCs, you want to launch something that's in neither, you can't get away from that. It still comes down to humans agreeing on stuff. And so I say this even as a person who is, works for a technology firm, sponsored this great conference, and is of course, is a technology bull and optimist, not a utopian by any stretch, but an optimist at least, say that technology is still done by humans, and you can't take the social construct out of it. That will not end. It just gives you more tools to deal with. So there's no way around that. And it's still people, human beings, which is why it's important to get together and have conferences and talk and figure out what's, so different people can try different things, experiment with different things. And that's really it. That's all I got, but happy to take questions and discussions.
All right, well, that's a lot. I think Lee is up first as the discussant.
Yes, thanks. Sure. Thanks, Anjan. So that's really excellent. I will confess that Anjan and I and Emily Walker and others have this a continuation of a conversation around CBDCs that we started last semester and had some really great conversations in the spring about this. It's a very rapidly moving and changing environment, and going back to that classic diagram, like what are we actually talking about? What is money? What are the different spaces is a great way to think about it. I wanted to segue, can you pull that up? And put out, because Anjan did such a great job and is actually clearly knows what's going on, I figured we're going to put him on the spot in a second. So we're looking at the central bank digital currency tracker of the Atlantic Council, which tracks pretty much in real time, like every single central bank digital currency project in the world, which now is up to 81 or 83 on this chart. So quick for the project, if you can do the filtering where you go to like launch projects. So if you go like filter by whatever state, what is it? Go up. How do you get your status? Like go just click on the launch projects. Okay, so we know where those launch projects are. Like real live CBDCs today, it's all in the Caribbean. Everyone that's real is St. Kitts and Nevis, Bahamas, St. Lucia, and they're complicated different things. So everybody talks about China and all the other countries, but the reality is, right, like today, as of this conference, the ones that are real, that are in use are in the Caribbean, not too far away from here. Okay, so now if we look at other categories at that overall aggregate, without going back through all of it, there's 10 or 12 sort of inactive projects that have sort of been abandoned, maybe 20 or 30 in research, and another like 15 moving along towards launch. Okay, so Anjan, who's been tracking this space, a year ago, if we had the same diet chart, there would be less than half this number of projects. We wind forward. What are our forecasts for the future? Are we going to see there's 200 countries in the world? We're up to less than half right now launching something. In another year or two, is this, there's the whole cryptocurrency space and the central bank digital currency space. Is this going to be ubiquitous? Are we going to get to 100% for all countries? Or are we going to see 50% of these drop off? What's your forecast, Professor Roy, based on, what's the future of money?
I'm not a professor. Wow, I am not prepared. I was not prepared to give a forecast.
Come on, you gotta go come back.
I think that I think some form of there's probably going to be a couple, probably multi-track in terms of some form of electronic money to lubricate the economic systems. I think is going to be universal, and so much like you have bank deposits and ATM machines have become pretty much universal. This is just going to be, I say and it's probably going to be largely invisible to most people. It'll just be part of the convenience and how economic activity occurs. It'll be a lubricant for it. So yeah, I don't see. I think you'll get some form. I think we're probably going towards near universal adoption. However, I chose those words very, very carefully when I said some form of government backed or rails that are maintained by the government, just like you already have now. And by government, I might mean that in a very loose sense. But there is, much like, again, banks, ATMs, credit card, you go back 20, 30 years, and you go to a developing country, it was very rare to see places that would be, that would accept MasterCard. For instance, like that was like, and I'm going further, I'm dating myself back here, but 25 years plus. Now you pretty much go anywhere, right? It's just, and so I think you'll probably see the same thing with with various governments. And it is interesting that you have the Caribbean. Yeah, that there's some research on the research there, and that there are specific reasons why the Caribbean countries have been kind of pushing forward on CBDCs. And one of them is just the convenience factor. When you have island economies, like you can't actually do everything. It's hard to travel and do stuff in person, right? And so having a really advanced and convenient rails to be able to transact both within the country and with the outside world is really important if you're an island nation. I think that's part of that was an explanation given to me by a Forbes columnist. I asked him why that exact question, like, because I was surprised. I didn't know that until a couple months ago when I saw that, the Caribbean countries were really leading the charge here. So, it's not the US, it's not China. It's they have a specific set of needs where that's more important. Now, we might see a situation, yes, please.
Oh, finish your thought.
Yeah. Now, we might see a situation where maybe not all of these they don't necessarily all call themselves CBDCs. Maybe they'll call it something else. And the word CBDC may have a very specific context. I could see it meaning like it's much more about the central bank than it is about the digital currency, where you have, where CBDCs are issued in like a wholesale environment and then used as a tool to carry out not just monetary, but fiscal policy in a more efficient manner. I could see a situation there that maybe the number of countries there and is smaller. So I guess again, and I wasn't prepared for this question, just kind of brainstorming this thing out. I think you're probably going to see wider and wider usage of CBDC, kind of more widespread, but with a lot more variation. And it's going to kind of, and a lot of it will be contextual. So in the Caribbean, what you see might be very different than what you see in another country. For instance, if you look at, what happened here during the economic recovery packages that were passed over the last year from the pandemic, there were big issues in how do you get people to even access the unemployment system. I mean, it was like waits of like weeks before they could access it. The rental assistance program has been, and again, I don't want to get into commentary on this. This is not the Maxwell School, and nor am I affiliated with it in any way. But the rental assistance, so you have one hand, the administrations have said, and the CD, and I think the Center for Disease Control, like extended the eviction moratorium. But what they haven't been able to do is get out the money to help renters and landlords pay to lubricate that, because the infrastructure, the rails to deliver public services in that matter are in the US are really rickety. And so if CBDCs can actually give you, if you implement it in that way, and again, it's a way, in that case, maybe not, they shouldn't even call it CBDC, it should be called something else. But because it's kind of sort of coming from the central bank, but the most important thing is just getting money. It's just a way of implementing fiscal policy. It's not really in the realm of monetary policy. But what if you could get the rental assistance money out so that people are able to make rent, landlords aren't falling behind mortgage, and renters aren't falling behind their rent, et cetera, et cetera. So they got the no eviction part right. Infrastructure isn't there to deliver, to lubricate the economy, so to speak. Now, then the question becomes is that kind of benefits delivery efficiency going to be a priority in the US? I don't know. Hard to say. I don't know if the US, that kind of stuff is a priority. It probably is to some degree, but I would guess that there are probably other countries in the world where that kind of benefits delivery would be a much higher priority. You guys could probably name a few. Probably in Northern Europe, probably in other places, probably other places around the world where that is going to be contextually relevant. In the US, it's like, people care about that? Well, they do, but that gets into more of a political question. Like, is that really a priority in the US? So that's what I mean, that I think you'll see a high degree of variation in terms of how CBDCs or CBDC-like instruments get implemented. So please.
Right, yeah, thank you, Angela. That's so very, very fascinating and a lot to think about. And what I'm thinking about is your observation or the stats that 15%, I guess, of Americans are unbanked.
Yeah.
And this population, this group of people rely primarily on cash.
Correct.
And it's within the cash sphere that most illicit economic activities occur.
Yeah.
So with, increasing income inequities and more people probably relying on cash, it's, I guess, like, what is the conversation to sort of address this? Because these people then are becoming, and especially because this is a group of people who perhaps are more surveyed than other groups of people, like so many, in a sense, inequities against this population of people. But what are conversations within, among technologists about using these currencies, cryptocurrencies, and other forms of electronic currencies to lessen these gaps rather than to reinforce them?
Sure. Well, those are big debates, and I don't think there's necessarily, well, there is definitely not like a single opinion within the technology sphere. And within the technology sphere and the crypto and blockchain sphere, there is a myriad of opinions. I would say that this is why that if a CBDC were to be implemented, I've tried to stay away from being too explicit with my opinion in this talk, although I'm sure you could read between the lines and pick it up. But the one place I'll be very explicit is I think it's really important that if you're going to get the type of near universal acceptance, and as well as to realize the kind of the transformative potential in here, like building privacy mechanisms into a digital treasury cash or Fed coin or CB, whatever you want to call it. And there's a couple different proposals out there in the U.S. And other countries as well, taking an approach that you use with this concept of Zcash. There's a project out there that's not very big, but it's out there, so that there's a lot of privacy into that, so it doesn't become like a surveillance tool, is really important. Like anything, it's all about how the institution is set up and their social and what the social norms are going to be, so that law enforcement is still going to want tools to be able to track money launderers like they're doing with cryptocurrencies. The question becomes, so what's the setup for that? What is the court? It's like there has to be then a process to do that. There has to be court systems. You have to go to a court to be able to do that. And so it's really important to get that part of it right. These are still human institutions, and you have to set those norms up right, or else it's going to be problematic. But part of those institutions is literally writing that into the code so that you make it really difficult and make the costs, make the barrier to surveillance very high. But at the end of the way, they're design questions.
Running on time.
Yeah.
Catherine, last question. Are we over? Well, I think we're gonna have to. Thank
you. Yeah.
Sure.
Thank you so much, Kevin. You there?
All right. No, thank you all very much. It's two very interesting perspectives on important issues. And I guess I'll turn it back to you, Lee, to send everyone to lunch.
Yeah, well, thank you, Kevin. Thank you, Anjan, and thanks, Thibault, for those really excellent presentations, and thanks for our respondents. We're going to go on to lunch break. In 30 minutes, we should be joined with our luncheon keynote. Dr. Naseem Naqvi of the British Blockchain Association. I think he sent me a few messages this morning. I hope nothing's changed in his schedule. For those of you remote, go grab something to eat too. We'll do the same here at Syracuse University, and join us at 12:45. Is that the right time? 12:45, because that's Naseem's in London again. We have to London, and that's 5:45, and that's a good London time. We don't want to keep him up too late over there. Right?
Now, one of the recommendations in the report is to build innovation ecosystems that are collaborative, quadruple helix, where government, academia, industry, and society and businesses work together for the advancement of technology. Now, this model was first proposed by Professor David Campbell and Elias Karayanis. Karayanis is a professor of business at George Washington University in USA, and David Campbell is a professor of comparative political science at University of Vienna. So these were the two guys about a decade ago. They published this quadruple helix model, which was later adopted by European Commission Open Innovation Projects, EU Climate Change Roadmap, and many, many others. And we are well aware of challenges of working in silos. We have seen recently the infrastructure bill seems to be a disconnect between the industry and government. If you look at Bitcoin mining issue, for example, a bit of a disconnect between society and industry. Industry saying Bitcoin mining is green, 70% is green, and the society and anthropologists saying, well, it's a green energy disaster. So unless we work together collaboratively, we are not going to be able to advance better science. Another example of a disconnect is a US Evidence-Based Policy Making Act, which seems to be a disconnect between academia and government. And those who don't know about it, you can read more. Evidence-based policy making is actually a law in the United States. This is now a law. And this was a bill passed in 2019 based on some scientific outputs. Basically, in the US, they looked at 10 community programs, and they found out that 9 of them were not based on randomized control studies, which is the highest form of evidence-based science. So they realized that they were wasting billions of dollars, and that was the final outcome of investigations. You can read more about that on the Congress website. So evidence-based policy making is a law in the United States. Now, a bulk of our work, what we do at the British Blockchain Association is exactly that. So is collaboration with the stakeholders, not just in the UK, but globally. Professor McKnight is on our editorial board. He's based in the USA. We have got editors and reviewers in 63 countries now. So bulk of our work is collaboration and really the advancement of this quadruple helix and establishing best practice standards and extended knowledge networks. Another important recommendation in the roadmap was the formation of subspecialty interest groups. And as I mentioned before, if we work in silos, there will be a disconnect and we will be talking different languages. So it is very, very important that we sit together. Now, obviously, this is for the UK, but I can't see any reason why this model cannot be adopted in other countries. On the right-hand side of your screen, you will see the crypto asset subspecialty group, and it's quite diverse. So there are crypto economists, Bank of England, financial conduct authorities, treasury, merchants, industry. So any policies that the countries look to make, they have to look at doing it in a more collaborative and holistic way. So we are currently inviting organizations to be a part of it. This is a 2030 roadmap, and you don't need to be in the UK or Britain. You can be anywhere. So any organization can be a part of it. The only requirement is that you have to be a member of the British Blockchain Association. And we will be producing reports and outputs at regular intervals. So your organization also will be featured in those reports if you are part of one of these specialty interest groups. So for example, if you are in DAOs or NFTs or DeFi or Lightning Network, you could join the emerging tech special interest groups. And I don't think many countries in the world right now, they have produced a national blockchain roadmap talking about DAOs or Lightning Network. So we have taken a very, very futuristic approach to this. And more information, as I said, is in the roadmap itself. So for example, this is a research that was published by Professor Karan about e-voting on the blockchain and various how various countries are exploring it. So if you, for example, if you are interested in e-voting, you could join citizens and public services as special interest groups. Impact is very important. We have heard that recently. How do we know that blockchain programs are working and making an impact? And I think that is a very, very important question. All of you in the audience, if you're working in blockchain crypto assets, you have to ask yourself, what am I doing that is making an impact? How am I going to measure that impact? And how do I know that the blockchain solutions that I'm proposing to the industries, to the government, are making an impact, and they are actually better and more efficient solutions than the legacy system? And the only way we can find out about it is obviously to evaluate the impact of these various programs. So we came up with these 8 key impact areas. Obviously, there is academic impact. How many people have cited your work, your H-index and other things, but also more importantly, the societal impact in terms of quality of life, environment, impact on policy making, and so on. So it's very important that DLT interventions are reviewed over time to ensure that they remain credible and relevant for the communities that you are intending to serve. Universities are awarded based on the impact that their research have created, whether it is academic or society. So in the UK, we have Research Excellence Framework, REF, and around 30% of the funding any university receives or public institution receives is based on demonstration of impact. So it makes sense to measure and audit the societal impact of blockchain applications. In the USA, I was looking the other day, the National Science Foundation, I believe you have. So NSF has a budget of about $8.5 billion per year, and it grants about 12,000 grants per year to various public institutions, universities, and there is a lot of mention of societal impact there as well. So I think it's important that whatever you're doing, you should look into the impact. And there are various different frameworks. This is one of them, inspired by the UK Research and Excellence Framework. Maybe you have some other framework in your country, but it's important that so you start with the basic science and then you move up all the way to availability and distribution. So impact in ideal setting, in the lab setting, and then the real world, and then the biggest effect on most people. So moving all the way up from basic science to efficacy, to effectiveness, and efficiency. This is a research that was published last year on evidence-based blockchain, looking at evaluating more than 500 DLT startups, blockchain and crypto companies. And the research showed that more than half of the blockchain firms showed no explicit evidence of the problem to be solved. It was not featured in their white paper or blue paper. And approximately 1/3 failed to cite comparison and intervention analysis, what they are doing, why is it better than the competitors, and just a few other 2% demonstrated evidence of impact and outcomes backed by peer-reviewed scientific information. This research again is open access, is available on the JBB. We have now seen startups and companies adopting evidence-based blockchain framework. This is another open access research looking at the use of blockchain for agriculture and farming industry. And this case study has actually used the PCIO framework of evidence-based blockchain. What is the problem? Comparison to what? What is the intervention? And what are your outcomes? And you have to make sure that at each of these steps, you're looking at high quality peer-reviewed scientific information, meta-analysis, systematic reviews, randomized control studies, and not just opinions and blog type articles. So at each stage of the framework, you are collecting a high quality data. Another recommendation was around sustainable development goals. I think this is important. UN SDGs could create about 12 trillion in market opportunities, and 300 million new jobs. This is on the United Nations website. They're saying that taking action on climate change alone would result in savings of $26 trillion by 2030. This research that we published in the JBBA is on the industrial symbiosis networks, which is using the waste products of one organization as raw material for another. And it showed that using ISNs on the blockchain alone could generate a net economic benefit of 1.8 trillion euros by 2030. So there is a lot happening in the SDG space in blockchain. Another recommendation was use of blockchain for government and public services. This research was published by the Companies House UK, which is an organization that collect information of all the limited companies and businesses that are registered in the UK. And they looked at the potential for blockchain to be used by Companies House for sharing information, fraud mitigation, and other things. So if this is something that interests you, then there is a lot of work going on and being explored by public services and government organizations. And as I said, there are 20 recommendations. You can read all about them on the website in the paper itself. So I'm going to talk a little bit about the British Blockchain Association, what we do, what's the ecosystem look like. So essentially, this is what it is in a nutshell. We are a quite unique system. We are the world's first, in fact, that actually do all these 7 things together under one umbrella. There is no other blockchain association in the world that does that. So we are working with the governments and regulators to author the roadmaps and the excellence standards framework, as I just explained. We publish a peer-reviewed scientific journal called the JBBA, which is open access. We are home to the Center for Evidence-Based Blockchain, which is a multidisciplinary think tank hub. Every year, we host our flagship scientific conference called the ISC, International Scientific Conference on Blockchain, where we invite authors to submit their abstract. I'll talk more about that in a second. We also award fellowships to exceptional scholars and industry leaders in the field of blockchain. We have a student forum, and we are also home to Blockchain Associations Forum, which has, as of today, 48 countries, blockchain associations, and we convene regularly to discuss some of the pressing challenges around adoption of blockchain and crypto assets. So the JBBA, just a bit about the different components. The JBBA is an open access journal. It is peer-reviewed in a different fashion. So when you submit your work to the journal, the reviewers don't know the identity of the authors, and authors don't know the identity of the reviewers. So your work is assessed purely on the basis of merit and not on the basis of which institutions you are coming from. We are also available in print, the only blockchain journal in the world that's available in print, the world's first. And we send the copies to various libraries around the globe, 2 or more. It's indexed in around 100 libraries. We also offer language editing and translation services to authors. We publish video abstracts on our YouTube channel. We are also on the blockchain and indexed in the directory of open access journals, which has over 500,000 readers and downloads per month. So we are much more than a journal. We are quite a complete ecosystem for authors. Here is one of our authors talking about utility of blockchain for climate mitigation. So he published his work in the journal, and then we invited him to submit a video abstract as well. And this is available again, open access on our YouTube channel. Some testimonials from professors and industry leaders from around the globe. As I said, we send the copies to around more than 4,000 blockchain influencers and thought leaders every 6 months, and also to various libraries around the globe. So as an author, it would be an extra publicity and promotion of your work. So it is published immediately online anyways, as soon as it is accepted, but then it is also made available in print and the hard copies goes around the globe. And we don't charge author any fee for this. They don't pay anything for the printing. We send them around the globe on their behalf. There is no fee for that. So here is one of the industry researches, which was published in the journal around non-fungible tokens and blockchain. And this infographic is created by our IT team at the Center for Evidence-Based Blockchain. This is another feature of the journal that currently the only journal in the world that offers this service. So if you have published your work in the journal, we will help you design these very easy to understand infographics, which are good for not only for governments and policymakers and regulators and even lay people, because sometimes the research is not very easy to understand. So we make it easy to understand for readers. So it increases the reach of their work, the visibility, the impact, and they are shared much more widely, obviously, because you could share this infographic on Twitter, on Facebook, on LinkedIn, and Instagram, and everywhere, comparing to sharing your PDF of your paper. So we offer many more services. Because of time, I will move on. So Center for Evidence-Based Blockchain is, as I mentioned, is a think tank hub. We have 5 components of this. So if you have published your work in the journal or at our conference, you will automatically become a member of KEB. You don't pay any fee for that. We also invite our members and institutions to be a part of it. Our industry think tank, student forums, and we have an online forum. This is what it looks like. And if you are a researcher, here is one example. One of the researchers who published his work is a part of KEB, and he's saying, I'm preparing a scientific paper for Marie Curie grant. If you have knowledge of similar initiatives in other countries, let me know in the comments. So it's an ecosystem where researchers connect with industry leaders, discuss grants, fundings, and other things. And industry leaders can connect with the best and the brightest minds in terms of scholars, researchers, and so on. So it's a complete ecosystem. We also arrange conferences and meetups around the globe. This is me talking, giving a talk at the Commonwealth. Commonwealth is, some of you may know, is home to more than 50 countries. 2.4 billion people in the world lives in Commonwealth, and they invited us to give their policymakers a talk on blockchain and cryptocurrencies. So we engage regularly with government organizations, policymakers, and regulators. This is another infographic on utility of blockchain for climate mitigation. Blockchain Associations Forum is a new initiative from this year. And it's, as I mentioned, this is a platform where blockchain associations, national blockchain associations from around the globe, they can become a part of it. And as of today, we have 48 countries, and it is growing. So if you are a BBA member, you can become a part of the Blockchain Associations Forum as well. We have published 2 reports now. And again, they are available on the website. So if you want to learn more about this ecosystem, this information is available. Scientific conferences is our flagship event. We host a scientific conference every year in March. Next conference is on the 14th of March. Call is open for abstract. So if you want to submit your work, please do so now. The conference is going to be online. So you don't need to travel. You don't need to spend any money on hotels and travels and flights. You can present your work from the comfort of your own home. And we hosted our conference this year, and we had a keynote talk from Hester Pierce, SEC commissioner from US. This is one of the researchers from Portland State University, Professor Christy Yuthas, presenting her abstract at our ISC on the topic of enterprise blockchain. This was a good paper, so we decided to feature it on the cover page of the journal. So as you can see that it's a full loop, really. So you submit your abstract, it gets peer reviewed. We invite you to present your work. then you publish your full paper, then it gets peer reviewed again, then it gets published online and also in the print format in the journal, and then the journal is distributed worldwide. It's extremely good value, I think, if you want to publish and promote yourself globally. So I would recommend you to submit your work. We are also home to the fellowship of the association. We have academics as well as industry leaders who are fellows of the association. This is John Wolpert, who is the founder of Baseline Protocol and also Ethereum mainnet chief. He was awarded a fellowship last year. We have members of the association from the largest university in the UK, the Open University, to Government of Gibraltar, to one of the largest audit firms, Baker McKenzie, and many other crypto and blockchain associations from around the globe. We also host regular events for associations and for our members. Our next meetup is on Sunday. They are free. So I would encourage you to register and attend. Thank you very much. These are my details. I am on LinkedIn, and this is the email. If you have any questions about the association or about our initiatives, or if you want to participate, please drop a line. You can connect with me on LinkedIn. And last but not the least, how can you participate and benefit from our ecosystem? Become a member, submit your work to the conference, publish your work in the journal. If you're a student who want to set up a student forum, get in touch with me. You can contribute to the UK's national blockchain roadmap, join various subspecialty groups. If you are an academic who wants to join the review and editorial board, please drop me a line. If you know someone who is an exceptional individual, nominate them for BBA fellowship. And you could also register for free for our monthly meetups. Thank you very much.
Hey, Dr. Naqvi. I got a couple questions for you. So one of my questions is the future for the evidence-based blockchain. And what do you kind of see the major challenges with this adoption?
Yeah, I think this is a good question. I think future has already arrived. The national blockchain roadmaps are being built on the EBB frameworks. UK is the first, but I'm sure many more countries will adopt it in future. We have now over 24 peer-reviewed research papers that have actually cited the evidence-based blockchain frameworks. European Commission report last year talked about evidence-based policy making for DLT applications. I'm also aware that IBM has published a book on enterprise blockchain, and on the very first page, it talks about enterprises to look at what is the problem that they are solving, what are the outcomes. So actually, it's been adopted across the globe by enterprises and the national blockchain frameworks and policymakers. So I think the future is bright. The challenge I think that I see is some enterprises, they don't know what it is. I think they are not aware of the fundamental frameworks, but hopefully my talk today and the other talks that I give around the globe help them to understand what it is. It is very, very simple. It is 5 A's: ask, acquire, appraise, apply, assess. Anybody could do it, and everybody should do it who is in the blockchain space. So you ask a question, what is the problem that you're trying to solve? Acquire, so you pull together all the information, starting with the most highest quality information, peer-reviewed research. Then you appraise that information. Is it good quality? Which bits are relevant for my practice? Then you apply the results of those research to your area of expertise, and then you publish the outcomes. So ask, acquire, appraise, apply, assess. 5 A's.
Okay, I think we've got one more question for Dinesh. Do you want to raise your question, or do you want me to go ahead and read the question?
Sure.
I'll go ahead and read.
Can you hear me okay?
Yes.
So first of all, I wanted to say that was just a wonderful presentation, and thank you for everything you're doing in this space. I'm a physician myself, and as a colleague in healthcare, I'm curious as to what you consider to be the most promising applications of blockchain in that space in healthcare.
In healthcare, most promising application?
Oh, yes. That's right, yes.
So is that your question? Did I get it right?
That's right.
Yeah, I think the most promising application of blockchain is how it can help the healthcare ecosystems. I'm a very big believer in ecosystem. As I said before, I think if you apply blockchain solution to any one area where there is no kind of stakeholder collaboration, it won't work. And really, I have seen many examples. I work in NHS as a consultant. There's been a lot of talks about applying distributed ledgers, but I don't think they will work, because there are 4 managers sitting in their office discussing their brilliant ideas. I think you have to take stakeholders on board early, involve everybody, because this technology is going to run in the background as an infrastructure. You have to have stakeholders on board who have a better understanding. Some understanding is better than no understanding. And then managers, funders, users, everybody should be on board. They should have received some education on what it is. And then you look into how to apply the various solutions. And whatever blockchain you use, I think that is secondary. The most important thing is that the stakeholders don't know. If they don't like it, they're not going to use it. So those systems are not going to work. So you have to start with the basic education and information, raising awareness of the stakeholder.
Well, thank you very much, Dr. Naqvi. Thank you very much.
Thank you.
You want to introduce the next moderator?
So thank you so much, Naseem, for that. That's really appreciate everything he's been doing. And we previously had Syracuse University students participate in that ISC conference a couple of years ago, just pre-pandemic, doing excellent work. So if those here should think about that and ways to engage further. Without further ado, we're moving quickly to the demo session. And I believe Tom, can you pull up Tom Cooksey? Remote. He's supposed to be our moderator for this.
Yep, I'm here. Hi, Tommy. Hi, I'm Tommy Cooksey. I'll be your moderator for this this next demo. So I believe we have some demos that are going to be coming up for Edgucoin, MuniBond, Takapool, and then of course we're going to be talking about SIMBA chain. Just real quick, are the folks that are going to be doing those demos ready? Okay, so as they kind of get set up, one thing real quick that I'll kind of talk a little bit about with SIMBA chain, some of the things that we've been able to do in education. SIMBA chain, we have this really interesting product called our Quick Start program. And so as we can imagine with any blockchain, you're going to have assets and you're going to have transactions that are going to be basically making state changes to those assets. So we have an easy way to mock that up and build out that workflow. So then you can conceptualize it and then see it in a web platform so that you can interact with those page controls and start to see the results of what that indexing on a blockchain would look like. So many times what we're trying to do is, of course, provide immutability and digital cryptography to different workloads to provide the various different attributes that we have from a blockchain that we don't currently have in our current situation. So many times after students learn that functionality of a blockchain, they want to apply it. And so we try to provide the tooling to make that application easy to use without having to do all that heavy lifting to learn the underlying materials of a blockchain or the underlying technologies. So with that being said, I'll hand it over and to our first demo. Thanks.
Awesome. Thank you so much, Tim. Abu, how much time do we? It's like 6 minutes.
There's 4. No, is there 4 presenters?
I don't know.
Yeah. I think we have until 1:40, so each of you have about 10 minutes apiece.
Oh, okay, great. All right. Hello, everybody. My name is Catherine Forrest. For those who weren't here earlier, I'm a rising senior in the iSchool Fast Track Master's student. So today I'm going to be presenting on our blockchain final project, my partner isn't here today, is Zach Goldstein and I developed the Edgucoin platform, which is blockchain education made simple. So the problem is that the nature of blockchain technology and cryptocurrency is hyper modern, ever changing, and complex by nature. It makes it a struggle for non-blockchain enthusiasts to understand. There are solutions on the market, but they are dense, boring, and none of them provide the complete package. So the Edgucoin solution is a blockchain-enabled education network utilizing Ethereum that rewards its users with crypto upon course completion. Our goal is to provide entertaining and engaging education that makes learning blockchain topics effective and more importantly, enjoyable. So we, just from a startup perspective, our idea is that we would target the individual consumer, as there would be less barriers to entry, easier operations, it's cost effective, easier to find clients, faster sales cycles, and larger volume of clients. We also have developed solutions for private universities and business enterprises. However, from just a startup perspective, we would be rolling those out at a future time. So talking a little bit about our competition. So we have Coinbase, Binance, BitDegree, and Edgucoin. I'll start off with Edgucoin. Edgucoin is a blockchain-based decentralized global education service. They utilize AI technology to digitize education services and to connect participants from all over the world to educators and their educational services. They're not actually providing resources to learn about crypto and blockchain. They're essentially just using blockchain to power their network and helping educators connect. So BitDegree is a platform that has a series of classes on cryptocurrency, less on blockchain, but some basic presentations there. However, it's not connected to cryptocurrency as a reward, as an incentive. Binance Academy offers insights on crypto, blockchain, trading, investing, and privacy. They provide some really, really nice animation videos, and they're able to rank them in beginner to intermediate advanced. However, they don't have any interactive elements. They don't have any, types of quizzes, or it's kind of, a one-dimensional media education platform. And then we have Coinbase. So Coinbase, when we were developing this, they just rolled out Coinbase Earn. And so we were, that was kind of a deterrent when I saw that on my phone, the advertisement where it was like, learn about crypto and be rewarded with it, right? And so where Coinbase has a slight edge is that they're able to offer, users rewards in crypto for learning in different types of crypto, right? What that's available on their exchange. However, upon using their service, these are really, really short educational pieces. It's kind of like videos and a little bit of documentation. However, it's really not enough to actually get a all-encompassing understanding of these topics. And a lot of people just use it so they can get the free crypto that comes with it. All right. It's not working. Okay, awesome. So we have several learning module types. So these courses will consist of pre-recorded lectures, interactive activities where users put their skills to the test, quizzes at the end of each section, a final project that would be worked on throughout the duration of the course, and a final exam for users to show their new skills. And so once users complete the course, they're rewarded with Edgucoin. So can you go to the next slide? So here we just kind of have a layout of what one of our courses would look like. Here's the cryptocurrency finance course. This is primarily for the the user who is just interested in that kind of DeFi angle, maybe not super interested about blockchain technology, but what we do is we want to give them kind of a really all-encompassing education. So we make sure to go over all of the basics and then lead into what's most of interest to them. The idea at the end of this upon completing this course, you would have an idea of how to invest in, or not invest, because you don't invest in cryptocurrency. That's, I didn't mean, that's a slippage, but how to, purchase cryptocurrency, what all of these projects that are out there are and how to understand what they're doing, how to build a wallet, etc. All right, next. Okay. Awesome. So this is our Edgucoin decentralized distributed network. So the idea is that we would have, here are some of the types of nodes that we would have on the network, right? So we would have, as our main validator, we would have the blockchain education network known as BEN. Our kind of lower level validators on the network would be staking nodes, universities, individuals, and enterprises. All right, so talking about the Edgucoin token, so why have a token? Edgucoin is a reward for users that are learning on our platform. Once they complete their course of choice, Edgucoin is then unlocked, giving them the ability to trade on exchanges. Their new knowledge of crypto and their wallet full of Edgucoin gives them the ability to exercise their new skills. Users also have the option of purchasing more courses at a discounted price by paying for it in Edgucoin. So the consensus algorithm that we would be using to verify transactions on the blockchain is called proof of stake. A lot of you have heard about proof of stake. It's a mechanism in which users can stake their Edgucoin to receive small rewards for validating other transactions on the network. This is much more energy efficient and sustainable than mining, which is proof of work. This approach is a friendly solution for like crowdsourcing to approve transactions by having peers on the network working together rather than, oh, okay. Yeah, so that's proof of stake. And or rather than competing, so they're it's a friendlier way. It's a massive incentive for our users to hold Edgucoin. And next one, we have a demo of our we won't do. You want to do the demo or?
That's the whole point of the session.
Oh, sorry. The Edgucoin smart contract was hard-coded in Remix Ethereum IDE. Then we deployed our contract to the Roundtable testnet utilizing our MetaMask wallet. The Edgucoin smart contract was compiled and deployed using injected Web3.
Here's the pending transaction that is sped up of the deployment of the contract. Takes around a minute, and then now we're going to add the custom token, which is the contract address. As you can see, there's a lot of Edgucoin in here. And then we're just going to add it to our second wallet. And it's the same exact process, adding a custom token. And as you can see, there's zero Edgucoin. Now we're going to copy the wallet address and claim our tokens. So for completing the module, we'll get 5 tokens. And here we're just approving the gas rate. Now we're going to speed it up a little bit again to wait for the pending transaction of claiming our tokens. Now, as you can see, 5 Edgucoins have been claimed. And in the other wallet, 5 Edgucoins have been taken out of the funding wallet.
All right, so yes.
You summarize it.
Yeah, so just to summarize really quickly, this was just, we actually created Edgucoin, the cryptocurrency with the ERC-20 standard, and we were just testing on the Roundtable testnet to demonstrate that, the real application of our future plans are to utilize SIMBA Chain's enterprise platform to write our smart contracts, the smart contract as a service platform. Codified staking could be implemented for proof of stake. Our users would be using MetaMask wallets, and we would be utilizing the ERC-20 token standard. Thank you all so much.
Really great job. The next up we have is MuniBond, decentralized MuniBond. And so while MuniBond is getting set up, one thing that I really liked about that presentation is it gives you an opportunity to learn and earn, right? So there's a reinforcement to the earning, an earning mechanism there. There was a question that came in to the chat. They wanted the contract address to Edgucoin, so they seen the demonstration and want to get an access to the contract address. So if you could provide that Ethereum address, that'd be great, and we'll answer that in line. So it looks like MuniBond is getting set up. Are you guys ready?
Yes. Yep. So real quick on the demonstration, is very similar to the one that you just saw. We just wanted to show the application of a token transfer, because that's likely how one example of how you can implement municipal bonds on a blockchain. You go ahead. So we have a demo video. It's about 5 minutes. It's really going to take in.
We're not going to play all 5 minutes. You're going to jump through it. Go.
In this demonstration, we're going to see a basic token transfer between two accounts, along with a couple of features of our municipal bond smart contract. Now, there's a couple assumptions we have to make. First of all, that our contract has already been deployed on the private blockchain. Contract terms have already been agreed upon by all parties involved. Investors have already been validated by the city and any regulating and financial entities. There's going to be 2 accounts demonstrated, the city token distribution account and 1 investor account. And we're going to be switching between these accounts in order to demonstrate both sides of the token transfer. Now, in front of us here, you can see that we have some functions of our smart contract. We're not going to be using all of these today. We are going to be using the MetaMask wallet here to represent both of our accounts. Here you can see we have the city token account, and they're the ones that hold the tokens. And here you can see they have a balance of 5 million MBD or MuniBond. And then we have John S, which represents the investor account. You can see here that John has 0 tokens. We can also check balances with our balance of function directly from our smart contract. So let's grab John's address and input it into our function. And we can see the contract says John has 0 tokens. Let's do the same for the city account. Copy that address, input into our function, and you can see that the city account does indeed have 5 million tokens. Now, what if John wants to invest?
So for the rest of the demo, really, we just go into showing how you can transfer tokens between accounts. And why that's important here is because the token can contain a lot of different information about the municipal bond, like the interest rate or the maturity or the date that it was issued or the city that issued it or the credit rating, things like that. And so using Solidity, we created just a really basic ERC20 token contract to show the transfer of the tokens between accounts. And you can validate this with any number of nodes on the network. And we show this later in the demo with some Ganache accounts. But the point of this is there is the infrastructure out there already to support this concept. And so we began by just showing some really simple transfers of these tokens that could be applied to our concept. Thank you.
All right, wonderful. Great job, guys. And so next up, it looks like our final is going to be, my apologies, that went really fast. So last is going to be, yes, thank you. Thank you very much. Yes. And one question that did come up from Garth Maynard is on the last one, if you've considered using an NFT for that project. And so if you do you want to come back?
Coming back now.
Yeah, just to the front.
Yeah, can you say that one more time, please?
Yeah, have you considered using a non-fungible token in your solution?
Yeah, so it could, and I think that's likely what would happen, just because for this you're just trying to transfer the information. You're not necessarily having something that in and of itself is a currency. So I think that's an excellent point. This was made for the demo for Professor McKnight's blockchain course, and so at that point we didn't really dig into NFTs at all. But I think that's a great application.
Yeah, initially when we want to introduce, just do a proof of concept and then look at other alternatives and basically do further research like NFTs. So we didn't necessarily, it was on our radar, but we didn't necessarily want to had enough time in our particular demo.
Yeah, Yeah. Yeah. I've always thought that, when you think that fungibility, right? When you want to have utility from your system, you're going to use a fungible token. When you want to have provenance of something, then maybe the non-fungible token will be the path you'll want to take. So definitely a great question there. Great job, guys. Next up, is everybody about ready? Okay.
Coming up now.
All right. Wonderful. And yeah, Takapool, sorry.
Yes. Hi, how are you, everybody? So glad to be here again. Well, if you heard the presentation yesterday, so just as a reminder, Takapool is a crowdfunded Takapool pool through Zakat donations. So donors put their funds in a traceable manner through smart contracts. And then financial services are distributed to communities in need in a sustainable and ethical way through civil society organizations. And this is more of a promo video, less technical than the ones that we've been seeing. So, Abu.
The best music.
Well, thank you very much. If you have any questions, just let me know.
Just to clarify, for Tom, we were expecting you now to say something more about the blockchain education platform.
Yeah, absolutely.
And do you actually have a demo that you can pull up of it, or show something, a screenshot?
Yeah, so what I'm going to do, so earlier I had an opportunity, I knew we were a little pressed on time. So what I wanted to do is I wanted to go ahead and just pre-stage a few things. So what I have here is, I want to show you a little bit about the product. As I mentioned earlier, we have a product that we use a lot in the educational space that has caught quite a bit of traction. And the reason it's caught a lot of traction is because it's easy for the professor to explain the concepts of a blockchain, the things like decentralization, immutability, cryptographic primitives, creating anonymous and autonomous data that has transparency built in, all those features of a blockchain that we want to pull back and we don't have in our workflow right now. We want to be able to build it. And a lot of times you don't necessarily need a computer degree or an IT degree in order to be able to understand that. You might not even want to go into Remix. Heck, you might not even want to learn about a wallet. So what we've done is at SIMBA is, I'm going to go ahead and share my screen with you here. But what we've done is we've created this really simple, we call it our SIMBA Quick Start platform, but it does just that. I mean, it's a platform where we have an area here where after you've signed up for your account, you can come in and create a wallet, and we have the different standards. So our remote wallets are for Hyperledger, your private networks. We got the Stellar wallet that's more the Bitcoin standard. We got the Ethereum wallet, of course, it's going to be the Ethereum Bitcoins, the Ethereum, I think it's Bit 15 or whatever that standard is for that wallet standard, right? So we have all those standards for the wallets, for the addresses of the public and private keys. So you can easily generate those in a Web3 hot wallet that's an in-browser wallet. So the reason for it is so that you can just start to structure up your solution. Well, what's your solution going to be? Well, it's going to be a smart contract, because a smart contract, as we know, it's just the logic, right? It's the logic that we want. Usually I say it's the structure to our workflow. So when we think structure and content, it's the structure that we're building for transactions that are coming through. So when we build that structure, here, if we have a farmer that's bringing something into a co-op, for instance, like roasting some coffee, well, we could have information that's going to be derived from that farmer as an asset and put those in as data primitives, right? So we can define it as a string or as integer, and do that programming thing that we talk about with data minimization. We can start to teach the end user how to do that, as they're modeling this up. And they're modeling up this workflow. They know this workflow better than the programmer. And what we're able to do is we're able to give them a canvas to easily just define what an asset is, what a transaction is, create the relationship, and they're just, it's like drawing a map, right? And generally speaking, they don't have to know anything about programming. But what they do have is they have a back-end set of data that's getting generated as the inputs for the smart contract. Now, do you need to add additional logic to this to add constraints or things like that? Yeah, possibly so. But with this, you can also just go ahead and come up here, and the last piece of our application is you can come up here and you can build an app on top of it. So you've created the logic, and now you can generate an API endpoint where you can hit, this website.com/API/generate new farmer, right? And have a new farmer get created by calling a post request at that endpoint. So that's where we can come in, and we basically just say, hey, I want to build a new blockchain app on any of these blockchains. And what we try to do at SIMBA is we try to stay blockchain agnostic, right? When we think about the big P's, right? The 3 P's: people, process, and platform. We want to stay platform agnostic and manage at the process level, and then leverage the strength of our people. So we're giving our people the tools that they need in order to be able to get the work done, right? And so that's what we try to do here is we just give them some easy to use tools, start mocking some stuff up, and then figure out if it works or not. If it doesn't work, then that's fine. Just try something different, reiterate, right? We call that fail fast in IT, but in essence, we're just trying to get to 80%, usually 80% coverage of whatever our initial goals were. And if we can cover that 80%, then maybe we're ready to go to market. But this is a way for us to start to iterate on and use different renditions of a program or of a resource to figure out what works and what doesn't. So at that point, so here we can say, hey, we're going to put this on Ethereum. We can define the blockchain that we're going to put this on. We actually even do this thing called Circle of Life that we can use for our smart contracts. And with that, that will allow you to deploy that smart contract. So here I can come in and say, hey, I want to deploy, this coffee smart contract that we were looking at. And I'm going to call this demo coffee. And it's just going to build out an actual application for me. So all I have to do is just go ahead and unlock my wallet. And it's going to actually generate and deploy this application out to a blockchain for me. And it's as simple as that. I mean, I just took that logic that you saw in the smart contract. It's generating this out, deploying it, and it's going to actually create an endpoint for me that I'm going to be able to manage all this from. So I'm not going to wait for this to finish, but I'll show you what that endpoint will look like. Here's those APIs. And then I can just call any of the APIs through my standards gets in post. And we also have an integration for managing the API that gives you the opportunity to grant access to the actors that are using your system. So so that's the front end piece. And we have a lot of other tools that we can use for aggregating data and querying against this data and monitoring this data and getting notified of state and things like that. But generally speaking, the concept of SIMBA is it's simpler blockchain applications. Dr. Ian Taylor, I know we heard from him earlier today, but when he created with Joel the SIMBA, they wanted to create tooling that was easy to use and remove a lot of that heavy lifting, all that DevOps work that you got to do just to be able to start to enable a blockchain application. People talk a lot about dApps. Well, you could even take an existing application with this interface, with this API, and just make it blockchain enabled. It's not it's not a decentralized application. It's just an application that you currently have where you're taking advantage of the features of a blockchain that you may not have had already built into your application. So it's easy to use, it's simple, and it allows you to really start to get to work on an idea. So hopefully that helps everybody understand it.
Thanks so much, Tom. That's great. Wonderful to see the continuing progress of SIMBA chain and your tools, which we look forward to continuing to use here at Syracuse University in our education and research. Who's up now?
Hi, hello everyone. Welcome to the Academic Industry Government Blockchain Research Roundtable Blockchaining IoT. We're fortunate to be joined on our panel by leading innovators and implementers in secure cloud architecture and the Internet of Things. I'm Vince Plaza, student in the Doctor of Professional Studies program at the iSchool, and I'm joined by Catherine Forrest, who is president of both YTech and CryptoQs, as well as being a star student in the School of Information Studies. Let me introduce our exciting group of panelists. Our first panelist is George Newman. George has over 3 decades of experience as a technology leader. In his current role as CEO of One Planet Education, he has led the effort on promoting STEM education on a global scale. One Planet has teams operating in 14 countries on every continent except for Antarctica. Their teams rely on a secure cloud architecture for projects ranging from sustainable agriculture to emergency response. Please join me in welcoming George Newman to the panel.
Thank you, Vince.
By Hank Brandt. Currently a senior solution engineer at VMware, Hank has over a decade of experience as an innovator and educator, including multiple adjunct professorship roles at colleges and universities across the Northeast. Hank will share his insight on how VMware's blockchain technology will secure the Internet of Things. Please join me in welcoming Hank Brandt to the panel.
Thank you.
Our next panelist is Tim Kelly. Tim is part of the research and development team at IMCON International, producers of the Internet Backpack. The backpack is designed to bring internet connectivity to 90% of the planet. Tim's work helps first responders, remote workers, and educators, especially in degraded environments. Tim personally handed an internet backpack to Nobel laureate and former president of the Republic of Liberia, Ellen Johnson Sirleaf. President Johnson Sirleaf personally carried the backpack to the remote village of Julajwa to deliver internet learning to the community for the first time. Please join me in welcoming Tim Kelly to the panel. Joining team is Dean Skidmore. Dean is the national chair of the National Public Safety Telecommunications Council's Public Safety IoT Workgroup. He also co-leads the Global City Teams Challenge Committee for Smart Public Safety, a group sponsored by the National Institute of Standards and Technology. Dean is founder and principal consultant at a private consulting company for advising public safety agencies on mission-critical communications and IoT cybersecurity best practices. He has generously shared his insight into what blockchaining IoT means and creating a secure cloud architecture. Please join me in welcoming Dean Skidmore to the panel. Our final panelist, and we're very excited to have him here, is Travis Teague, the developer growth lead at Helium Systems. If you missed the announcement, Helium just secured an additional $111 million of funding, fueling their already explosive growth in peer-to-peer networking. The People's Network, as it is called, climbed from 7,000 hotspots a year ago to over 127,000 hotspots today, not to mention that there are an additional 500,000 hotspots on backorder. Earlier this year, Helium created a developer kit for users to build their own special purpose device using the WiseBlock developer platform. In April, Helium announced their plan to create the world's first consumer-owned 5G network. Travis brings a unique perspective on end-to-end secure cloud architecture. Please join me in welcoming Travis Teague to the panel.
Thanks a lot for having me today.
We've put the panel together for you, the audience. We invite you to submit questions in the online chat or directly to the speakers at any time. We're going to start with an introductory question to each panel member, and we look forward to including questions from the audience. Catherine, take it away.
Thanks so much, Vince. I would just like to extend an invite to all of our, extend a welcome to all of our amazing panelists. We're really lucky to have you here today. So our first question of the day is for George. George, your work on regenerative farming projects on the African continent is a perfect use case of how IoT can be both a teaching tool and change agent in an important part of local economies. Can you describe a recent project and how you use devices in the classroom and the field? How are you currently using blockchain to secure and manage sensors and other critical components?
Thank you very much, Catherine, and everybody. And thank you, Professor McKnight, and everybody for a wonderful job in this workshop and your support. Well, that question, points to our work that we're doing internationally, particularly in Africa and Outback Australia. We focus on underserved communities, that are, pretty much a raw material. It's like an open canvas. It's a infrastructure modernization effort, really. We're looking at applying K-12 education to sustainable community development. We're focusing on the 2030 SDGs. I think we cover about 11 of them. And we started work, of course, in K through 12, as mentioned, in bringing new technologies to places that are in need of, covering the 2030 goals. The first one being sustainable agriculture and food security. Hunger is the main one. So immediately we're working with the ministries of agriculture. So we go from schools into government, and then industry, of course, bringing in my IoT partners such as Helium and IMCOM, who are here on this panel, in their technologies to connect the places at first who have poor connectivity, and then to bring IoT to modernize the farming production process. So we would take in a big community, a farming community in Western Kenya, and we're doing specifications for expanding from 10 schools in one farm to 100 schools and 100 farms. And those involve thousands of sensors. The project suddenly is just scaled into a very large systems integration project. We're bringing in IBM weather systems, big data, S3 digital mapping, and others to complete the circle here. So it's a comprehensive solution with IoT kind of as a core technology. Well, with Helium, we automatically get blockchain because that's their backbone network in connecting the gateways of what we need to connect the sensors to the internet and then to the cloud systems. So yeah, and the security aspects of it, and not to mention the HNT mining is another added incentive of which the Helium has done a brilliant job. And they've just announced a 5G service which is yet to be fully unveiled and defined, but a very interesting addition to the basic LoRaWAN, low bandwidth network. So yeah, that's where we're landed. We're in Australia in the outback setting up sensors. We're in an ecosystem restoration or test bed, which covers water, forest, everything that we want to cover in the future for these communities, not just farming. So we're gearing up, and education is our thrust, but technology is being applied in a way that's really useful for a community. And we've got all sectors involved.
Thanks so much, George. Doing incredibly necessary work for sustainable agriculture and elevating, nations around the world and bringing them kind of into the loop. My next question is for Hank. Hank, the vulnerability of the legacy power grid continues to make news as an easy target for nation state hacking. In the case of smart grid, devices will be much closer to the generation and delivery of power, for instance, at a substation rather than a data center. In this more distributed processing architecture, how might VMware's blockchain technology enable a trusted and secure smart grid network?
Thank you, Catherine, Vincent and Professor Ignite for inviting me here today. So VMware's blockchain technology leverages the Byzantine, also known as malicious, fault tolerance at its core. Everything within the platform is done by consensus with guaranteed safety, also known as data integrity and reliability, and availability, even when up to a third of the network is compromised. To explain this further, if you take 100 IoT-based devices, for example, call those nodes, and run a smart grid power application on top of them, each one, and put that within the VMware blockchain technology to create a smart grid network, you created a platform in which the network's integrity and reliability cannot be compromised. Blockchain consensus ensures fault tolerance throughout the grid. If one or several of those nodes gets compromised and the blockchain network detects that, the malicious actors will not be able to move laterally and affect any of the other smart grids and affect the cluster. To extend this further, we can then leverage some of our other technology, such as our NSX intelligence, to take that information that's transmitted from the blockchain network, stating that it's a detected malicious device, and through the use of our NSX advanced threat protection and network detection and response tools, we'll be basically able to air gap that device to ensure that no lateral movements can be made. The same intelligence can be used for our security endpoint solution called Carbon Black, and particularly our application control that's can essentially harden the device further.
Thank you so much, Hank. All right, our third question is for Tim. Tim, George and Hank shared their use cases that will only work with the right hardware to back them. MCON produces a version called the Internet of Things backpack, making IoT front and center in how MCON sees the backpack being used. The backpack was introduced yesterday, but can you explain the opportunity that blockchain provides for automation and security in connecting devices to the backpack? Is Tim there?
He's unmuted, but there's no audio coming through.
Tim, we can't hear you.
Can you hear me now?
Yes, great.
Okay. Sorry, I have my gaming headset on. No, big thank you also, as the other panelists said, for including IMCON on this awesome panel. So the backpack, the big key to it is to be able to provide the opportunity for connectivity anywhere in the world. And in doing so and working closely in projects and things with George and Travis at Helium, and the Things Gateway, we're able to provide that additional layer of security so that we can do these innovative projects like in Kenya or France or some of the other places we're working. So we certainly look at blockchain as something that's, adds that layer of security and ensures that the people that we're working with are able to, kind of get a leg up and be safe at the same time.
Yeah, thank you so much, Tim. I after listening to what VMware and Hank is conveying to us, I would be really interested to see with the Internet Backpack if there could be any of their Byzantine fault tolerance solutions that VMware could be implemented into the backpack, just based on, we know that these backpacks are for a consortium environment, that we know who the users of the backpacks are. All right, well, we're moving on to the next question, our fourth question for Dean. Dean, in the conversation we had before the panel, you mentioned that any IoT device connected to a secure network should have device cybersecurity capabilities. This ideal runs up against the reality of legacy devices that are in use today, many of which are not secure. Can you explain the risk legacy hardware poses to critical networks such as those relied on by first responders? What are the risks in other less critical networks?
Thank you, Catherine. Well, first, Professor McKnight, thank you very much for holding the workshop. It's been great for me over the last 2 days. And also, thanks for inviting me to be on this panel. So getting to answer this question about devices, both secure and unsecured devices being attached to mission critical networks. And then how does this become part of blockchaining IoT? Let me offer the following 6 points. The number of connected IoT devices is measured in billions today, used by consumers, enterprises, and government agencies. A very controlled subset of these devices are being deployed in mission critical networks. The other IoT device subsets used by consumers and enterprises do not usually connect through that same mission critical network. It is expected that the yearly growth of connected IoT devices will grow every year by several billions of devices. Most of these devices are connected to the public internet and not to private enterprise networks. Over time, this could change. So the second point is many of these devices have been connected without forethought or awareness to the security threat that are unsecured devices pose to any network. The third point is for mission critical networks that are used in life-saving operations, it is common practice to not allow those types of devices, types of unsecured devices, to attach or connect to these life-saving mission critical networks. It is possible to enable these types of IoT devices to connect after ensuring adequate security measures have been implemented by these IoT devices when connecting directly to mission critical networks or indirectly via the internet. Now, some of these adequate security measures include doing risk management, conducting risk analysis of the IoT device and data versus the threats that could occur by opening the network to connect this device. The second major thing is risk mitigation and threat response. Making sure authentication measures are activated in the device and supported by the network access points. Examples of this include activating device passwords and keeping those device passwords updated, enabling device software updating to be done on a regular basis, and then using network containment approaches that ensure that the internet connected device has limited addressability, network addressability, and can be monitored for any possibility of attempting to access unauthorized systems, applications, or data. So for public, the fourth point is for public safety mission critical networks, today heavily depend on secure and resilient push-to-talk voice, mobile, and portable devices. These LMR devices and networks connect to a very secure encrypted wireless network called Land Mobile Radio. These LMR devices and networks support primarily secure voice communications between first responders, central dispatch, and central incident command. Obviously, this points to a very distributed operation, which is going to become very obvious for why IoT and then also blockchain play a major role. Public safety IoT networks are starting to be deployed by public safety over city, state, national broadband networks. Example of some of the things that have been mentioned already, networks are the 4G LTE and 5G new radio type networks. The first deployment of PSIoT devices will be used to gather in-field, so this is first responder in-field, incident situational awareness data, on-body biometrics data, emergency medical services patient information, sending IoT commands to IoT actuators, example, machine activation, deactivation, and later automation of incident command decisions via usage of trusted and unbiased artificial intelligence. Many of these types of device operations and corresponding server processes will require trust between the corresponding agencies. Public safety agencies and other mission critical communications providers will require robust blockchains and smart contracts to address these trust issues across the IoT ecosystem of products, services, and governance policies. In order to the fifth point is in order to mitigate many of the IoT device cybersecurity threats, it is necessary for IoT device manufacturers to implement these necessary in-device capabilities following industry-published guidelines from organizations like the National Institute of Standards and Technology. The NIST Information Technology Lab has published several IoT device security documents which help attempt to define these capabilities and the best practices for implementing secure communications for IoT usage.
Thank you, Dean. I think we have to stop there, move on to the next question, but we're going to loop back to all of you. So our next question in the first round is for Travis. Tomorrow, the on-site, or let me start with Travis. Tomorrow, the on-site guests are touring Coinmint's high-density mining facility in Messina, New York. Their videos show a sea of containers stuffed with servers racing to earn rewards and fees. In contrast, mining Helium's cryptocurrency, HNT, only requires plugging in a 5-watt hotspot on your windowsill. Can you explain what Helium describes as burn and mint equilibrium? Do hotspots that are also minting cryptocurrencies close the loop on self-sustaining peer-to-peer networks? How will the move into 5G affect this model?
Okay. Hey, folks. My name is Travis, and thank you very much for having me on this panel today. As far as the question, okay, that's kind of a big one. As far as I guess if we attack this initially, as far as burn and mint, this is something where we have a supply of what we call HNT, which is used on the Helium network. And this HNT can be converted into what we call data credits. And these data credits are locked to USD, right? And so you will always, if I want to plan out my IoT budget, this is locked to the dollar. And so I can always know how much my expenditure is going to be, right? Regardless of the price of HNT, which can fluctuate on chain, right? Through speculation. I can automatically burn HNT to data credits. Data credits are used to transfer packets over the Helium network. And the price of one data credit is $0.00001 US. And what this allows me to do is, regardless of any speculation on HNT, which I receive by running the network, by providing network coverage, I'm always going to pay the same price in data credits for transferring a 12-byte package over the network. The other parts of the question.
Let me repeat them for you. So do hotspots?
I appreciate it.
Yeah, no problem. Do hotspots that are minting cryptocurrency close the loop on a self-sustaining peer-to-peer network?
They close the loop on a self-sustaining, okay. Helium does not want to be a central authority on this network at all. I mean, this is a decentralized peer-to-peer network that we've built out. And, like you said, earlier, in the past 18 months, we have over 127,000 hotspots, with many more on the way deployed worldwide. And we've built up the world's largest LoRaWAN decentralized peer-to-peer network, which has been fantastic. It has been busy, but fantastic. And what this allows you to do is, regardless of whether you come into the network as a network builder or someone from the crypto side of things, or if you come in from the IoT side of things, I can get a device, and in most urban areas in the US right now, I can just turn a device on and it works. I can onboard this onto this network and have an encrypted form of communication for these payloads, for these very, very small payloads, going end to end, and feed those into whatever type of integration, be it Amazon, be it IBM, be it Azure, that I want to feed this data into. And it's incredibly powerful what's happening here, to be able to, and this isn't, I mean, this is worldwide. We're moving out in so many countries right now that we're providing an encrypted form of communication, packetized communication, put it into the hands of the people with no centralized authority. Helium isn't controlling this.
Yeah.
And if you want to run your own console router on top of Helium, get out there and do it.
Travis, we have a question from Garth on HNT. He's pointing out that it's not a tear, but the rewards are way down since the recent halving, and this is apparently exacerbated by the hotspot build out. Is there any comments on the effect of 5G in terms of incentives in the face of and continued miner growth?
Okay, this is another three-part question, huh? Okay. What he's referring to as far as the halving, or the halvening, as I like to call it, is where every 2 years, the amount of HNT earned by performing network coverage, or by building out this network, is going to be cut in half. And we recently did that on the 1st of this month. And what this kind of ties into, also is the supply of HNT on the network, because this is a limited supply. And I can't really discuss, fiat at all. But if you look at what's happened to the H&T price, since the halving, when you have a limited supply, it tends, or look at other coins, it tends to increase. As far as 5G, what we're doing there is effectively using the same mechanism that we've used with LoRaWAN, which, I mean, there's been other LoRaWAN networks, such as the Things Network, whatnot, in the US. They didn't quite get a foothold in the US. And in the past 18 months, we've been able to cover pretty much every metropolitan area in the United States, plus, I mean, tons of rural areas, for, cattle operations, for farming operations, agriculture. I mean, it's been really phenomenal, but we're now applying that mechanism onto 5G, which we're very excited about.
Awesome.
Let's Catherine, let's switch to the roundtable and give Travis a break here. Thank you for that answer, Travis.
Thanks, folks.
So for the roundtable, I'm just going to start with a question, and you should feel free to query each other and to jump in whenever you have something to add. So last week, a hacker stole and then returned $600 million in cryptocurrency from the Poly network. The hacker exploited a flaw in the code Poly used for connecting different blockchains. So what are the risks in connecting a secure blockchain to an insecure cloud? And how do these high-profile breaches undermine public confidence in cryptocurrency? Let's start with, let's start with Dean on this one.
So this is really outside my area of expertise. I would rather rely on the other panelists.
Maybe we could see, Hank, as you work with VMware, which is obviously integrating cloud and blockchain, you may be more likely to have some insight on, maybe what mechanisms need to be implemented, because obviously if we're not blockchaining the cloud, then, there's a huge flaw in the plan and kind of everything could just be there for potential failure. So Hank, do you have any thoughts?
Yeah, I mean, I guess it really comes down to how your blockchain works, both in a private and public cloud. The VMware blockchain is unique, but we actually run on vSphere. So vSphere is the virtualization platform that sits on top of the hypervisor, also known as ESX. And when you look at that model, we have the capability of virtualizing the full infrastructure stack, from the storage known as vSAN, the network known as NSX, and then the compute, which essentially is vSphere. So when you take those three components, we now are able to then modernize those into both a private and a public cloud. So being able to take it, whether on-prem or move it into any of the public cloud partners, we now have the ability of running our blockchain, whether it's on private or whether it's in the public cloud. I think that's important, which, ensuring the validity of your blockchain network, and being able to connect it. Because at the end of the day, when your blockchain is able to be supported, regardless of where it's running, you're able to work with those types of vulnerabilities. So connecting an unsecure node, for example, it would basically, through the replicated system, which essentially is our blockchain, would be able to detect that and be able to control it and block it. I mean, it's a lot more complex than that. But I think on the simplicity side, being able to run your blockchain, regardless of which cloud it's running in, is your first step.
Yeah, so essentially you guys have kind of cultivated this, layered solution that can be scalable, which is definitely, to other clouds, which, I guess we can go potentially for this question. If there's, I saw some prompts, Vince, if you just if you see those, if any of the audience is asking questions. But Travis, is this something that did you hear about this news? Did you at all consider how this could be a potential threat to the Helium network?
I don't see it as being a potential threat. No, I believe that side chains are something that absolutely can coexist. Alongside the HNT blockchain. That's something that we're seeing a lot of work done in the Helium community right now, on being able to run Lightning alongside HNT. I think that's fascinating work right now, and I'm interested. I'm working with it. I'd love to speak with other people who are doing the same. So
Awesome, thank you.
I had a question for Dean. As we're talking about trust, and that came up in your earlier answer, Dean, can you talk about what is the current status of implementing security based off standards in the current device production? And then, what's the difference between insecurity in code, like in the case of Poly network, and insecurity in a device? What's actually the greater risk to the network?
Well, I think both of those situations are at risk for the network, coming from different sides of attaching to the network. The current status of some of the standards that you mentioned is that several of the standards that have been produced by NIST were developed with device manufacturers. What their internal plans are for actually incorporating those standards is still under discussion. These standards have only been approved since January, so we still got a ways to go here. But as I said, for mission critical networks, we cannot allow device attachment for devices that do not have these built-in security capabilities, the ones that I mentioned previously. And as far as the application side of things, and you mentioned Poly, which I don't have awareness of, so I can't really talk about that particular instance, right? But applications taking advantage of various security mechanisms are usually done through IoT platforms, right? So that's the extra element in the mix here, is these IoT platforms are going to have to implement some digital ledger technology in order to provide a secure environment.
Thank you, Dean.
If it's okay if I jump in here and kind of comment on what Mr. Skidmore was talking about here. That is critical. That is critical. And I believe that another problem is we see a lot of manufacturers that go out of business, that we have, so the firmware isn't going to be updated on, huge rollouts of these IoT devices that then are just, susceptible to, be pulled into botnets. I think that's a critical issue that we have to deal with, as an industry.
Definitely. So I wanted to pose a question quickly to George and Tim, as you guys are connected by way of the MCON Internet Backpack. So I know for a fact that MCON in the backpack has not yet implemented a blockchain security solution, because I'm currently working on a grant where that's what I'm supposed to do. So I was wondering, from your perspective, Tim and George, could you potentially see, as VMware's technology is already utilized in the backpack, could you see adopting this blockchain solution? In what way are your current efforts of securing data transfer, and or is your team working on any future pursuits other than me? But I don't know if I'm part of the team, so.
Yeah. So I think, certainly we do have some VMware pieces, for user management and other items that we're currently utilizing. But, as we go forward and it gets in more hands, we want to ensure that we, protect it as best as possible. So I can, see certainly the work that you're doing, Catherine, coming into play here in the next little bit. And then as we continue to develop it and roll it out, it's going to play an ever more present role of, what's the data that people are collecting, and, in what way do they need to protect it, and how can we ensure that happens?
Thank you. Thank you. do we have any further questions, Vince, from the chat?
No, I did have a question for Travis, because this came up in our before the panel discussions. So we're talking a lot about, device security, but Travis, can you tie in how all of this security actually increases notions of privacy, especially on peer-to-peer networking?
Notions of privacy. I believe that we have notions of secrecy, right? And I believe that a lot of times in politics, we kind of get caught up in discussions about can this technology be used for bad purposes? Yes, but the fact that you need to have a secure layer of communication. This is something that you can give to the people. The people are running this network, right? This is a distributed network that we've built up here that allows you to send secrets around, and that can be incredibly powerful. In a lot of the countries that we're rolling out to, in South Africa, and it's important to understand, in South America, it's important to understand that the ability to tell secrets is something that a lot of people take for granted.
Thank you. So you're working, George, you're working in remote locations. And it's very practical applications, as far as the work you're doing with the farming and the emergency response and the monitoring of, ecological situations such as around volcanoes. How does privacy come into play for you in your working with the different governments and ministries? There must be a bit of a complex dance to both be implementing secure networks, but then having to fulfill government expectations on what's available to actually be seen.
Well, we're still, pretty early stage in a lot of these scaling projects. And the privacy issue, it's more, let's see what we can do with these applications to improve the farm economy and get data to the farmer that's going to be helpful, and then have the ministry get that data safely and have those end nodes, the edge devices be secure. We haven't really, no government so far, let's put it that way, has broached the subject of privacy and that what this may inhibit or allow within their boundaries of their state. So right now we're working at the county government level in Kenya, which is like a state in the United States. And we're working at the national level in Liberia and the national level in the Congo, and kind of fast approaching the national level in Nigeria and Malawi. But no one has broached that subject yet, although some of those governments may be, I won't mention which ones, but may have an issue with some of this. But it really hasn't been, and I suppose we really have to give it some careful thought. And, that may be a stumbling block at some point. But right now, we're just rolling forward with the plans. And until I'm told otherwise, we're just going to continue on the same path.
So speaking of the plans, we really haven't gone over the IoT kit that you've developed as part of one. You're looking for new innovation from the people you're actually working with, where they can develop their own special purpose device. Can you go into that a little bit? And like you were doing, show us?
I don't know if you can see it with my camera, but Travis was one of the co-designers of this, and RAC Wireless, the company from Shenzhen, who makes this gear. One of our two partners, Seed Studios, is the other one, both from Shenzhen. And this kit is industrial grade material to put your own sensor kit together. It's mainly an environmental and weather station, but it also has GPS tracking. We're tracking the dog and the ecosystem in southern France, which is going to be livestock eventually, but right now we're tracking the dog with this. And the kids get to build this and learn how to program. And what this will allow, these will be able to connect to the Helium network through the RAC gateways, and then up, of course, into the cloud and be shared. information with the ministry. So we could have these schools develop these kits, learn the skill sets, the farmers could too, and deploy these and really saturate the schoolyards in Bungoma Farm Region and give them microclimate information. I was told by the university they were working with their ICT department, George, we don't have access to real data. This is unheard of. This is hugely, this is a breakthrough. So I think the utility of this and the potential outweighs the security issues. Well, not the security issues, but shall we say the privacy issues maybe for the moment. But these kits are very inexpensive. You can create 2 sensors out of them. And, you know, we're just going to have to track these like we're going to have to track every other device and, you know, make sure, you know, it's secure. And, you know, that's VMware and Helium are going to, through the backpack, are going to come together. Because I've been trying to have them meet one another and talk with the IMCOM company, Helium, but we've obviously been so busy running in place to get where we are. But this has sparked that idea, you know, reaffirmed my thinking and Tim's thinking of what we need to do with the layering of our blockchains of our systems.
Travis, have you seen, what's the most interesting thing you've seen coming out of this effort? Are people innovating in unexpected ways?
I think what's pretty fantastic right now, and you know, after speaking with IBM, they have a marketplace for data, which you know, using deployments like this, where you can have you know, STEM-based education courses, you know, which you know, we're working with Open and George on around the Moodle, you know, open curriculum system, where you can have you know, kids learning how to write firmware that can then be monitoring volcanoes, and that data can then be you know, correlated and put up into an IBM or you know, some marketplace where scientists from you know, from around the world can then take advantage of that data. That's fantastic. I mean, that's cool as hell. Yeah.
So we have a question from the audience. Rand Cato, I'd like to know just if everybody could go into the challenges you haven't discussed yet. Is it cost associated or more data associated or security? So what hasn't come up in this panel that you want the audience to know about the challenges of a secure cloud architecture?
You know, if I may build off of that in a way, I have a question that's kind of directly related to it. You know, an example challenge, I know that, you know, Travis, you said that Helium is, you know, across the globe, and Tim and George, the backpack obviously has applications that are, you know, global, especially in places that are really rural. Currently on the grant that, you know, we're working on here with MCON and SU is, you know, rolling these backpacks out to Central America. So my question is, how do you communicate to these governments who are very, very protective of their information, especially from outsiders, right, of protective of this data? How do you communicate with them effectively and educate them about, you know, what you guys are trying to do in a way that is successful so they feel safe, you know, fostering you know, fostering that trust between you guys, so that you're able to, you know, implement on your side? I just know from personal experience with working with Central America, you know, they are very, very clear that, you know, they don't want any US entities looking at the data of their citizens, accessing it in any way. And so I just wanted to ask how you guys are able to go and, you know, implement and communicate, you know, what you're trying to do, them, especially to people who maybe have not heard of these solutions before, right? This is all very new to them.
That's a, if I could jump in real quick. No, that's a fantastic question. And actually, there's a gentleman, Paul, who is running his own implementation of Helium, like a private Helium network on top of the Helium network, because in the EU, there's export issues for data. And that's exactly addressing what I believe you're asking here. And so if you want to run your own Helium network, you can run your console, you can run your router, you can run end-to-end completely encrypted data on top of the Helium network and still make use of, you know, all of these, 127,000, you know, gateways that have been deployed around the world right now. I think that's crucial.
Yeah,
Well,
that's
there's sorry, Catherine, there's another side of that too, though, is, some of these places that we're talking to, you're right. This is totally foreign to them, right? We here, in the US, have this is kind of some of this to us who are around it all the time. It's second nature, right? I've been playing with Arduinos for a dozen years now. Data is what I live. But, and somebody that is a farmer in rural Kenya who might have electricity 4 or 5 hours a day, right? It's a multi-level conversation. Like when you're talking to the government entities, you have to take into account all their security and the different country rules, different regions that have different requirements. But then when you get down to the individual users, you can't just set a backpack or a rack device in the middle of some rural community and expect them to know how to use it. It's foreign to them. They don't jump on eBay or Facebook like we do, without even thinking a lot of times. So it's an educational piece, I think, is really a big thing that George and I have talked quite a bit about over the years.
Yeah, we really, everybody's at the same level. We want to elevate, level the playing field, as I keep calling it. So that they have all the opportunities, all the technologies that can benefit them, that are benefiting us, and maybe just a cleaner slate, as I was saying earlier. The only one I really run across this, Catherine and Rand, is when we were talking about the data from the volcano in the Congo. With that data, they don't mind sharing the data, how the volcano fluctuates. Some of it's observational, that you can say that the volcano blew up today, but the dangerous gases that emanate from different holes in the ground in the city are what we'd be tracking. And if there was gone from green to yellow to red flag of the dangerous gas levels, the volcano observatory there wants to know first and not share it with the populace for obvious reasons, for panic. And if they have the heads up and it's proactive, and they have the backpacks and they have their people trained in emergency disaster relief with them, then they can have more orderly evacuations and have real-time data feeds from those sensors with an AR or an MR system within the backpacks, and digital mapping. The evacuation can go more safely, but they don't want that data shared right away. So that's kind of a unique situation. The farming data, I think that's going to be more open. Pollution data, people might not want to know. The EPAs of the world, we're going to share the weather and share the pollution indexes. But then you get really granular with this data, and where does the line stop, and what does the government care about? Well, it's in their interest, some of this, to share with the scientists of the world. They've been going off models outside of Kenya, but now they're going to get their own models, and I don't think they're just going to covet them. I think they'll want to share them like they're getting model data from elsewhere. So it's a negotiation we have yet to really broach in many cases, but I'm sure we're going to have to.
Thank you. Sorry, I was just writing down a note.
Could I bring up another, Catherine? Could I bring up another area which is related?
Yes, please.
Question that we're discussing. In my work that I do with towns, cities, states, and to some degree federal agencies, a lot of the times there has to be corresponding governance changes in order to incorporate new types of technology like IoT. And it really comes back to the points that George was just making is relative to the data that these devices generate. Even here within the US, public safety agencies do not like to share information across even their own agencies. And so the sharing of data is at the fundamental level of everything we want to do with blockchain and with AI and so forth. And until we start addressing some of the governance issues that are associated with embracing the stuff that's coming out of universities like Syracuse, I feel like we're going to have a slow go here, right? And that, yes, maybe there are some departments that would pick it up, some of the IT departments that would pick up all the innovation, but unless we get at the policy level and also what type of procedures need to be put in place that enable the trusted sharing of information, I think we're headed for some slow go here relative to that blockchain technology.
Yes.
Yeah. Go ahead.
No, you go ahead.
Yeah, Dean, and one of the things I've tried to be proactive about in these new territories that are, like as it was said with Tim, with the Arduinos and the farmers not really even having computers. They do have Android cell phones, and so they get pretty sophisticated pretty fast, and we're going to have to train them all at a base level, including the ministers themselves. But I'm bringing everybody to the table. I've got the university partners, I've got the vendors, I've got the government, I've got the NGOs in the region and the schools and the teachers, pretty much the community right from the start. And again, I guess we're in a unique situation with what I'm doing. I know we're going to run into the hurdles that have been, that Dean is mentioning. People are covet their own little territorials. And actually, I ran into this with the government in the county of Kenya. The ministry told me, the Ministry of Agriculture, it's a farm region. George, don't have us all come together at first. Have us take the lead because it's farm region, it's farm education and agriculture. But if you get everybody around the table, including Ministry of Education, telecom, water, energy, whoever else we're going to bring into this, it's going to be chaos. Everybody will be like fighting for you to be the lead. If you let us go first, and we did, and that unfolded very well. Now we're bringing in all the others and getting them at the table at the right point in time, we hope, to really take this, out to the streets and make this, this scale to 100 farms and 100 schools and get the ministries up to speed. So, I think, we're fortunate in that regard. And I think that with, in the US, it's a whole different story, and in other developed countries. But we'll see how it's played out. We're just going to have to, take it down the line and report back in the next workshop next year how it goes.
Yeah, it seems that, following the lead of those countries that you're trying to implement your technology in is definitely the way to go, and having, them kind of take you in to bridge that gap. And then, integrating other parties. So I just wanted to ask about, in scaling of, the backpack and Dean, the IoT tech that you're working on, and Travis with Helium, what are some unforeseen challenges that you guys have come upon that you couldn't even have imagined before going into it? And how did you effectively navigate those challenges?
I'll jump in here. And this is kind of piggybacking on what Mr. Skidmore was talking about. As far as, different agencies working together. I've done some work, some government work on the federal level. And I think one area where you can really get a lot of cooperation is hazmat, is in emergency response, is in, where you have agencies that have completely different systems, but they have to be working together. They have to have this data correlated. They have to, all have, coherent data coming from, all of these different companies' sensors. And I've seen the most cooperation in that industry, just in my career. I think that it's incredibly hard to get that to work in the commercial sectors. But one thing that the blockchain can help out with, if you look at, for example, oil and gas, you have a lot of companies that may not like each other at all, but they do have a common interest in mind, with what they're working on, and they need some type of, a common source of truth that can be, all related to by all the companies, right? And so you could consider that source of truth. The blockchain allows us to do that. And so we can have sensors, and it doesn't have to be oil and gas. This could be any industry where I don't trust the other parties. I don't have to trust the other parties, right? I have a mechanism now in place where I can work with with trustless relationships and basically bank on that. I think that's incredibly powerful.
We have a final audience question, but we're running up against time constraints. So this might be better to answer using the Q&A portion of Zoom here. And I'm sorry about running up against the time constraints, because this has been great. So as expected, our panelists gave us a lively discussion. I wish there was more we could have gotten to. Travis was demonstrating 3D printed communication devices the other day that I think could be a roundtable unto themselves. But we have valuable insight on how to create a truly end-to-end secure cloud architecture from this discussion and the Internet of Things. And I want to thank my co-moderator, Catherine, and our panelists, George, Hank, Tim, Dean, and Travis, for your contributions. I hope we can do this again next year. Thank you, everyone.
Our next keynote speaker, we've been talking about the future and future of smart cities, future of communities around the world. And now Professor Ricart doesn't think we've been thinking about the future far enough. So he's going to take us to 2041, 20 years in the future. Professor Ricart.
Well, thank you very much. I appreciate that, Lee. Yes, you've already heard some about what US Ignite, my nonprofit, is doing. Also my fifth startup has been doing. That is, of course, very important. But in a seminar like this, it's very important to leave something to the graduate students. And so instead of just saying, hey, look, we've done all the stuff, the world is wrapped up, we've done all the good stuff, I thought I'd lay out a series of issues and problems I thought are going to be coming in the next couple decades, and for which we need good answers and good responses. And so to Rand and everybody else out there who's looking for an absolutely fantastic topic, I'm going to mention lots of opportunities in this talk today, and maybe you'll grab onto one of those. It's also really good to talk about the future because it engenders lots of discussion. I've undoubtedly made some mistakes, and I'm hoping that you'll point them out to me in the discussion period which follows the presentation. So with that, let me go and get this started here. So I thought I would first of all start off with a cover.
Just jump in again for real quick. So I didn't do an adequate introduction. Glenn Ricart is not just the founder of US Ignite. He's a true legend in the history of the internet, and that meaning he is in the Internet History Museum, a member of the Hall of Fame, done tremendous work, technical work, program management work for the federal governments, and research work at the University of Utah and elsewhere. So it's a real privilege and honor to have you here with us, Glenn, and to continue to work with you and the US Ignite community. Thank you.
Well, thank you, Professor McKnight. So this is a picture of the dark skies of Utah. I live in Salt Lake City, and there are 23 dark sky locations in Utah that you can come and see the Milky Way looking like this. This is a time exposure that also has some of the red buttes showing up in the background, lit by starlight and taken in a long time photo here. It also goes and shows that some of this work I'm talking about was sponsored by the National Science Foundation, and I'd like to acknowledge them. My nonprofit, US Ignite, has been the home for a lot of this work and speculation. And I'm also a member of the faculty as an adjunct professor in the School of Computing at the University of Utah. So it's from those positions that I'm going to be talking to you. And I'm so privileged to be talking here at the Syracuse University School of Information Studies and the important folks and work that's going on there. So with that, let me just make sure that everyone has an idea of what US Ignite is. We're a high-tech nonprofit. We're accelerating the smart and connected cities movement by creating value for an entire ecosystem by guiding communities into their connected futures, creating a path for private sector growth, VMware here and everybody else, and advancing technology research. And that technology research is a really important part of this, because without the technology research, we're not going to be able to sustain and grow the kinds of smart and connected cities movement that we'd like to see. Here are some of the projects that US Ignite is working on. I'm sure Praveen probably mentioned some of them. On the top left is the US Ignite Smart and Connected Communities. These are the communities across the country we're working with. And you'll see Syracuse there because of some of the work that we're doing there with the University of Syracuse. On the top right, we have $100 million platforms for advanced wireless research. 50 million of that comes from the National Science Foundation. 50 million comes from the industry participants, and we really appreciate them. Bottom left, you can see Project Overcome. This is one of our newer projects. We have 7 communities from across the country that are being funded by the National Science Foundation and by Schmidt Futures to connect the unconnected in these communities. And we've chosen them to be a wide variety of different kinds of situations for connecting the unconnected, so that we can use them as exemplars when we have more substantial funding from things like the infrastructure bill currently before the House of Representatives. Community data dashboards, of course, is the primary thing that Praveen's working on. The bottom right, we're also working on smart and connected bases, because we're able to do advanced work there that we may not be able to get permission from the city council to do in some of our other communities. But turns out if the base commander says it's okay, we get to go ahead and do it. So let me talk about 2041. That's of course 2 decades from now. And I chose that date because it's sufficiently far in advance that things should have changed dramatically, and yet not so far out that so many things have happened that we wouldn't even recognize what's going on. So let's think about 2041 and just what other folks have shown us. You have been signed out because you're currently on another device, all right? Hopefully this is not affecting the conference here. I don't want to leave the webinar. Okay. We see that populations have shifted dramatically. India and China are much larger than the United States. And you can see that really the balance of the economic growth and issues in where smart cities are going to be is really going to be changing. The population will be about 50% bigger than today. Most people are guessing, and so that's going to be very important. Here are some of the specific recommendations or projections that people are seeing. So for example, Sumitomo Forestry Company will build the world's tallest wooden high-rise, 70 stories, 350 meters, comprised 90% of wood. That'll be in Tokyo. And by the way, they've already taken out the building permit on that. We think the people will be able to upload or change their memories and personalities. We'll be able to upload enough of memories that we can go and do things like that. Annual deaths from cardiovascular disease will reach negligible levels in the United States, where we have that kind of healthcare. Electric vehicles will be nearly 100% of sales. And orbital solar power becomes commercially feasible. So we may be able to use solar power from orbit to both shield parts of the Earth from the warming effects of the sun, at the same time producing power in a clean fashion from the sun. So all of those are interesting things that may have happened by 2041, other people have predicted. I wanted to talk to you about smart city infrastructure and how that's likely to change in the next 20 years. And I'm going to talk about these 7 areas: mobility management, water management, public health management, smart energy, public safety services, multi-purpose augmented reality services, and smart citizen safety services. And I'll talk about each of them individually. So let's talk about smart mobility management. This is a good example of where we see the ability to have things like an intersection in which there's no traffic light that's stopping folks. We see in this intersection that the cars are adjusting their speed in order to pass by one another without having to have complete stops. And that will save a lot in terms of fuel usage. It'll save a lot in travel time. It'll increase the ability to use existing pavement, which is really important because with 50% more people, we can go up higher in high rises or residences, but we don't have a lot more street space. So we'll have to use the streets much more effectively like you see here. In terms of interstate highways, on the right-hand side, you can see platooning vehicles. They are running at highway speeds, 70, 80 miles an hour, and follow one another very closely. Here's an example of what we perceive to be a personal mobility device that we would see. Here's an example interior of no steering wheel. You can have meetings, conferences, be able to do Zoom conferences like this from inside those vehicles. And they give them reliable communications. And I'll speak about this again later, but just to give you a preview, I expect that we'll actually be sending things from the car to the pavement so that we don't have to worry about obstacles that might intervene in what's going on there. So what are we going to need? So our challenges are going to be, take a look here at the top, latency requirements are going to demand ubiquitous edge facilities. We just have to have total latency under 10 milliseconds to do this vehicles passing through the intersection and to do the platooning. And with a total latency of less than 10 milliseconds, we have to have very short periods of time. We can't go and add things to blockchains because just the consensus time is way more than 10 milliseconds. So we've got to be able to figure out how to do much more of this at the edge with ubiquitous edge facilities. It also demands ultra reliable communication. What if any one of these vehicles on the left was not communicating and wasn't playing the game? It would be almost impossible to be able to have them pass through the intersection unless they were in communication, which means we need ultra reliable communication. And the latency plus the safety requirements are going to demand cryptography because, of course, we want signed attestations of where each vehicle is and how fast it's going. And so we're going to need low cost and high performance cryptography in order to make that happen. And of course, even if we're successful at these first three things, the ubiquitous edge, the ultra reliable communication, the low cost, high performance cryptography, they'll still have to have the public be able to trust it. I've just noticed that within the vaccination debacle that we've got currently going on, that even when we have a technology that works, like the COVID-19 vaccine, there's a lot of public trust issues. And so I am predicting that same kind of public trust issue may occur for some of these mobility concerns. Second is smart water management. And that includes both the storm and sanitary collection of the water that's used and both the culinary and agricultural water distribution. And why is this becoming important? Well, droughts and floods are being exacerbated by global warming. We have an aging infrastructure for many of our cities with these pipes. Some of them are still lead. That may be addressed partially by the Infrastructure Act, but we're not replacing the infrastructure on a schedule that's going to allow for 50% more use. And we don't have 50% more water. Population is increasing, but the water, especially in the West, isn't. Whereas in the East, we may have more water than we can deal with, and we'll have to raise the level of homes near oceans. 30 to 40% of today's culinary water does not reach the meter due to leaks and other issues like that. And we have an increasing prevalence of wildfires requiring water to extinguish. So the use for water is going up, the amount of water is not going up, and we're going to have to take much better care and be able to account for and have a more modern water management system. And I see, I skipped a slide here. So what are going to be the challenges here? Low cost, reliable sensors. A lot of these sensors are underground. How do we get reliable radio frequency communication to underground sensors? We're going to need cryptography to avoid spoofing and provide information integrity. We're going to need public accountability for water use. And of course, the public will have to trust this new system. Number three, oh, come on, I'm skipping slides here, is smart public health management. And I think that's going to be a combination of continuous health monitoring, detailed air quality monitoring, including microclimates for pollution. That's especially been playing out. You can see in the second graphic there, yesterday in Salt Lake City, the air was red because of wildfires in California blowing smoke into Utah. And of course, the respiratory diseases and asthma that gets exacerbated by that. There are a variety of self-tests that are available. On the left is an oral ring You don't have to wear a special watch. You can just wear a ring that collects your biometric data. And of course, I think on the far right, you can see an example of how devices, even like Amazon and Google devices, are going to be using local radar to be able to check your breathing rate and to listen for sounds of snoring to help understand how well you're sleeping. And I think we'll also see some individualized prescriptions for specific physical and mental exercises, the environment in which you should live, and online psychological health boosters, because right now most of the stuff online is not boosting your psychological health. In fact, it's working the opposite. So here's a challenge. How can we get online psychological health boosters? Just one of several different possible topics that people may want to think about. So what are the challenges here? We're going to need low-cost, bioaccurate, continuously reporting sensors. We're going to have provably personal edge processing for privacy. I don't want my stuff all going into some cloud. Right now, the United States government says we can access anything that's in the cloud, but maybe not what's still on your own phone. So I'm relying on that to say we're going to have to do a lot of personal edge processing, your own phone, your own Amazon or Google device, latency based on the immediacy of care needed. And of course, this is going to require a lot of public trust to be able to pull off. So number 4 out of 7 is smart energy. And energy is going to be very complex because we have only a fixed amount of it at any given time. We're trying to grow more with more solar energy, more hydropower, and so forth. We think the orbital solar power by 2040 will really be very helpful, as will ambient energy harvesting. Now that can occur both by the fact that we're going to put up a lot more RF, which means that you can capture more of that electromagnetic spectrum to generate low amounts of power, and also body energy. It turns out that your heartbeat is 1.4 watts. An arm in motion can be spending up to 60 watts. So there's many ways we can get through that. The difference of body temperature to environmental temperature can generate energy. Respiration, evaporation heat, glucose, lactic acids. We can use chemical energy, which is what the body uses, of course, in the ATP cycle. And mechanical energy from your body movement, footsteps. Footfalls alone can generate 67 watts, according to this article that just appeared in March of this year. So those are some of the things in smart energy, the challenges there. We'll have to motivate life cycle changes if we want to live with less energy per person, with more people, and not have to generate more energy with oil and coal. We're going to probably have, I think, separate digital economies and digital currencies for energy. I'm not sure energy is going to be denominated in dollars or even virtual dollars or Bitcoins or Ethereum or Dogecoins or whatever. I think there will probably be a separate digital economy and a digital currency for energy, because energy can neither be created or, can be created and destroyed, but it has to live in the moment. Some of this is going to be privatized. How do we deal with that privatization? And how do we get public trust of some of those private things that are going on? So that's going to be, I think, very important. Number 5 out of 7, I think we're going to have very smart public safety services. Self-safety is going to be important. Crowd safety ways it's already being used for people to help identify to others where there are accidents and debris on the road. So that's a crowd safety service. And we're going to have to think about public safety services. Prediction is going to help predominate. We're going to need a sort of risk management economy, that is insurance. So for risk management, again, that may or may not be done in dollars. It might be done in a risk-based digital currency. A risk-based digital currency can better absorb changes that can occur that are unforeseen in the future. And so for things like insurance, a risk-based digital insurance currency may turn out to be really important. That is separate digital currencies for different levels of risk loaded against fiat currencies. based on the actual results that we've got. And in that way, we may be able to use digital coin infrastructures to help with the risk management that's necessary to be able to have insurance in this new world. And what are some of the challenges there? Well, we need to create these digital risk-based currencies if they're going to be the insurance of the future. We're going to need to create digital twins, which can be used to predict risk. And some of those will be privatized. And how do we get public trust in the insurance? As you know, your insurance today is only as good as your insurance company, and yet the public trusts them to be able to pay out if that insurance is needed. So really very important and interesting. Number 6 out of 7, I think that we will end up with a smart, citywide, multi-purpose AR services infrastructure. And that's because there will be so many applications for augmented reality that the base service is a natural monopoly. Now, specific services on top of that could be privatized, but the base service is going to require lots of small cell communication, lots of use of RF for localization indoors, and having 4 different sensors to tell me where I am in the room, one from Verizon, one from AT&T, one from T-Mobile, and one from Google and one from Amazon is not going to work out. We're going to have a base service that is a natural monopoly, whereas those other services can compete to say, we're going to be more useful to you. Smart visitor services are going to help attract visitors to communities, help tell them about historic locations, give them practical information, how to get around. Smart navigation overlays, especially can be used by people who have various handicaps, such as people who may be blind or people who may need to be in wheelchairs. You know, what areas and maps and routes are wheelchair friendly. And to be able to help predict the risks, can we use the models? Can we use the digital twins to predict the risks, the safety concerns, the cognition clues, and even help with artificial memory? I'm beginning to forget a few people's names. Can you help me remember Rand Cato when I meet him again on the street? Okay, so all of these things are going to, I think, be rather important. You see here a Pokemon. Here's one that says turn right, the end of the corridor. This is emergency exit. In the case of a fire, your phone can tell you which way to go. And the advantage to this is that it can send different people different ways so that the nearest exit isn't completely crowded. You can get to the exit that will get you out fastest. And of course, here is somebody who's trying to analyze what's going on in some kind of industrial machinery, and it's showing them an overlay of what's going on, what's working, what's not working, that they can't see in real life with their real eyes. So what are the challenges here? It's a lot more additional information channeled to the brain than we've had before. So we're going to need main ways of visualizing the probability of various futures, including economic decisions and things that have insurance impacts. We're going to need not just machine learning, but we're going to need what I call real artificial intelligence. What does someone need or want to know right now? Too often, AI today means, can you categorize a picture? But real AI is, what does someone need or want to know right now, and can you help them with that? The latency here are in the milliseconds to a few seconds, depending on the application. And will people trust this kind of AI in 2041? How do we generate that public trust? And by the way, here's my favorite work environment in 2041. I'd like to look out over the French Alps. I'd like to have, looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 screens so that I can not have to keep calling up windows and putting them behind, but I can just deal with them. As you can see, the person has on a headset and is seeing all of this, of course, in their headset. But I think it'll just be a pair of glasses that don't look much different from my normal pair of corrective lenses. And we're going to need the ability to wiggle fingers and move hands and arms and heads and nod and shrug shoulders and have other kinds of gestures that are recognized by these systems in 2041. Okay, number 7, smart citizen safety services, digitalized to watch for, attempt to avoid, and respond to problems. So what if everybody had a sensor that would be able to tell if I were having a heart attack and be able to help me avoid it and respond to it when I have it, and do it in a way which doesn't intrude on my privacy. Now, if I'm having a heart attack and I might die, I don't care. You can tell the EMS, they can come in the front door. I don't care how embarrassing, watching cartoons is at that time, they can come in. So how can we use technology to both be our safety eyes and at the same time give us our privacy? How can these eyes watch for, attempt to avoid, and respond to problems while forgetting everything else and not recording it or keeping it? So we have some examples like that already. This is a pacemaker. Pacemaker is watching your heart rhythm. Your heart rhythm is okay, it just does nothing. It's a very silent observer of your heart and it doesn't do anything. However, if it sees that your heart has gone into atrial fibrillation or cardiac arrest, it will go and provide a shock which can go and reset the heart rhythm. You really want that if you need it. And at the same time, you don't want it interfering with your normal life. You want it to do absolutely nothing almost all the time. And I think that's going to be characteristic of these smart citizen safety services. Silent Observer is a program of many police departments that says, did you observe a crime? You don't have to tell us who you are. You don't have to get involved. Just give us some clues, whatever you know. We promise not to collect your personal information, find out who you are. But anything that you can help us with would be useful for policing. And can we take that same idea and put it in a camera, which is watching, but have trust that that camera is not recording everything. It's only looking out for my own good. It's a real lift. I'm not sure we would be ready for this yet, but I think by 2041, we may have developed enough ability to have public trust and accurate AI video understanding, low latency, high accuracy, and high reliability systems for this, coordinating multiple views so that we don't have false alarms very often. I think we'll be able to generate the public trust to have this new kind of, yes, we're being watched all the time, but we're being watched all the time by technology we trust to not give up our privacy. A lot of dissertations there. Okay, so those were the 7 pieces of infrastructure I wanted to talk about. And I now want to just go and talk about some of the technology and technology implications I think lie behind supporting these. So here's my technology 2041 predictions. Energy utilization is a key consideration everywhere, thanks to climate change. And in climate change, there is no such thing as green blockchain computations, because any energy we have, we need to put to productive use. And anything we're using that's green for blockchains is something that's not available for something else. So energy utilization will be a key consideration. Edge computing resources will be everywhere, public and private, and that's almost occurring naturally with very powerful cell phones, very powerful television sets, smart assistants, and so forth. The wireless spectrum will finally be full as a practical matter. Right now, believe it or not, the spectrum is being utilized about 2% to 5%, and the rest is empty. The reason the rest is empty is because there's such a belief that there will be so much more wireless in the future than now, that the big companies like Verizon and T-Mobile have bought lots of spectrum they're not now using, so that they will have that in the future to be able to use and charge you for. So I think that by 2041, in 2 decades, we will have pretty much moved that 2 to 5% to something in the 80% range. I think we're going to find that we have fiber to every structure and road. Roads tend to get repaved about every 20 years. We should put new fiber underneath it at that time. Whenever a new building or structure is built, we should put fiber to it. For existing structures, we should go and put fiber to it. Complex collection of public and private 5G networks. I think we will have an almost uncountable number of 5G networks running around, a lot of them being private. So cybersecurity is going to be a bigger issue than ever before because there's going to be more that's cyber. We won't have any magic bullets, I'm not predicting, to be able to get rid of all the problems that we've got with cybersecurity. So we will continue to have significant cybersecurity breaches, and I'd be very surprised if ransomware was gone. And I actually think that mini wars will be frequent and primarily fought via cyber disruption of infrastructure and economic structures. And you've already seen that a little bit with Russian-based ransomware attackers going after lots of little mini wars against infrastructure in the United States right now for money, but we can easily see that could go beyond money and be something else. Crypto, since this is a conference is about crypto, I think we will be finishing the transition to post-quantum cryptography in 2041. Quantum computing will have forced a revolution in cryptography. There will be no crypto standard before 2031, except for, of course, the one-time pad that can be trusted. However, storage is so cheap by 2041 that one-time pad is widely used to generate short-lived keying material. So I think a lot of inexpensive IoT devices will actually come with a few gigabytes of one-time keying material. Each piece of keying material can be used to send a certain amount of information, you know, multiplied by 1,000 or 10,000 bits per bit of keying material, and have relatively safe and secure IoT devices, at least in terms of cryptography. Distributed ledgers. Distributed ledgers, they will be absolutely critical technology for applications with stringent latency and reliability requirements. So I see a big future for distributed ledgers. If you have to keep things local because of low latency requirements, if edge computing is going to be really big, then you've got to distribute the ledgers to the edges, and the edges, being ubiquitous, are going to be billions of them. So how do we have distributed ledgers for billions of edges? Great topic for a dissertation. We're going to have local actions, which are based on the known past. Those are the reconciled ledgers, or we can call them blockchains. Current events, that is those which are not yet frozen into a ledger. You can think about not yet reconciled or not yet put into a sealed block that is a part of the settled blockchain. In addition to those current events that are in some trial blocks, but not yet, I'm calling it reconciled as opposed to any other term. We also are going to have predictions of what's likely to be happening elsewhere. And when we look at what's going to be happening elsewhere, we're going to have to consider multiple futures at once. But that's just like a chess move. When you make a chess move, you consider, if I make this move, what else could happen? What are the multiple futures that could come back to affect me based on this move? And so we're going to have to think about all of those things in making those local actions. They're not simple, and it'll be one of the reasons that, again, because of latency and the immediacy that's needed for cyber physical systems that work at the speed of human thought, that we are able to take these local actions based on distributed ledgers. Okay, blockchain conference. So here's the mandatory blockchain 2041 predictions. I believe that government digital fiat currencies will be in wide use. I don't think they'll be blockchain based necessarily. I think they could be distributed ledger based, because they'll be government run. So we don't need the publicness of the current blockchain, at least the Bitcoin style proof of work style blockchain. But I believe that there will be gazillion transactions on these distributed ledgers using this government directed digital fiat currencies. And of course, we see this already in China. Even today, they are looking at how do they get more of their digital currency under their own control in China. Proof of work blockchains just take up too much energy given the climate crisis. They'll be limited to specialized purposes. They'll be kind of like owning gold or something where there will still be some of these around, I believe, but they won't be the most. There will be some public digital currencies, like I'm predicting Ethereum 3.0. As you know, 2.0 is scheduled for, I think it's November this year. But they'll be priced on value, not on speculation. In 2021, all of these digital currencies are based on speculation. And that will not be something that will last. What's going to happen is that speculation eventually in any large market dies out, or it doesn't die out, but it's really controlled by the market. And so we'll see a lot more realistic pricing for digital currencies. I do believe that we need something like we're using blockchains for now, where we can say, yeah, this actually did happen. We can guarantee it and everyone knows it happened. And I'm predicting the way that will be done is with 4 to 5 public notaries, kind of like we have 4 to 5 big accounting firms today, all of which will be paid very small amounts of money per transaction to digitally sign important transaction clusters. They'll be the new Lloyds of London. The reason for 4 or 5 of these is so that any one of them could lose their private key and we would still have the signatures of the others. So I think that the 4 to 5 public notaries, which are doing a really good job, we will lose some over time, but I still think that we will have enough that we can make sure that we've got a notary that has not lost the important information necessary to alter anything. The public notary services on the last bullet point here provide much of the value of the blockchains at a fraction of the energy cost. And I'm calling this proof by multiple authority, which of course we already have proof by authority, but I'm projecting proof by multiple authority. Okay, so those were the predictions. All of those require public trust. Remember that term on many of my slides. Today in the currency market, public trust is provided by a paper fiat currency and credit cards and Venmo. Everyone trusts them. Who knows why? Why should you trust Venmo? You have no idea. It just seems to work, so I trust it. But I think soon it's going to be by government issued fiat digital currency. As you know, the US Treasury has already considered digital currencies for the United States. China is there already. We're seeing this being moved in Britain and the EU and other places. We think it'll look almost the same as credit cards and Venmo and such, and people will not notice the switch from fiat currency that's paper to fiat currency that's digital. And in fact, if you look at how a lot of the government transactions today work, it's almost that way. Okay, so I have a slide here that says, what will public trust look like in 2041? And you notice the slide is blank. I'm not sure. I think this is a big variable. I don't know what it's going to be. Another really good topic for some graduate work. But I do know in 2021, US Ignite, with some funding from the National Science Foundation, has created a document on fostering civic trust, a policy guide for municipal leaders. And this is a, I think it's a 93-page guide that I think is going to be very important to keep in mind. It talks about a number of different areas, equity, data governance, cybersecurity, privacy, community engagement, all of which help to build trust. And it doesn't give you all the answers within the book, but it's a compendium of why you should worry, and here's where you should look for additional information. So I encourage you to come to the US Ignite website, download that, to think about public trust in anything and everything that we do. Okay, so I'm going to talk about, I think it's another 7 technologies that I think will be there in 2041. This is the last series here. Ubiquitous connectivity and ubiquitous edge computing I want to talk about on just a few other subsidiary slides here. So ubiquitous connectivity, what speeds do we need? So I kind of wrote down in the 1970s, we had dial-up at 14.4 kilobits per second. You could get to the ARPANET. By the way, that was faster than I could read text. So I thought this was the fastest I would ever need to a computer. You can laugh. In 1980s, that went up to 28 kilobits per second, about double. In the 1990s, cable took it up to 10 megabits per second. DSL was still at 1.5 megabits per second. In 2010s, in 2012, actually, Google Fiber put in a gigabit per second in Kansas City. And now in Chattanooga, 10 gigabits per second is very reasonable in the 2020s. And in the 2030s, I think it's going to be fiber to terabit per second. That's now in research with projects like the Fabric project. So it's being used in higher education. And I think in the 2040s, it's reasonable to expect about 10 terabits per second. Japan has just done an experiment at 200 terabits per second over, I forget exactly how many cores of fiber. I think it was 4 cores of fiber. If we take a look at this progression, we see that speed doubles about every 2 years. So the speed doubles, it doubles. So about every 2 years, the speed doubles. And it's been that way for 10, 20, 30, 40, 50, 60 years. And I'm only projecting to the 2040s, 20 more years than the 60 that we already have data for. So I am predicting, Ricart's law here, that the speed will continue to double every 2 years. And people may compare that to Moore's law, which was every 18 months, but now seems to be about every 2 years as well. So I think that's what's going to happen there. This is a slide on Fabric. You can see the terabit per second network is the broad yellow line. And you can see where that's going and what's happening there and the partners that are putting that together. And US Ignite and Internet 2, there's the US Ignite logo at the very bottom right, are participating in these efforts. Fiber will need to go deep. And you already heard me say, I think it's going to go in every building and then every under road, because we're going to fill up the spectrum and we can't just put it all on RF and spectrum. We've got to go fiber deep. On wireless, we need to optimize it. We need to optimize it to minimize distance, be able to use very high frequencies, which means, again, limited distances and no interference. And I think we're going to need to have neutral host and open radio access networks to provide equitable service, least antenna clutter, and have basically a natural monopoly at the lowest level of radio access networks, while being able to have a combination of private and public value-added services on top of that. So again, the example is if we have radio frequencies to cars, we can't have trees getting in the way of cars communicating. We're going to need to have the antenna on the car, for example, in the bottom, also sending information to the pavement right below it, so that we have a very close connection, probably no more than 12 inches away, which is going to be very reliable over the distance here, several feet in the car, and allow for highly reliable communication, localization, and potentially even power. There is a road called Automated Roadways that people are talking about providing electric power to electric cars in real time using this kind of technology. We have a lot of uses for limited spectrum. We've got localization, we've got rough imaging, we've got detection of gestures. This is the Google Soli chip. So we're going to have a lot of very localized pieces of wireless infrastructure. So this is the living building at Georgia Tech. And I have just outfitted it with wireless all over the place. This is not how it's actually done. This is my vision of how it's done. I think we might have a RF reflective wall here or window so that we can use the same frequencies outside as inside. I think that in public spaces, every building that faces a public space will probably have RF available. There may be RF coming up from the pavement to help with people who are on bicycles or will otherwise be near paved things. So we should put it not under just roadways, but also under walkways. And then, of course, in all the different spaces that we may have anybody, even if it's not very frequently done, we may put it and a water tank just for the sensors that are there. So innovations, again, lots of possibilities here for dissertations. RF reflective or absorbing external walls, RF reflective or absorbing interior walls, very high precision localization, passive backscatter for security, and Bluetooth plus biometrics to help ensure secure entry. So the technologies I think are going to be ubiquitous connectivity, ubiquitous edge computing, digital economies interwoven with business. And those digital economies, I think, are going to employ digital currencies for risk management and insurance, personalized digital assistants interwoven with personal lives, this public neutral host and open access that I've talked about, digital twinning of economic and safety aspects of the real world, continuous real-time prediction of the salient future events and trends, and bear in mind that the real world and its digital twin are going to be running in parallel. But the digital twin can fork off multiple probabilistic future worlds. Those worlds don't become real until the future arrives. And for those of you who have studied some quantum mechanics, I've just described how a quantum computer looks. It is computing multiple futures at the same time, which don't become real until that future arrives. And I think that our networks and our technologies will end up looking a lot like quantum mechanics does today. And if that doesn't provide a number of interesting dissertations and master's theses, I don't know what will. So thank you very much. We welcome you to the dark skies, and I have about 5 minutes for questions.
Thanks, Glenn. That's incredible. Really loved having you join us because you were in the middle of so many different things. You were able to pull it together beautifully. Are there questions from the floor?
Hi, Lee. This is
Yes.
Lan
Yes, go ahead, Lan.
Yes, this is fascinating. Thank you so much. My question would be that adoption. I want to see Glenn's point of view on how you envision the adoption may roll out. My observation is that in terms of intellectual leading capabilities, the US definitely continues to lead. But if we compare the developments on the ground, and in the light of, say, some other newer comers like China, I personally feel that the execution in China, aided by, of course, different political system and culture, is rolling up so fast. So to me, it seems to be a key point about, intellectually we see it all, but how do we see it getting implemented on the ground in a massive scale?
Excellent question. Excellent question. So how does all of this actually come about on the ground? And it's going to be a planned economy versus a capitalist economy. And capitalism has always embraced the future more rapidly than planned economies. And because this represents such a big change, my own prediction is that the planned economies will continue to lag because there are going to be innovators, like VMware, like Microsoft, Google, and others, who will see a lot of these positive futures and be able to implement them more quickly in the United States and in other Western countries. Now, the big danger is that with all the benefits, technology is a two-edged sword. So we also will experience the negative effects sooner than the planned economies. So your question to me comes down to, well, we're going to have more advantages, but also more disadvantages sooner. And will it be that the more planned economies can do a better job of navigating the benefits without having so many of the downsides? I don't know. What do you think?
Let's move on to the next question because we're going to let Lan address some agenda setting questions on the next panel. Is there another question out there?
Yeah, someone named Johnny that you wanted to get.
Yeah, but let John go ahead.
Yeah, I don't know.
Do you see?
I don't see John.
No. Okay. Well, Glenn, you've been building out. I'll just close with a softball US Ignite question. Okay, so we have our. You've been successful somehow in keeping that organization alive through presidential transitions. Are you forecasting a future to 2041 for US Ignite? Is there going to be a need for what you're doing then, or what do you see?
I think that's another excellent question. I think that there is always a room for the discovery process to improve the lives of Americans. And by putting US Ignite squarely in that path and saying, we're going to pick up where the National Science Foundation leaves off, and we're going to try to provide value to the citizenry at large, I think that that's an area which will always be ripe for innovation and development, and being able to work with communities like Syracuse and like the University of Syracuse in interesting and innovative ways that are going to pay off for everybody in the long run. So that's an easy one. US Ignite is the kind of gap filler that helps academia and industry work better together and to really serve the needs of the people.
Okay, well, that's a great closing line. Thanks so much, Glenn, and thanks for joining us.
It's been my privilege.
So we're going cold open to the next panel. Right on, now we need to set the agenda. Glenn's laid out a future that perhaps looks pretty good to me, but can we get there? So we have a great panelists, but we also have, because we have such great panels, they get pulled like by their bosses or customers or something. So we've lost two of them, but that's, and what a shock. It's VMware and Intel that have clients that demand their attention. So we can move right, but I think we have Mark Phillips. Is Mark Phillips here with us? No? Oh, now we're down to the three. Okay, so we have who's on the panel that's here?
We have Scott, Eric, and Matt.
Oh, Scott, okay. Eric, okay, so Eric, well, first, that's a great time then to bring in Eric Pinos. Eric Pinos is one of those who inspired or encouraged this workshop. He is the president and founder of the Blockchain Education Network, spun out from the MIT Digital Currency Initiative that I also tried to get to participate in this event, but they're a little busy working with the Federal Reserve Bank on their work on digital currencies. Eric, so why don't we let you take the floor a little bit, because you've been great in inspiring students at many different campuses. Could you help start off the panel and talk about like what do you see as a future education and innovation agenda? And are you live from Puerto Rico or where are you?
Yeah, thanks for the intros. Can everyone hear me?
Yep.
Okay. Yes, I am live from Puerto Rico, where I've been for the past couple of weeks since coming back down. I moved here in May. Before that, I was living in New Jersey. And then before that, I was in Boston, right? That's where I was for school when I was at MIT. I was part of the MIT Bitcoin Club. I was part of the MIT Digital Currency Initiative, and the Blockchain Education Network as an intercollegiate network between all of the different universities. So I've seen a lot of things change, and I've seen the environment change over the time. So Ben started this short for Blockchain Education Network. That started back in 2014. So seeing it over the years, initially it was very much peer-to-peer, student-to-student education, because a lot of the school administrations were they weren't catching on to like what crypto was yet. Like there was no blockchain classes, there's no blockchain courses. At the most, there were clubs. But now, fast forward to today, I think we've seen a lot more classes, even for college credit. We've seen faculty embrace it. We've seen more research projects. I've met a lot of like grad students and PhD students that are writing their dissertations in blockchain and doing blockchain research. And this is taking place all over the world, in Europe, in Africa, and India, and the US, and Canada, and Australia, and China. And me, I'm focusing a lot in Latin America now that I'm down here. there's a lot of incentives for cryptocurrency people to move to Puerto Rico. And so it's been interesting to see the desire to want to hire talent from Latin America and from Puerto Rico. The other trend that I wanted to mention is, the trend of remote work. I think that we're kind of seeing that a lot of companies now, they're leaving San Francisco, they're leaving Silicon Valley, but they're still looking for talent, and they're looking for talent on a global scale. Like, where can I hire someone anywhere in the world, as long as they can do the job? Doesn't matter if they're remote, they don't even have to be full-time. And I think that represents a very interesting opportunity for, especially for students and recent graduates, to adapt and to, and it works out great for people that live in like less economically developed regions, because they can get those jobs. They can work entirely from their laptop, do these jobs on the internet. And so that's a big trend that we've been seeing and trying to help accelerate.
Okay, thanks. And what was the next panel? Sarah?
Scott,
Scott, you're with us again. I really appreciate your comments always. So I wanted to gave you extra duty here to follow in. So can you follow on with some of what you would see as major trends or issues for the future, whether it's 5 years from now or 40 years from now, whatever I don't know if 40 years from now is your time frame usually, but could you say a little bit from your personal and now Inca Digital perspective? And actually, so far, you haven't said anything about what Inca Digital does, so maybe this is a soft opening for you to say a little bit more. And we thank you for your sponsorship of this event.
Oh, my pleasure. And I'll come back to the Inca stuff in a bit, but I wanted to toss out a few things that I wrote to myself as I was listening to Glenn's really interesting talk. And his thinking really resonates with me, because one of the things I read a long time ago was a book that was written as the Soviet Union broke up. And it was written by a couple of folks that came out of the Shell Strategic Analysis Group that looks decades ahead and so on. And they wrote a book called Russia 2010, I think, or 2020. And it's turned out to be surprisingly prescient. They did not try and predict this or that. They tried to say what'll happen in 25 years plus in Russia will likely end up along some of these routes, some of these checkpoints, whatever you want to call it. And so thinking forward in some structured ways is always a good thing. But I wrote down to myself 3 questions in listening to Glenn's talk. One was, if cybersecurity is going to remain a continuing problem, I wrote to myself, what does policing actually look like in 2041? Because we still, for the most part today, have policing that looks a lot like it did in the Al Capone days. And my guess is that if we think more aggressively and thoughtfully and judiciously and so on, policing may look very, very different in a democracy like the United States. And it's worth asking that question. And will we see innovation organizationally around what we call policing? And will that do better things? Because I would argue that maybe we have not done enough creative innovation around the function of policing over the last 30 or 40 years. And maybe that's one of the things that's badly needed. So what does policing look like, and how does that play into all of the things that Glenn laid out, for example? The second, there are probably some people in this discussion and so on that are fans of the book that came in as sort of a bad movie, but the book Ready Player One. And the precept of that writing is that the world keeps getting worse in day-to-day reality, but people are all playing games off on their personal life, and that's taking over society in some ways. And there may be some truth to that when you look at the popularity of gaming and everything else. But what if you proposed or thought of some different things? What would digital twins as widespread tools look like in 2041? And what might be some of the beneficial things to that? And can we educate people through digital twinning? And can we learn that way? And can we think of far more positive ideas around the uses of wide-scale digital twinning to complement a lot of the things that Glenn brought up? And then the third thing that ran through my mind that I was thinking about and wanted to put down as a note was, there will be something that will happen that will provide a medium and maybe even a large set of disconnects and breaks and whoop, not so fast or whatever in that linear expectation of advancement and possibility and need. just in my professional lifetime, we've seen the Soviet breakup, we've seen the rise of China. 9/11 was a pretty big deal. For my parents and grandparents, World War II was massive. Well, what might happen in 5 years, in 10 years, in 20 years? And that could be a massive climate change that happens quickly, not slowly. It could be what I would call a serious biological event. I personally don't think COVID is serious. Truthfully, I honestly believe we're, in a system sense, overreacting more than we need to. But what if you had a really bad one, in my opinion? What if a nuclear detonation happens somewhere in the world? What if a financial system breaks to the extent that it causes a Great Depression? So there are possible disconnects, and thinking through something out to 2041, you want to ask yourself, what if, what could really scramble these otherwise sort of natural linear projections of things? So those are the things that ran through my mind that I wanted to toss into the mix around this Life in 2041 conversation that Glenn did a really great job of laying out and sort of expanding our thinking.
Great.
We're also joined by Mate.
Yeah. So we're taking perspectives from all around the world, and we're privileged to have Mate Alil from the Democratic Republic of Congo and IMCON with us. Mate, do you have something to share on what you see from where you are at? And well, first let me just say Eric Pinos's comment on remote work and opportunities in the new economy. Mate's been like one of the secret sauce engine for IMCON from its before its founding even. So we appreciate your work and contributions to the Internet Backpack. And now speak up and tell us what you think for the future, Mate.
So give him 5 minutes.
Say again?
5 minutes. He might be
He's
configuring his system.
Okay. All right. So so let me circle back then to okay. Well, I hinted to Lan that I was going to pull her in because she has a new organization, Cyber Trust America, that probably just a few of us know about. That is, I think. Well, let me let Lan say, what does she think the future holds for us? Lan?
Thank you, Lee. I wouldn't say new organization yet because it has grown from an older nonprofit, Adaptable Security Corp. That is 5 years old now already. So like Glenn put forward trust, we also felt that is going to be a fundamental piece that will provide the foundation for the society's peace going forward. So and also it's easier for the mainstream people to understand. So that's the name change from Adaptable Security Corp to Cyber Trust America. And one thing also related to Glenn's sharing, I think the consensus is getting there about the mainstream and the people in power needed to coordinate and collaborate a lot more than before. As Glenn also mentioned, technologies are indeed a double-edged sword, and we have seen both the tremendous benefits, but as well as the other negative or not so ideal side edge of the sword, which is that some people have been pushed down even further on the wrong side of the digital divide, for example. And so, and cybersecurity could also be fitting right in there as we, as a society, try to bring more people, historically disadvantaged populations, onto the right side of that divide. So in terms of setting the agenda, I think the next decade or so, what will, in a way, determine whether we as a society will succeed in maximizing the benefits of all this digital revolution, including the latest emerging technologies and all, is that there needs to be a bit more consideration into adoption. We are great at innovating, putting the newest shiny things on the map. But in terms of the impact it plays on the society, and who's going to stay there to hold the bag together, and help the populations not on the bandwagon yet to get along before they're permanently left behind and creating potentially a seed for unrest. I think that needs to be addressed before it gets to that point. And that, in my book also, the government needs to take a leadership role. And I say that based on what we as a nonprofit we have observed by working with different sectors in the past couple of years, especially since COVID-19. So to come back a bit to what Cyber Trust America does, we have done two things in the past year or so. One is that we help the local governments to collaborate closer in terms of beefing up cybersecurity. And so that it's not siloed and they can put their limited resources to achieve better and more cost beneficial results sooner. So that's one. And the other one is to bring up small and medium-sized businesses also into the digital world. And in doing that, I have observed that while the private sector companies, a lot of them wanted to help, they even put out a lot of effort to help, setting up nonprofits, etc., to help, but it's not the same. There's still quite a big gap between what they offer and what the small businesses actually need. And that gap can only be bridged by local governments taking up a leadership role and convening, using their convening power to invite everybody into at the table, and then the resources could be leveraged to its fullest effect. So I'll pause at that, Lee. Thank you.
Thank you, Lynn. And I of course, we've been working with adaptable security before it became Cyber Trust America. So we could say it's a shiny new label, but it's really, I think it's a broadening of the mission to national scope after the groundbreaking work you've been doing in Silicon Valley and in cooperation with NIST. So I want to pull, if Mate's not, is he with us? Okay, all right. So we'll give one more new perspective, new agenda. Mate Alil, now live from Goma, and we hope the volcano there has calmed down of late. Mate.
Yeah, thank you, Dr. Lee, for the floor. I'm speaking from Goma. Very happy to be here. I've been watching this since my afternoon around 2 p.m. Now it's 9 p.m. No, it's 10 p.m. right now. So that's why at a certain moment I was not corrected, but I was listening. So as soon as you said that to me, then I came back to the home office. So I'm very happy to be here. I really appreciated all the themes that were developed. I watched the demo from the students and the panel. It was great. I really appreciate it. I think we have to apply these technologies that we are building on the people on this earth who do not have good internet connection, because there are many challenges that we can fix with this, especially with decentralization. I think this is a great tool that will help to empower many people in this world to have access to currency, to have access to trade, and to many other activity and connection. So this is what we basically do with the Internet Backpack, because as I was presented, I work with IMCON International. We try to connect people who do not have access to the internet through a microgrid technology. So I was in Liberia 2 years ago to install with President Ellen Sirleaf. It was a great experience to have these children and kids at school to be connected to the other in New York and to talk about technology. I've been also teaching some lessons through One Planet Education Network about IoT and other DIY lessons. So it's a great privilege for me to be here and to encourage that apart from the fact that we are working on this high-end world, talking about technology, to also consider other countries which do not have the high-end infrastructure and see how we can bring to them the technology so that they can also participate in what is being built. So thank you very much for this opportunity and for Syracuse University to have this conference.
Thank you, Mate. Okay, so I wanted to move to a second question. Do you want to get into the question? Go ahead. Just come on up and so people can hear you.
Upon listening to all three of you, or all four of you, especially Scott and Lan, for Scott essentially queried at the end of his statement is like kind of like, how can these digital twins be implemented and truly what use cases and the application of for 2041. And I think that bridging the digital gap, which Lan was speaking on, is so incredibly important. And I think that digital twins could truly be that tool to do so and to optimize technologies like blockchains, because they provide the ability for us to real world simulate, right? So we can have these really, really exact simulations. So before wasting, and for environmental and sustainability, before wasting resources, manpower, we are able to run, really complex and accurate simulations. And so hopefully that can potentially, it's not just a physical object that we can make a digital twin of, but a process, right? So, rolling out, trying to, expand and bridge these gaps. I think, digital twins could be a great solution for that. And I think that the only way that blockchain is going to survive, in the world is if we're not trying to improve something that's not sustainable, but that it needs to be inherently sustainable, that the solutions coming out of it, and all technology solutions, because if our physical world is crumbling, then what's the, no one's going to care about the digital world. So, I think that we need to be thinking about innovating in a different way than we think about it. And Lam was kind of talking about this, capitalistic, that there's this gap between, what people need and what people are, putting out. And I think, in the speak about 2041, it was that capitalism fuels innovation, but, it's a double-edged sword, right? So we need to kind of take that incentive that capitalism has, but it should be for, needs to be for we should be incentivized not just by money, but by actually being able to, connect these people and help, because.
Okay, so great points. I'm not sure if you actually had a question, but you made some.
It wasn't a question. I was just trying to comment on that.
That was fantastic, Catherine. Thank you so much. Yeah, so we have one more pulled in from this broader community that's been working on thinking about transformative education and innovation and technology and AI and VR and AR, who's literally got alchemy in his blood. Johnny Rinelli is live from New York City now. John, can you join us and say a little bit about what you see for the future, since you're got the lab with the third graders doing some of the coolest stuff on the planet, including dealing with mate in the Congo. Are you there, Johnny? Is he? I moved him up the panel.
I'm here.
Yeah. Okay, John. So I tried to, well, first, if you could just say a little bit about like where you're coming from, because we know you and Mate knows you, but not everybody else knows you.
Sure. Sorry, I will just sorry, I didn't expect this, but this is so awesome, Dr. Lee. Well, God, I think of it this way. I'm listening to all of this high level stuff. Me being a STEM learning scientist, my thing has always been, well, how do we make this palatable and take it to the education system where you can practically take all this high level stuff we're talking about here and take it to the kids in the classroom, especially in the largest school system in the nation. I am a STEM researcher in the New York City Board of Education, and Dr. Lee and I and others from MCON and Open and other entities, we have actually mapped out a plan to bring IoT and AI, machine learning, deep learning, cryptocurrency to the system. I do believe that's one way to deal with this digital divide, because the area where I am working, I have the Alchemist Club Studios. We are practically in the South Bronx. And if anyone knows New York City, you know, when you're talking about social economic deprivation, you don't get lower than that. So I've been able for over 2 decades to build a lab there where I'm able to get kids, practically, they have the latent potential to be anything they would want to be in life, but they don't have exposure to that kind of knowledge base. And I crafted this lab from scratch. And now we have some of the members who passed through my hand from pre-K all the way to high school. I continue to guide them through the process. Some of these alchemists, they end up at MIT, like Dr. Lee was a serious person there, and we have them all over in Ivy League institutions and everywhere else. So my thing here, as I'm listening to you all, I'm just learning and finding a way, as you passing this high level knowledge, find a way to take all that information, that knowledge, and bring it down to the level where it's palatable and it can be enacted in real classroom settings. So in that way, it's not just the theoretical thing that only a few of us who are cerebral genius happen to be able to make it through it, but the general population and learners all over the world can have access to it. So all I'm doing is providing a portal for that to happen. And that's the work I'm working on with Dr. Lee and other brave maverick educators. And Dr. Lee, thank you for giving me the opportunity to just articulate those few words. Thank you.
Yeah, thank you, Dr. Johnny, as he's known. You're being far too modest for a guy with a PhD, whose work we have just been publishing, and we will be presenting at conferences in the coming weeks. You've done some really amazing work with amazing partners, which you didn't give advertisement for, but we won't say more. But it's really incredible to see and super inspiring to see third graders in the South Bronx doing amazing things if they just have access to some IoT sensor kits or machine learning or AR headsets or internet backpack too. Okay, so let's go around without keeping things moving. We have some vision and optimism for the future, but there's going to be some challenges along the way. Scott, what are you worrying about? What do you see as the largest challenges to impede us from getting from here to there going forward, whether from a technical perspective or again from these broader societal issues that we're challenged? Also speaking about
let me speak to that from an Inca perspective. Can I share my screen?
Sure.
You able to see it?
Yeah.
Yes. Again, just a few summary things so people know the background I'm coming from. We sort of think of ourselves as a Bloomberg Palantir, if you will, for the digital currency space. So we're doing a lot of data analytics on the back end, architectural things to make sure the platform's as strong as possible. We work with a bunch of data, a bunch of technical blockchain data, and we're doing a lot of fascinating work applying natural language processing to all of this. And we work with an interesting mix of both commercial and governmental customers, and we sort of think of the regulators in between, because the regulators, you know, have one foot in the commercial world and one foot in the governmental perspective and so on. But that's what leads me to this summary. You know, the fintech world, and we're a part of that, you know, is a steadily growing part of the massive world that is financial systems worldwide. The estimates I've seen are $750+ trillion. And so if digital currencies and other fintech elements are 2, 3, 4, 5% of that, whatever sort of metric you take, whether you look at what the big existing historical companies are investing internally or some of the small startups that are raising funds and so on, you know, it's a big area of business and growing and going to grow pretty steadily. What we're looking at Inca is stuff that is applicable to commercial purposes, what the financial world needs to know and wants to know in this innovation area that's going to influence their world going forward and so forth. Obviously, there's a huge challenge and area of interest around what regulators want to know and want to follow and want to see. And again, it's fascinating to see that the individual that taught, you know, one of the better courses at MIT a few years ago on all of these digital currency questions is now the chairman of the Securities and Exchange Commission. And so it's, you know, very good to have somebody, not just old school quality, if you will, but somebody who is up to speed on everything happening currently in all these spaces as the government looks at what to do and drive in a regulatory sense and so on. And then a lot of the work that I do at Inca, of course, is around the governmental stuff. And that's element of just mainstream financial operations that people are looking at how to do it. You know, there's technology and solicitations coming out of places like GSA and other parts of the government that you might not think of, looking at either digital currency questions or blockchain engineering applications underneath it or both. Obviously, there's a huge area of intelligence, and most of this is open source intelligence or OSINT. A lot of the stuff that we track and look at is freely available. It's a question of who understands what to look for and how to put it together and stuff like that. The military is looking at this. There's the old heuristic they use called DIME, which stands for diplomatic things, informational things, military things, and economic things. And because you're seeing lots of growing governmental areas of cryptocurrency and digital currency questions, the military is trying to understand and anticipate that and have that be a factor in how they plan and do their looking to the future and so on. And then obviously there's a lot of interest as we speak around the correlation, the connections between ransomware and its success and digital currency and you know, blockchain and digital currency payments and all those sorts of things, or Bitcoin and digital currency payments and all those sorts of things. And that's a huge area of interest right now for major customers that we work with. There's a massive number of use cases, near term and longer term. That's a big part of what we wrestle with, is understanding the tech, but then understanding our customers and figuring out what are their pain points now and where can we do a demonstration, where can we do something for them and so on. And that's an area that sort of connects a Syracuse and its research community with a Syracuse and its business student community, and people understanding what business customers, governmental, but especially commercial, are looking for, and use cases, just like the old learning technique of looking at case study analysis for business purposes, with use cases and all this are central to understanding clearly what innovation can do and where and how to do it. A lot of what we wrestle with is tied around investigations, whether that's a law enforcement supporting investigation or simply an analytical investigation to understand a question that a financial customer is asking, or a governmental or a regulatory customer is asking. And so we're early in the game of understanding how to do a thorough, a conclusive, and operationally actionable investigation. And that's something that's really a big part of what we do internally and are thinking about and doing. And then underlying all that is the blockchain engineering questions. I'm also in the middle of getting started on a major project for a DoD organization. I won't say much more than that, but what they're asking for is systems level mapping What does this look like in lightweight, thin, what they call austere environments? And you can sort of guess where that might be of interest. But they are also asking about digital currency and underlying blockchain engineering questions and critical infrastructure systems and analysis. And those are multiple sectors. It's not just the financial sector, it's the energy sector and how to pay for it. And one of the fascinating things, I've worked with the GCTC and the smart city community quite a bit, and I do not ever want to drop that work and interest and support capability. But I find myself now thinking about the question of micropayments and how might payment systems be an underlying foundational element of the different elements of smart city applications and capabilities. I found it interesting that in Glenn's talk, he didn't actually lay down, at least not that clearly to me, or maybe I missed it, the financial flow model of how that might enable and support and might be needed to supply and address all those different technical areas he talked about. And the other part of the DoD project, sort of conjecture who we might be doing it for, but we're looking near term as well as long term. And that's an interesting question in a space that is this fast moving, this dynamic, is how do we do applied research that is valuable to the customer, that comes up with actionable insights and technology for the now, and for 2 or 3 years from now, and for 5, 8, 10 years from now, and something that looks at all 3 of those timeframes in a relatively open-ended way. So I just wanted to make sure people had a sense of what the applied research challenge looked like from a commercial perspective at Inca Digital. And I'll close down the sharing thing here and return the floor back to.
Thanks, Scott. That was very helpful. So it gave a very both practical, real world, this is what you're doing today, but also challenges for the future. Eric, I wanted to follow up with you and do a little bit of a contrast and maybe set you in opposition to our prior esteemed speaker, Glenn Ricart. So Glenn made perhaps a depressing forecast that the 80-20 rule, which some of you understand, will still rule. And in 20 years, as opposed to the hundreds and thousands of new startups, young companies, new cryptocurrencies, we're going to end up with a system in which 4 or 5 notary giants control, I don't know, the whole world, but this whole space. On the other hand, you're down in Puerto Rico and you're saying, I'm bringing in, talented developers from Latin America, blockchain projects from around the world, things, I moved to Puerto Rico because I can get a better deal than being in a more central location for blockchain developers. I know there is actually specific reasons and things going on in Puerto Rico that make it a financial or tax attractive location for your work too, but we don't need to go into that. So are you in past waves of innovation? There were many competitive local exchange carriers, or CLEX. David Montanaro here in the front row knows what I'm saying. And they all got killed by the Supreme Court and the courts, and they all died pretty much. And we end up with our lovely, wonderful ATT and Verizon, and now T-Mobile that just gave away 100 million people's records to hackers. Right. Okay. So there is certain risk to this centralized future that Glenn is predicting. Eric, over to you. What do you think? How do you see things balancing out over the decades?
Yeah, well, I think there is a balance. I mean, like you said, and like Glenn said, there's always a trend towards decentralization, which is interesting because this technology is supposed to be about decentralization. But we see now, even now, the early stages of application-wise, most people kind of coming back to just using Coinbase or Robinhood. Robinhood now accepts crypto. Venmo accepts crypto. PayPal accepts crypto. So for most people, that's enough. Like I just buy my Bitcoin on Robinhood, I sell it on Robinhood, and that's it. But that doesn't even touch the potential of what the cryptocurrencies can do and what blockchain can do. So I think that on the technology side, I do see crypto as more of like a back-end tool. Like I think what we'll see is like applications that exist today and new startups that exist, that will be starting up, will adopt the technology and use the technology to provide a better service to users. Because there is, most people aren't going to be managing their own private keys. Like, I don't think that that's going to be the case. Like, if it was the case where everyone can manage their own private keys, we'd all be running our own email servers too, but we don't. Like everyone uses Gmail. So I do think, yeah, on the company side, there's going to be a centralization level. But I think the balance, or at least the good news, is that on the accessibility and in terms of like people being able to make wealth for themselves, or like to get like jobs and to, you know, create like economic prosperity, that's definitely becoming decentralized, because even the big companies are decentralizing their workforce, right? Like they're not hiring, move to get this job, move to New York or move to San Francisco. So, okay, wherever you are, you can stay there. You work for a big company, and then the person who lives in a third world country or wherever they're from, they can earn like a first world salary, and then that, as more and more of the community members start getting that kind of income, that can change the entire city, right? And I think that I see that as a good thing. And even though the tech kind of just comes back down to like one or two big competitors, there's always like the biggest company that almost has like a monopoly, and then there's the best alternative. And then if the biggest company gets too big, then the government comes in and breaks it up, like trust busting or like monopoly busting. So I don't really like know too much or can say too much on like how I think that future can change. But I know that on the people side, like and the talent side, that people, you know, it's not like these companies are just going to be walled off within the US and only people in the US are going to be able to experience this, or like say companies in Japan or companies in China, as China becomes more of like a world superpower, it doesn't get limited to just gated in terms of the opportunities for people. I think that kind of gets decentralized, that people from anywhere will be able to work for any company anywhere. And I think at least that's one positive part of this future.
Minutes. I want to keep on schedule with Mate having another chance. Mate, what do you see as the challenges? There's so many in where you're living in Goma. So again, I hope the post-earthquake and the volcano eruption recovery, which is just from a few months ago. So just to say that that's a very difficult situation. Are you back? You're back in Goma now?
Yeah, I'm back in Goma since about 2 months.
Okay, all right. Well, so leaving, well, not leaving your present circumstances alone, but what can you see as the challenges going forward?
Well, the challenges, I mean, we have many challenges here, but talking about the trust of the information, I will quote George, who was talking about sharing information with the population in case of the eruption, because it's kind of sensitive information, which is not to be shared with the public. But if we can have this trusted authority that we can set up with the blockchain, and which can be trustworthy as for the information to give to people, that will be a solution to what we had. Because, you know, apart from the technical issues that the Goma Volcano Observatory had, we also had the issue of fake news, and also the means of communication with the population. There is still traditional analog radio stations, and you know, it was very difficult for the population to get the information. SMS could be better, instead of just going to the radio and trying to inform people where they should go. We had those propositions in the past with the Internet Backpack that people should use the application that we provide. But you know, with this process of validation and all, we're not able to provide that solution. So I think it is very important and very urgent that the country and our administration get to adopting solutions like that, but also think about all the solutions which can work online and offline, because it is very important, as we do not have a larger internet coverage over the Democratic Republic of Congo and many other developing economies. So it is very important that we adapt to what we build to this situation. So I know that we are at a certain level of progress about all these technologies, but I think there is something that is missing, and that thing is to adapt to what we have, the trust, the trust method that we have even on the blockchain, to have it, to make it possible to work in an environment where there's no internet connection and where there is internet connection. I think, and that is a big challenge, which might take time to overcome. But I think if we have a solution like that, it will be very helpful for the people and for the society in which we are.
Okay, well, that was very well said, Mate, laying out. So we've covered a wide range of the planet, the US and far beyond. We're right at 4:29, but I'll call it 4:30 since the clock will flip over in a second. So apologies to Lan and Dr. Johnny that we're not going to be able to go back to you again on the challenges. I think you all know, and we've been interacting with you on those challenges as well. I think this has been a fantastic roundtable, following on from Professor Ricart's excellent presentations, laying out some of the challenges and the agenda for the future. So now I thought I would be giving closing remarks and thanks, and then we would have another whole day together for some of us and some remote things. And you know what? We all are living in an extreme environment now. We all are living in uncertain times, and this pandemic is not over. And if it wasn't the pandemic, it could be the wildfires in California, or it could be floods in Europe, or it could be something else. So I think we should all recognize that our future is not knowable right now, but we can, by working together collaboratively, learning from each other, we can try to make all of the world a better place over time. So for ourselves here at Syracuse University, we want to thank everybody for your time and attention, but you can't go away yet because there's something more coming in just a few minutes about where the world will be going next in an area of technology that we haven't spoken about so much yet. But before we get to that, I'll just say here again, on behalf of the host committee, the organizing committee, the student committee, everyone at Syracuse University, we really thank you for your participation, your willingness to take time out of your busy and pandemic lives to engage in this conversation and advance research. We will be continuing our work, and I'll highlight again the two student clubs, YTech, Worldwide Innovation, Technology and Entrepreneurship Club, and the brand new Crypto Q's Club. And like everything else you do, you may have noticed a pattern where we put all the load on Catherine Forrest, who's the president of not one, but two student clubs. She'll get the chance to say a few more words before we go. I want to give a special thanks for Abdullah, who's had his life taken over by this workshop. Fantastic job. We've gotten in the habit of saying, no matter what happened, no worries, no problem. We get through it. We've gotten through everything over the course of a day and a half. Now, speaking about where this work all goes, you might have noticed that the Journal of the British Blockchain Association, on which I'm on an editorial board, showed up here. You might have noticed several research papers being presented here with people saying, yeah, keep going, take it further, trying to get our fantastic doctoral students like Rand and Ariel here in the room with us encouraged. But Tanya, even though she has a day job literally with the United Nations Security Council, we managed to keep her intellectually engaged enough with us that she'll continue, hopefully, and take her work forward. So there's quite a bit of the work here in terms of the papers and presentations that were given that we hope to be taking forward to journal submission in a variety of different academic journals. But there's also work. Is Mike Maloney still here with us? Yeah, I don't know if he is, but the data point that Mike dropped yesterday, that the Bitcoin mining sort of basically improved its energy efficiency by 50% in 45 days. is a pretty amazing statistic that I don't think the popular media or policymakers really understand or appreciate. So while we may be concerned about the environmental impact, if it's something that can be changed that radically in that short a time without regulation or policy intervention, that would be kind of be making the point of Professor Schramm and his keynote yesterday. So, so just want to highlight and thank all the speakers and the participants and all of our sponsors, CoinMint, SIMBA Chain, Inca Digital, Upstate Interactive, VMware, Renee Crown University Honors Program, and the Dean's Office, especially here at the iSchool, that's made this whole event possible. And because I wanted to make sure not to step on time for what comes next, I'm actually going to give our next and closing act, the surprise non-fungible ending, NFTing blank. We're going to fill in the blank starting at 4:34, not 4:35. And so please come on up, Anjan Roy from SIMBA Chain, Catherine Forrest from CryptoQs and YTech, and David Montanaro, friend of Syracuse University and innovator. Thank you.
First, who's going to go first?
Oh, the slides.
Yeah, I think we have a video first.
Okay.
Oh no, slides.
The slides, yeah. David's first one.
Yes.
Center.
Great. This is a very timely opportunity for me to share with you an amazing story that goes back almost 45 years, when me and a business partner of mine with a company I started at a very young age myself, traveled to San Francisco to attend the first West Coast Computer Fair in April of 1977. And while we were there negotiating with some companies for the company that I was there for, he interrupted and said, by the way, we'll have to finish this conversation later because I have to get to the computer show, which is the last day, and maybe we could meet you there. So that wasn't part of our plan, but thought it was pretty interesting to see what was going on at the computer fair. So we went over there. It was at Brooks Hall in San Francisco, and as soon as we came through the front doors of the hall, just a few steps in, here was Steve Jobs and Steve Wozniak at a small booth at the computer fair, where they unveiled the first real Apple computer, the Apple II. And little did I realize, because I, since my young 20s, have collected business cards, and I continue to do so all my life. I literally have probably 2,000 cards that I've collected from many people, with some pretty amazing cards, but none was ever as amazing as the fact that after we had a demonstration of the Apple II computer, and after we had some pretty amazing discussions with Steve Jobs about Apple, how they got started, and we were able to, my partner was kind of pulling me away because he wasn't very technical, but I'm a tech geek. And I really got into what Steve Jobs was doing, what he was showing us. So as we ended the conversations, to move on to see the rest of the show, of course, I asked to exchange business cards. And but lo and behold, they only printed a small number of cards because they just moved out of their garage, and they moved into a small office a mile or so away from his parents' home. And he said he didn't have any. He had given them away. And that's understandable because it was the afternoon of the last day of this computer fair. But I guess I had enough of an interesting conversation with him that he reached into his pocket, which, by the way, was the first suit he ever owned for that show, and pulled out his last card. And to my knowledge, looking at everything that's out there, I haven't seen anything that's been offered or in circulation for that card. And I think it's the most iconic card I've ever collected in my life. Looking back now, 45 years of being able to have that opportunity to meet both Steve and his partner, Steve Wozniak. And by the way, Steve, just a few months before that computer show, turned 20 years old. There's the picture of us, them, as we remembered them in front of the exhibit booth there in April of 1977. So that was kind of, a piece of history. And I've held on to that card for all this time. And although I could have had opportunities to maybe sell that, give it to somebody, trade it, I kept it. And I'm glad I did, because working with the great people here with Syracuse University, and you're going to hear from SIMBA Chain and Catherine, I've had the pleasure of being able to work with them to launch this as an NFT. I think this is about an iconic card that you can possibly get. I think it's at the level of sports trading cards that are being offered as NFTs that are going for a lot of money these days. So I'm excited about this. I've been involved in following blockchain for ever since it happened 12 years ago. Worked with startup companies, supported them that are using blockchain technologies, developing applications, and obviously now, going into cryptocurrencies and NFTs. I just felt that the timing is really great to work with some very knowledgeable, smart people to guide me on the best way to sell such a valuable, iconic, collectible item. So I thank Lee McKnight for supporting this opportunity to work together. I got to know Lee for a number of years and have been there to work with him and support him on the what he's been doing with the students at the blockchain courses that he now runs since 2017. So I think this is the time to share it with the world, because there's a story behind the card, how it happened, especially when you look back 45 years later. And I looked at this card over the years as it went from two young guys, that looked like they were just running a science project of something that my partner thought would never go anywhere, right? So, but that's not the story, right? So I think this is an exciting, process of positioning this thing in the right way, and I'm passionate about this now because when Steve Jobs passed away, I had an emotional connection to him. He died of pancreatic cancer at a very young age, 56 years old. And since then, I've lost family and friends to cancer, particularly a few from pancreatic cancer and brain cancer. So a portion of the monies that get raised through hopefully a successful launch of the NFT is going to be contributed to the pancreatic cancer research efforts. And I'm very happy to be able to do that, to share, the distribution of whatever we are able to get. So that's what I wanted to have the opportunity to share with you. It's a piece of history. There's billions of people out there that love their Apple devices and products. Right? He did change the world. And he's been written up in biographies. I've read every biography, watched every DVD and movie, all newspaper articles, magazines. I've got a file 3 inches thick of all the things that I've collected over the years. So I think that this will be an interesting thing for people that have, followed Steve Jobs, and the people that can't wait for the next product announcement of Apple. And
Thanks, David.
Yeah.
And in keeping with this strict timing,
Right.
want to keep for this amazing announcement and sharing this with the group. Catherine, you go for or Sim. Okay, Anjan will take Anjan Roy and SIMBA Chain that's working with David and the university. Go ahead.
Thank you, and thank you, David. Thank you, Lee, Catherine, the Syracuse community. It's an honor for SIMBA to be part of this effort, partnering with you on this amazing initiative. So just a few things on when we spoke and why we thought it was a great idea to come together that really matched with our values and I think the spirit of what we're what we're going to be auctioning off. First off, we are going to be as far as the blockchain network, we're going to be minting this on the Avalanche blockchain network because of the environmental and the emissions efficiency and cost efficiencies they bring to the table, particularly on the energy side, versus other networks that NFTs tend to get minted on. And we know that Steve Jobs had a history of caring about the environment, and I think that's a consideration that our industry should take seriously. And so we can mint on a network where the emissions are far more favorable. Number two, payment optionality. We'll be able to, you don't have to have a cryptocurrency wallet to be able to participate in this. We believe there should be as broadest participation as possible. So we will be able to accept mainstream payment mechanisms like dollars and through Stripe and credit cards to be able to bid on this. Certainly mainstream payment mechanisms, the specifics we'll still get into, but you don't need a cryptocurrency wallet as a prerequisite because we want this to be open to everybody. And that's very much within the spirit of what we're auctioning off. And then finally, really thinking ahead in terms of sustainability on the security side, and this starts to get pretty technical, but the summary of it is we're going to take an image of the digital image, we're going to store a cryptographic hash of that into the NFT, and then we're going to take the NFT metadata, deploy that onto the smart contract, and that will go on chain, giving both the image and the NFT itself, the metadata, far more irrefutability than what, again, you see much of what being minted out, in the industry these days. And so all of that we believe is in the spirit of and the values that David, you bring to the table, and also with what we're auctioning off. So again, it's an honor for us to be a part of it. We are also negotiating with and taking inquiries from auction houses who'd like to partner with us. But we are honored to be the technical partner in this effort. So thank you all.
Thank you so much, Anjan and Catherine.
Thank you so much to David and Anjan and SIMBA Chain. It's been an absolute joy and privilege working with them thus far. I would, like to share with you all that in connection with, the ideals of Steve Jobs and Apple. We are going to be we have already begun the development of the AR augmented reality NFT of the Steve Jobs rookie card. So using their AR kit, object capture and photogrammetry in their new AR kit. We have developed a prototype that we are going to be sharing with you today. Go to the next one, or next slide. So here you can see a high quality image, and we encourage you all to take out your phones and type in this URL, www.stevejobsrookiecardnft.com, and you can personally experience the first prototype of the AR NFT. I'm going to share. It may take a little bit to download, or not download, but to register on your Apple devices. This is also only compatible with iOS, but I will be sharing it from a version of it from my phone now. Can you give me host abilities? So it takes a little bit for it to capture. If we hit the object first, I can just show you. So this is a prototype, and there is more than this card right now that meets the eye, as you can see, because there's obviously one important component that's missing, which is the other side of the card, which we will reveal information on later in the future. Incredibly exciting information. As you can see, just this basic prototype, you're able to see just all the exact creases in the card. And you know, all of its components, making it just feel so real, in addition to being able to place it. There we go. So we can put it, here you go, Lee.
There you go. Thank you very much.
Yeah. And so it just makes the experience of the entire card so much more enjoyable. It is really a fantastic feature, and nobody out there is doing it right now. So we are incredibly excited to share this with you, and so happy that YTech and CryptoQs can be a part of this amazing project. David.
So a couple of interesting points on the card. There's no cell phone number on the card. There's no website. There's no email address. Just the first office a few miles from his home. So we've been able to go through the authentication process about the originality of the card. If you call the number on that card 45 years later, it's still answered by Apple corporate. Even though they've changed their numbers over the years, they still answer that same phone number on that card. I find that kind of an interesting thing. There's going to be a lot more to the story that we're going to be sharing prior to the NFT launch. Thank you.
Thank you all.
Any final thoughts?
Oh, well, again, this concludes with our surprise ending. We promised a surprise non-fungible ending. I think that's a surprise for many of you. There'll be more to hear about all of that, and much more to do on the research side. And it's so wonderful that Syracuse University students have such experiential participatory learning experiences as we're able to provide here in this context. So thanks again to all of you for your time and attention. And we're usually at the end of academic meetings, if you're able to give a few minutes back, you say, well, I'm giving you back 10 minutes of your life. Even though we ran about 5 or 10 minutes over here, I'm giving you back a day of your life. So now you all owe me a day. So I'm going to be, when I follow up and ask you to do something for you, you'll remember, I say, hey, you owe me. So thanks very much for all of you. We'll look forward to seeing you next year for the second Syracuse Blockchain and Cryptocurrency Research Workshop. Thanks again.